office space style progress bar. All right. We are live.
Live?
Okay, we are streaming on YouTube and I hit broadcast, so attendees are starting to show up. Hello, attendees.
Hello, everyone, and welcome to EightKB. We will be getting started in about 4 or 5 minutes, so we'll wait for everyone to join and we'll kick off. We've got a few introduction slides, and then at 20 past the hour, we'll be kicking off with our first session. So bear with us. We'll be live soon.
He types incredibly loud. You're correct, Andrew.
I know, every day.
You can hear it right now?
We can hear you typing every single time, Mark. Yeah, absolutely. We have a question already. Morning. And I will stop doing that because everyone can see my screen. Nope.
Wow, good morning, everyone. Got Jacksonville, Florida, UK, Poland.
Awesome. Now we'll give it another couple of minutes and we will get started with the introduction stuff. Anyone checking the YouTube stream? Looking good?
Take a look. Yep, looking good.
Fantastic. Okay, second. Sorry about that. Just making sure everything's okay here.
So, Mark, there's a question. Can we determine what you're typing? And so I promised that I'll do an audio analysis afterwards to determine what keys you were hitting.
Okay,
on that
I had
keyboard.
the wrong microphone turned on. I muted the wrong one. Come on.
Okay, are we good to get started? It's on the hour.
It
Yep.
is.
Okay, so welcome everyone to 8KB, the SQL Internals Conference. We just have a few slides to get through and we'll be starting the main session, the first one with Bob Ward at 20 past the hour. Just want to do a quick introduction as to why we put this conference on. Obviously, with everything that's going on in the world at the moment, a load of conferences getting cancelled, we wanted to put on some free technical training for the community. and we wanted it to be a little bit different from some of the other conferences that are out there. So we wanted to focus entirely on SQL Server internals. And not only that, we didn't want to do anything with beginner level. We wanted to do some really mind-melty content. So we put the word out there to the speaker community, and the response that we had was absolutely fantastic. We had, I think, about 75 sessions submitted, all of which were absolutely fantastic and gave us a really, really hard job in the selection. But we managed to pick 5 sessions after some, let's say, foot stomping, childish name calling, some arguments in the committee. We got 5 amazing speakers for you here today. So before we do that, we want to introduce who we are. My name is Andrew Prusky. I'm a SQL Server DBA, Microsoft Data Platform MVP, and Certified Kubernetes Administrator. I'm originally from Swansea, Wales, but I've been living in Dublin, Ireland for about, coming on to 7 years now. So I'll be helping out today with the moderators and the other organizers. Mark, Anthony, if you want to introduce yourselves.
Go ahead, Anthony.
Cool. It's Anthony Nocentino. I'm an enterprise architect and founder of Centino Systems. I specialize in system architecture and performance. So internals is kind of a interesting topic to me. And so Mark and Andrew started this concept on their own. And then I submitted initially an internals topic, and they were like, hey, that's a good topic. What do you think about helping us organize it? I'm like, that's a really good idea. And so now I've kind of been in the party helping them keep the conference going and help select the content and working with the moderators and speakers to start the event. So I'm grateful that they let me join the party, and hope you guys join the conference today.
Right, and I'm Mark Wilkinson, DBA, and I do a little less work nowadays because I'm an engineering manager, but I still get my hands dirty every once in a while. I'm originally from Michigan, but I enjoy sunlight, so I moved down to North Carolina. That's about it.
No worries. Okay, so here is our schedule today. So we've got about another 15 minutes before we kick off our first session with Bob Ward and Understanding Memory with SQL Server and Azure SQL. And I'm particularly looking forward to this because memory internals for me, I really kind of need a bit of a refresher on it, if I'm honest. Then we'll have a 15-minute break, and then we'll crack on with Aaron Salato with demystifying statistics in SQL Server. Another 15-minute break, and we'll go with Joseph D'Antoni, deep inside Azure SQL High Availability. And this is our only insanity level session. So really looking forward to the mind-melty content of that one. Have a break then, and we're going to go into Pam Loud, TempDB, the good, the bad, and the ugly, 400 level session. Final break, and we'll round the day off with our Janice Fernandez, doing queues all the way down, tracing SQL Server IO. So 5 absolutely fantastic sessions there. Guys,
Yeah.
which one are you looking forward to the most?
So the funny thing is, all of them, of course.
Nah.
But go back and look at our
politicians
go back and look at our Genesis Twitter feed for the last 24 hours, and I think and Joey's too. I think you'll be pretty excited. The other sessions that are awesome. I've seen Pam's session before on TempDB, and it is intense in a good way. Another interesting story is Bob's session. Bob submitted it initially as a 300 level session, and he was like, "Hey, do you mind if I upgrade that to 400?" And I probably was, do you really think we're going to mind? Yes, please.
Absolutely.
And then same thing with Aaron. Aaron was like, hey, what do you think about this as a 60-minute session? No, 75-minute session. I'm like, yes, please. The more, the better. So yes, it is a politician's answer, but each one of them kind of has something I think that's going to be a little bit special for today. So I'm enjoying it.
I really like the schedule. I like the way we're covering different areas of SQL. So we haven't got any duplication there. Each speaker is taking a different area of SQL and drilling down into it. So we're covering quite a large bit of the internals base there. So yeah, looking forward to it.
Yeah, and I would have the politician's answer as well. Although, to be honest, I am interested to see what kind of nonsense Argenis is going to get into in his session.
I've been seeing talk of debuggers and evaluation products and demos and things like that. So I'm looking forward to it. Okay, so there's our schedule. I'll come back to this schedule whilst we're waiting, but we'll crack on. And we just got some resources for you. We've got our GitHub account at the top there, where the speakers will be uploading, if they haven't already, slides and code for their demos, so you can grab those after the event. We also we're streaming this live on YouTube. This is a community-funded event, so we only have a license for 1,000 attendees in the actual event. And we have how many, Mark? 2,200 and something registered?
Yeah, we have 2,272 registered for today.
Yeah, so that link there will take you to our YouTube channel, and after the event we'll also post all the sessions to the YouTube channel. So if you can't make a session, we will be tweeting out when the sessions are available on YouTube, so you won't miss anything. We've got our website there as well. We're on Twitter at 8kbconf. You can obviously contact us as well via email at info@8kb.online if you have any questions about how to get resources or when the next event might be. And then we have a channel in the SQL community Slack at #8kb. We've asked the speakers and moderators, and we're all hanging out there all day. So if you want to hang out there, ask a few questions, talk to the speakers, more than welcome to join us there.
Yeah,
Some more
we haven't
resources. Oh, yep. Sorry.
I was gonna say we haven't decided when the next event's going to be, but if you could see the listing and sessionize of the sessions submitted, we pretty much could have events for the next 5 years and still have a banging schedule.
Absolutely. So
Yeah.
we haven't decided anything yet. We do want to put this on again, but it's still up in the air. But watch this space, absolutely. One more slide. Microsoft have been really helpful to us. We want to say thank you to them with helping promote this event. So they've given us a link there to some of their resources online. So if you scan the QR code, it'll take you to a Microsoft page where there's a whole bunch of SQL Server resources that you can access. We actually want to take this opportunity as well to thank everyone else out there who's been helping us promote this event. We don't have any sponsors. We've relied solely on the community to help promote and put this on. So we want to say thank you to all the speakers. Thank you to all the moderators. I want to say thank you to Mark and Anthony as well for all the work behind the scenes that they've been doing. So very, very big thank you. Without all of you, we couldn't have put this on. And then finally, we have one more slide for speaker and event feedback. If you go to the link there, there will be links to feedback forms for all the sessions and one for the entire event. So please, after the event or after the sessions, go and fill those out. Let the speakers know what you liked, what you didn't like. They always want some feedback so they can make their sessions, improve upon them. And obviously, let us know what you did like about this event, what you didn't like this event, so we can make this better next time. Okay, so I'm going to jump back to the schedule and leave that up there. And whilst we wait for everyone to get ready, we've got about 12 minutes until we're going to go live with the first session. So I can see we've got people coming in. How many have we got in at the moment? 400?
Got about 400 people in.
That's pretty good. And it's going up.
Yeah.
Okay.
Looks like we got people from all over the world here. Got in Russia, Canada. Saw someone from India. Quite a few people from your neck of the woods there, Andrew.
You got a few people from Ireland in?
Yep.
South Africa as well.
Netherlands, Australia.
Australia. It's going to be like, what, midnight? Well, it depends where you are in Australia, I guess. Well, that's fantastic. We wanted to put on a worldwide conference. One of the things about this conference, I think, get your opinions of this, Mark and Anthony, is we couldn't put this on live. I don't think this would work as an actual in-person conference. So
no, I couldn't see people flying out for 5 sessions. But that's another reason why this is a perfect time to put this on.
okay, we've got about 10 minutes to go. So yeah, I'll leave the schedule up, and we can. So if we want to bring Bob and the moderators in, get them prepped.
Howdy, everybody.
Hey, Bob.
Good morning, Bob. How are you?
I'm doing great. Another sunny day in Texas.
Nothing but rain here in North Carolina.
I'm sorry.
Well, it's absolutely beautiful here in Ireland, as you can probably tell by my complexion.
Good evening from New Zealand.
Hi, Hamish. How you doing?
I'm absolutely fantastic, mate.
You awake? How you doing?
Yeah, 11 past 1 in the morning. It's brilliant.
I very much appreciate you getting up. But have you gotten up early, or have you just stayed up late?
What I did was I actually moderated a session last night for my own user group, which is currently a virtual group. And yeah, so I moderated that till 7:30. Then I went to bed at 8:30 and slept until 5 to 1. Yeah, it's all good.
Get you.
Well,
Hi.
Thanks for abusing your sleep schedule for us.
See, the cool thing is I operate in the Hamish time zone. So this is just something o'clock.
Right.
Something o'clock somewhere? Is that? Okay.
Yeah, exactly. Yeah.
On the day known as Blur's Day.
Yeah.
Hey guys, you will have to, and I guess, enable me to share my screen, right?
It should be enabled for you now. What I can do is,
If I say share screen, it says you cannot start screen share while other participant is sharing.
Andrew's sharing now, so when he's
what I can do is I'll stop sharing, and then you can take over, Bob.
Okay, sure.
There we go.
Which one am I sharing? Can you see that?
Nope.
All right, hold on a sec. How about
Oh,
now?
there we go. Yep, there we are.
Beauty. Okay, how do I get rid of all that stuff? Okay, there we go. You just see my slide deck now, right?
Yep.
yes.
Slide deck is there, ready to go.
Perfect. Perfect. Okay. Oh. I guess that'll go away. Do you
Just
see the
confirming.
Do you see this go-to meeting menu up here as well, or okay, it's going away. Never mind. So it's not letting me see the Q&A. So you guys, moderators, you'll have to let me know at the end what questions come up, because I can't see it while I'm sharing.
Yeah, Hamish, Ray. I think they've got that covered for you there, Bob.
Perfect.
Sure have, mate. Bob, would you like me to sort of wait till the end, or if there's sort of a theme going on, would you like me to just sort of calmly interrupt?
Let's do this. There's a couple of demos, sections of demos. Maybe after the first demo, we'll stop and see if there's anything like people are crying to know, and then at the end, that'll be okay. Like halfway, and then at the end.
Yep.
Perfect. Thank you.
Cool.
Yep. For all attendees, we've got the chat there that you can talk in. But if you have any questions for the speakers, please use the Q&A. We won't be monitoring the chat for any questions.
See that? Okay. Okay. And then I'm going to, let's see, it's 8:20. I'll go from 8:20 Texas time to 9:35 Texas time. Is that right? No.
Oh, time zones. Yes.
Yeah, I was trying to get this right. Okay.
I think absolutely everyone all the panelists are in different time zones, which is interesting.
Got it.
Yeah.
One thing we will do next time for everyone is we will announce everything in UTC. We went with Eastern Standard Time because Mark controls the website and Mark is in Eastern Standard Time.
I see.
This was not my request.
I always feel compelled to talk when there's dead air.
Right.
Don't talk, Hamish. No talking.
This is a struggle for me. I'm just letting you know this, okay?
Right. Well, quick. Oh, sorry. I was gonna say quick backstory. My first IT conference was SQL Intersection 2014, and I saw Bob do a memory internal session across two 75-minute sessions, and was blown away by how easily and consumable Bob made a very, very complex topic. So I'm pretty pumped that you're covering this concept, covering memory again, Bob. So I appreciate that.
Well, some of the slides may look familiar.
And it was in Vegas, so there were some opposing forces to my attentiveness.
I see. It was in Vegas, 2014 in Vegas. Okay, yeah.
Anthony, please don't tell us about the slides or anything,
Okay.
because what happens in Vegas stays in Vegas.
Right.
So you can't tell us about the session, right?
Zero.
Oh. That's fantastic that you've had such good input from the community in terms of sessions submitted too. That's great. Could like do
Yeah,
it.
we were really blown away, actually. We put the call out there and the speaker community just jumped on it, and we got so many great sessions.
That's fantastic. Yeah.
And then when me and Mark were talking about running this, we were going to be happy if we got 200 people registered. So getting over 2,000 is something else for us. So yeah.
Nice work. 24 hours of 8KB. There you go. Just do it 24 hours. Oh, what the heck? Let's just keep going until we can't do any more. 5 days later, we're all like, we've got to stop, guys. Everyone, this is have like moderators on sleep shifts.
Rotating schedule through.
Yeah. Count me in, by the way, if you do that.
Okay, we've got about a minute to go, I think. I never trust the clock on my computer. Can someone else confirm that?
Yep.
Yep, we're all
Correct.
good. Okay, right. I am going to turn my camera off to mute myself. And Bob, whenever you're ready, take it away.
Wow. I can't even begin to tell you how I'm feeling right now, because working for Microsoft for over 26 years, being the SQL community that long, I'm completely blown away by all of you that have organized this and everyone online that has taken their time, wherever you are around the world, to watch this. For me, at Microsoft, SQL Server internals is kind of my roots. So I used to be in support team back in the day for 20 plus years, and I got a reputation within Microsoft and outside of Microsoft of understanding the internals of SQL Server And it was, quite frankly, a necessary part of my job. I had to understand how things worked because I found myself troubleshooting the most complex problems in the world. Found myself connecting to people with like Robert Dorr and Slava Oaks and all the people in the SQL engineering team, using techniques like debuggers and all sorts of things, but also understanding the source code. So a lot of times I do these presentations in various places on things like latches and memory and IO and so forth. And a lot of it having to do with researching things in the source code and trying to explain these things in a way that pretty much anybody could understand. Although, to be candid with you, a lot of people would come to me after these talks and say, hey man, you know, my brain was melted. I didn't understand anything you said, but I loved it, man. You know, put the thumbs up to me. And I'm shaking my head going, okay, all right, well, I guess I'll keep doing those things. So the last few years, maybe you've seen me out there in the community at a physical event or now in virtual events, and I am not doing much of that anymore. And so one of my colleagues mentioned about this conference, and I talked to Anthony, who was a tech reviewer for my first book, and I said, hey, you know, do you guys think memory would be a good one? And Anthony's like, yes, that would be a good topic. Please submit that, right? So I submitted this topic, and I hope you'll enjoy this session. I'm not sure I can live up to what you're going to see later. So maybe we'll start maybe not as deep as these other topics, because I think Joey put insanity, and then for Argenis to be the last one of the day, heaven help us all. So we'll see how that all rocks. So let's talk about some memory. First of all, a couple of things. Number one, I have already put this deck on this website, aka.ms/bobwardms. Although before the end of the day, I will put my deck and scripts for my demos and so forth up on the 8KB GitHub site. I haven't put it up there yet. I was working on this last night. But if you want the deck right now, you can get it on this site, aka.ms/bobwardms. And what's interesting about that site, if you go look at it, there are presentations I've done for the last decade out there, including some internals on various topics. So let's dive into what we're going to talk about today. This is kind of what we're going to do in the next 75 minutes. And what we're going to do is we're going to go through a bit of this. My moderators, Hamish and Ree, will probably stop me about halfway through or so. We'll see if there's any burning questions you have out there, and then we'll proceed to the end of the talk, and then we'll end up with some questions as well. So we're going to talk a little architecture. We're going to talk about how you can make some configuration choices and how you look at what I call memory accounting. How do you look at this data to decide what memory looks like for SQL Server? We're definitely going to talk about dynamic memory management. Hopefully I'm going to bust some myths about how that works in SQL. I got some other memory topics I'm throwing in there. I also wanted to cover at the end of the topic a little bit about how does memory work slightly differently in Linux containers and Kubernetes. And then you might find interesting the last slide I have and a small little demo about what have we done in Azure to be a little bit different than we've done with SQL Server. It's pretty much the same, but there are a few interesting nuances. So let's just go into the topic. So this is my world of the SQL Server memory architecture. Now, what I'm not going to do today too much, but I'm not going to be able to help myself, is it's all about APIs. The SQL Server engine is a Windows program, and it uses Windows APIs to allocate memory. But it does something in a very interesting way. So let's kind of dive into what are the major components of memory that we allocate for use of SQL Server. So first of all, we have something called caches. Let me back up one here. So we have something called caches, that's in the blue, and something called fixed memory. Now you recognize some of these names: the buffer pool to store database pages, plan cache to store procedures and text parameterize queries or queries that we've compiled and put into plans. We have other caches and pools that we store things in, and we have column store, which is stored in the form of pools and also participates with the buffer pool. So that's what's in blue. What's unique about caches, and we're doing all the allocation of memory for these things, is that they can grow, they can shrink, and here's what's unique about them. There's a backing store for them. For example, as you know, the buffer pool is backed by database pages on disk. The plan cache is backed by the actual stored procedure text that is stored in system tables. And column store, everybody kind of thinks column store is an in-memory technology. And don't get me wrong, it's fastest when it's all in memory. But these are compressed indexes that are stored on disk as well. So the thinking here, just like maybe a swap file or something, this is memory, SQL's allocating, but we can shrink and trim this really, really low because everything's on disk if we have to load it back into cache. Now, fixed memory is different in this gray area. It doesn't take up near as much space typically. And I've kind of drawn this diagram to show you what is typically your biggest consumers of memory in SQL Server. And so fixed memory can grow and shrink, but it only can shrink when it's not used. So an example here is connection memory or memory grants we use for like hashes and sorts. So it's not used, we can get rid of it, and it can grow, but it cannot shrink when it is in use, unlike these caches. These caches, if they're in use, like a database page, if it's what's called clean or not dirty or changed, we can just free up that memory and give it to somebody else. If it is dirty, what do? We write it to disk, we flush it, like Lazy Writer can flush this, and then we can give that memory to somebody else. But you can't give connection memory to another connection because there's no way to have a backing store for it. There is no disk behind connection memory. Now, typically we use something called a memory object. Memory object is a abstraction in the SQL engine that the SQL OS component gives other developers on how to access memory. So that's caches and fixed memory. And you're going to find, it's very interesting, that if we don't have enough memory for our fixed memory, you're going to run out of memory inside SQL Server, but it's going to be a little bit different than you might expect. So another thing you need to know about SQL Server memory is something called overhead. SQL Server is an executable, and therefore there are things inside the normal nature of running an executable like thread stacks that take up memory in the SQL Server architecture. Well, why am I saying that? That's because between fixed memory and overhead, again, if we run out of memory, we have to make sure that SQL's memory exists just for that. But also, when we talk about a concept called locked pages, the SQL Server overhead can actually be swapped out to disk, which is really kind of crazy, and SQL doesn't know it. And that's when you get into a really bad problem called working set trim issues. Now, finally, I want to dispel some myths about hackathon memory or in-memory LTP. So in-memory LTP is fixed, but and I say fixed for this very reason. Think of in-memory LTP as almost like a dynamic disk drive in memory for data, because this is where you store your data for memory optimized tables. And that data has to fit in that space. So hackathon memory can grow, but we limit it. We don't let the entire, notice it doesn't take up the entire SQL chart here. So it grows, but it has limits. Now here's the interesting part. It can't shrink if there's data in it. So if you populate this thing with data and you haven't deleted that data, we cannot shrink this memory. So it's another kind of almost fixed memory that could cause you to run out of memory. Well, how do we reclaim this memory? Well, you got to delete data, and we use a garbage collection process. So for example, if memory pressure comes into SQL Server in this diagram, all the blue guys can adjust themselves, right? Because they're caches and they have backing stores. The gray fixed memory cannot adjust itself, neither can SQL overhead, and hackathon cannot adjust itself either unless you reclaim that data by deleting data, and garbage collection will kick in. So that's a little interesting look at the architecture, and we'll talk about how dynamic memory affects all of these things. Okay, so what about paging and SQL Server? I get this question all the time because people try to understand the difference between locked pages and not locked pages and so forth. So just like I talked about in the previous diagram, SQL Server has the ability to do its own paging, like almost a page file in an operating system. So for example, if we get memory pressure, we can take buffer pool database pages and write them to a database file. You know how that works. If it's dirty, if the page has been changed, we can write it and write all the log records. And if the procedure cache has pressure, we'll talk about this concept called a planned cache eviction. That's what you call when you get rid of plans from cache. We obviously can just reload these from system tables. So you don't lose any data. That's the idea about being paging. But then again, this connection memory is not pageable. Now, Windows as an operating system, and Linux has the same concept, it can page out any process's memory, period. Doesn't matter about SQL's paging concept. And in fact, Windows can go through this process of doing this. And in some cases, SQL doesn't know it's happening. So Windows would write out pages for a process to the page file. And then there's this really crazy process called a working set trim. This was a really bad scenario that can happen. And even that SQL Server overhead for thread stacks could get written to the page file in that case. Look at that. Look at the comment in bold here. SQL still thinks it's all in RAM. So normally when you're looking at a problem for paging of SQL right here, you're looking at things that might give you
Is audio cut out for anyone else?
Yes.
Okay. Bob, if you can hear me, we can't hear you.
Whoops.
Okay, everybody in the chat, we know you can't hear. We're working on it.
Bob is muted. Oh.
Hello?
There it goes.
You there, Bob?
Hello?
There we go.
Yep.
Can you hear me
gotcha.
now?
Yeah.
Yeah, you left off at still thinks it's all in RAM.
Okay. Sorry, guys. Don't know. Welcome to the world of
Computers.
virtual presentations, right?
All
Haven't had
good.
that happen with my headset before. Okay, so as Anthony was saying, right where it says SQL thinks it's in RAM. Remember this from a performance perspective. SQL doesn't know this. It just thinks everything's fine. You normally used to looking at things from a performance perspective, that things I/O related are happening that could show paging for SQL going on, but for Windows. So how do you know this? Well, you can look at things like process working set and memory pages out per second from a perfmon perspective to see if that's happening, or look at the working set data that SQL shows. Now, having said that, SQL, after a while, we got tired of these problems in support. And so I told the engineering team back when I was in support, you got to do something about this. So we did put some logic in the server where we recognize if a severe working set trim is happening, and we generate pressure into the engine to tell itself, hey, this working set trim is happening here. You guys need to react to this. And we dump something in the error log. But typically, SQL doesn't know this is going on. So why does that even really matter? So let's go to the next screen here. Okay. We'll talk about locked in a second, why that matters. So first of all, I want to talk about some memory configuration decisions that you may be making with SQL Server. Let's bust some myths here. Number one, SQL has something called a memory model. And the default is called conventional, and we'll use the virtual alloc APIs from Windows if conventional is the model, which is the default again. So along comes the need because of these working set problems that we'd run into before, and we had just some really bizarre behavior across the years with SQL Server, where literally Windows would do this working set trim, and there was a lot of physical memory on the computer at that point available. So we didn't understand why that was going on. So this lock pages concept comes along, and you have to have the lock pages memory privilege set for the account for SQL Server. If you set that, and we're running standard to enterprise edition, we will use what's called the AWE APIs, address window extension APIs. When we do that, and we use those APIs, Windows cannot trim that memory. It's considered locked. Now, what does that even mean? What it means is that it doesn't even look like it's part of the working set of a process. When you use these APIs to allocate your memory instead of virtual alloc, the Windows operating system doesn't even know that's part of your working set. Therefore, it can't trim you, which is why we use this technique. And I often tell customers in many cases that this is something you should be using in your environment because of that type of problem. And if you don't know, you can go back and read a little bit of the history of what AWE is all about. AWE is really an API that was built back in the 32-bit days. I know that sounds crazy. Anybody on the phone, they're like, was there such a thing as 32-bit processing? There was. That's originally why this technology was built. But it turns out it's actually faster to access memory, this method, and it gives us this locked pages type functionality. And we're going to show in a demo and in some slides here, how can you tell if you're using locked pages? Along comes our team that does benchmarking and said, you know what? If you use the virtual alloc call with this option called mem large pages, it is also locked like AWE, but it has an interesting property. The size of the pages from a Windows perspective, and when I say pages, I don't mean database pages, I mean Windows pages that are in memory from a Windows perspective, they're larger in size. And we found out we could get a performance boost. So if you turn on trace flag 834 and you have this lock pages privilege, we will use this concept called large pages. And here's the thing that's interesting about it. We allocate the memory up front if you use large pages. So if you use large pages, we're going to allocate this memory up front. And that can be an interesting scenario for you because it could take a while to allocate memory. So if you set max server memory even at 0, or you set max server memory to a very large number, we have to allocate all that stuff up front as we start the engine. We've seen people have issues with that in like a cluster failover scenario. We typically only recommend people use this large pages if you're really doing some fine-tuning benchmark scenarios. You may have different experiences here as you're watching this presentation where it's helped you or not. We use it for benchmarks like TPCH, and that's why we document the whole process. Recently, Over the years, we've found that column store indexes has issues with this. So instead of 834, we have a different trace flag, 876, that if you're going to use column store and large pages, you want to use that trace flag. Okay, max server memory. Just like max degree of parallelism, it's probably a religious war in the community about should you set this, should you not set this, what should you set this to? Let's just state some facts so you understand what it means. If you set it to 0, it means it's dynamic. In other words, the maximum is dynamic, but I got this from the source code. It is not the absolute amount of physical RAM. It's the minimum of 95% physical RAM or 50% of the available RAM left. I know that sounds like a complicated algorithm. What it really means is we are going to go almost the amount of physical RAM on your computer or virtual machine. But as you'll see here, we're going to talk about the fact that we could lower that value. And you need to get used to this term, these two terms. Max server memory will end up being something called the target or the ceiling to which SQL will not grow above. And many people choose on big servers for this to not be 0, and they'll set it somewhat less of physical RAM. It could take an entire presentation to describe like experimentations people have done to decide, well, how much should that be? And so I always tell somebody, if you're going to use locked pages, because then Windows can't trim us, you probably should set this not to 0. But you need to experiment with how much you should set this to where you leave enough memory for the operating system without causing any issues for the system. And then there's this concept called external pressure. So if we detect in SQL Server, and we can negotiate with the operating system actually, we get notified, hey, there's some memory pressure going on the computer you're running on. We call that external pressure. We can lower this ceiling or the target dynamically down, but it does not change the configured value. So we can lower that ceiling, but we can go back to that ceiling if we need to, if this pressure has gone. Now, min server memory is the floor. Think of that as the floor to which SQL will not shrink below. We do not allocate this at startup. And a lot of people have asked me, what should I set this to? So on a machine where you have a standalone SQL server and that's the only thing running, I just leave it alone. You may decide though, on a server we have multiple instances to set this differently. And in fact, speaking of multiple instances, here's something that people don't know about. If you put multiple SQL Server instances on a computer, they do not know about each other from the perspective of memory negotiation. So it's not like one SQL Server says, oh, your max server memory is at 8 gig. I'm going to adjust mine dynamically because you might need 8 gig. We don't know about each other. The same thing's you're going to see applies for containers. So that's another scenario where you might start playing with what these are the appropriate values for your system in a multi-instance environment. Now let's make sure we kind of bust some myths about what locked means. The locked pages memory model is again a scenario where we're going to use APIs so Windows won't page that memory because it's not part of the working set. But notice this comment here. Other memory like thread stacks and even Windows heaps can be trimmed. And in fact, as it turns out, some memory, even when we're using locked pages, SQL Server doesn't use AW APIs. It's a very small amount, but it does in some cases not always use that. So there is a small amount of memory, including thread stacks, that could be trimmed even if we're using locked pages. So I've had some people tell me, well, I use locked pages, and then this working set trim scenario occurred because I saw this in Perfmon, and I had a performance problem. And I'm like, yeah, our thread stacks got trimmed. I mean, the actual stack memory for a thread, if that gets out into a page file, for SQL to have to read that back in to execute code on a thread, that could actually be a performance problem. So when you run into these working set trim type issues, you have to go look and see what's going on in the system. Are there other things running on the system that could be causing issues? And again, large pages are also locked. Now, what is the difference between a locked page memory model and SQL locking memory? So what that means is that we have max and min values of our ceiling and our floor that are independent of that locked model. So whether using the conventional model, the large model, or the locked model, SQL's max server memory ceiling and min server memory floor are independent of that. We don't pay attention to what that model is to make decisions on the target or the ceiling. Remember, the target or the ceiling is a response. We lower that if the operating system says there's pressure in the system. And then min server memory, if we start lowering that ceiling down, of course, think about a concept of a room. You can't have your ceiling below your floor. We will never do that. We will never allow memory to go below that floor level. So I thought that was important for you to understand because I've had some people, and it's not your fault, it's a complex topic, say, well, I've got the locked pages memory model on, and therefore my target won't change. And I'm like, no, that's not true. The ceiling or the target of SQL Server memory, that is independent of whether using this locked model. This locked model is purely used to avoid Windows from taking any of our memory and writing it out to the page file and trimming our working set. Okay, let's look at an example, and we're also going to go do a demo to look at this. This is like a perfmon chart where you see target memory here, total memory, and private bytes, which is the amount of memory being allocated to the SQL Server process. So first of all, total server memory right after startup is fairly low. In this case, in my example, it's like 500 gig, right? That's the total server memory. Whoops. Now, the ceiling in this particular case, I've set, let's assume, max server memory to 1 gig. So you can see the difference here. The black line is my total, and the red line is my ceiling. So I can grow dynamically within that. And in fact, if a query starts loading pages, you'll see the black line start running and moving up towards the red line. Now, funny quick side story is, in the early days of SQL Server on Windows NT, and being in SQL support, I often had to work with the Windows support team on cases, on issues. And I'm not making the story up, this is a true story. In those early days, we're talking about like mid-90s, right? The Windows support team would walk up to my desk, we were a pretty small team back then, and say, Bob, we've got another SQL Server memory leak going on. And I'm like, SQL Server memory leak? What are you talking about? And they would show me a chart like this. They'd say, yeah, look at that black line. Do you see how SQL's memory is going up and climbing? That's a memory leak. And I'm like, no, that's what we do. That's how SQL is a hog. As soon as we start using memory, we are going to start climbing and climbing. And so I'll tell this engineer from support team Windows, did we ever back off? Did we ever peak? And they're like, yeah, it's weird. You guys were climbing, and then it kind of leveled off. Like the leak stopped. I'm like, no. That is us doing the following. So when the query is still running and loading pages, but we hit near this ceiling, we hit a concept called internal pressure. And SQL Server has mechanism in internal pressure scenario to tell all the caches in the system. It's called a notification system. Hey, caches, we are running out of memory within the SQL memory system. Everybody needs to start flushing their caches out. So what happens in the case of buffer pool? If the query is still running, we're going to start throwing away pages that are free, that are not dirty, right? And loading in pages we need to finish our query. Or if they're dirty, in this case, we're just running, one query here, they're not dirty, I might need to write them at the disk. So internal pressure causes all the caches to start adjusting. But remember now, the fixed memory, they can't adjust. So there could be problems if the ceiling gets lowered, and we'll see that in a second here. Okay, so let's say external memory pressure kicks in, or I change the ceiling with max server memory and I drop it to the floor, which in this case, I've set the minimum to 512. You see how now the black line starts dropping. So the total server memory is going to start falling down towards that ceiling, right? Because we can't go above that ceiling, but we can't go below the floor. So if we hit this kind of type scenario and we need fixed memory, we could run into some problems. But notice here that the black line and the red line are right on top of each other. Okay, so if the query is still running during this dropping scenario, what is going to happen? Like you may be asking yourself, does the query fail? Nope, doesn't fail. It just means you got bad performance because we're having to throw pages in and out of cache. Remember, we still need pages probably from disk to be pulled into cache. So pages that we previously read are getting thrown out of cache. It's kind of a crazy, we call this cache sloshing in some cases. So if the query completes right here, let's say it's done at this time level, and the pressure goes away, notice that the ceiling goes back up. But the black line does not go back up. Why? Well, we don't need any memory at that point. So you can literally have this dynamic scenario where the target or the ceiling can dynamically adjust itself back up. But if you don't need any memory, we won't grow our memory back until we actually need it. Now, the other thing to notice here is that private bytes will always be slightly higher. And if you ever saw this private byte line start really climbing way above our total server memory, you truly might have a leak in SQL Server, but not from the SQL Server code. You'd be having this probably in something else. Okay, let me just see something here real quick. Okay, so let's look at some accounting data. So number one, SQL Server often is seen from Task Manager. People in Windows will look at this all the time, and they'll look at something called working set and something called commit size. Now, another thing to look at is a DMV called OS process memory. So let's kind of tie some things together. The working set is often tied to this physical memory and use KB, but remember this, large and locked pages are not part of the working set. So this physical memory counter is a combination of all three. So if you're trying to tie memory accounting together, like, hey, this working set's really low, what's going on? Well, remember, large and locked, which we account for inside SQL Server, are a combination of all of that. So when you're trying to tie this together, you got to keep that in mind. Second of all, the commit size should line up. We have virtual address space committed. So if you're looking at commit size, which again is a kind of a combination of these things plus additional memory, that's going to line up to this DMV counter. And remember, this is something you may not be aware of, but even without that trace flag, we can use large pages internally, not a large amount, not for the buffer pool and so forth, but for small overhead, we could potentially use large pages. So that could show up if the log pages memory privilege is turned on. Now, some of you may have seen and heard about this old DBCC command called memory status. I find it somewhat useful in some cases, especially for NUMA scenarios. I still use it in some situations, but I wanted to kind of line up some things here. So first of all, notice that the lock pages and large pages tie into these two DMV columns. And then also notice that DMOSSYSINFO, this is a very common DMV used, and I like to use this one because if I'm not looking at perfmon, I can easily see what is my total and target. And what I mean by that is current committed lines up here, target lines up here, and here's how they line up to perfmon. So you can see here that committed KB will be my total and target will be my ceiling. Now, just a quick comment about this. People have said to me before, Bob, we're not using enough memory. SQL Server is not using the amount of memory it should. Or SQL Server is having a performance problem because memory is, under huge pressure. I get those kind of type questions. What are the first two things I ask anybody is show me these two numbers. What's the target and what's the total? Why do I want to see target? Because if target is really low, that means somebody either used max server memory to change it or there was pressure in the system. And there's DMVs through ring buffers and stuff for us to find out if there was pressure. So if anybody ever asks you, hey, is SQL using the memory it should? Or is there something going on with pressure on your system? Always start with target and total to find out the ceiling, the usage, and then of course you would look at min server memory to see what the floor is, which typically, again, you may not change, but keep those two important counters in mind. Okay, so let's definitely do a demo. Let's do a couple of fun demos too. Let's see, what do we got here? So I've got a perfmon on my local laptop right now. Now I threw up page life expectancy, which is a counter a lot of people use to look at buffer pool. And you notice here it's really large because I've been running the SQL Server for a while. I've had this run all night basically. And you can see here my total is around like 800 meg and my target though is like 4 gig because I've set max server memory accordingly. And my private bytes is slightly above it. Notice that's the green line above the total and the ceiling is my red line. So let's go over here and let's go run. Let's look at a couple of queries. So under Management Studio, here's some DMVs. Remember this is committed and committed target. So let's go run this and see what we got. Okay, can you see here that these two numbers are aligning up to perfmon? You can see how those kind of, like we talked about, how you line those up. This is the total physical memory. Remember, if you get down here to physical memory in use, this is the working set plus this together to give you that total number. That's really how much physical memory SQL is literally using on this system. And then one thing that we did not talk about yet is memory clerks, which I'll show you in a debugger example in a second. A clerk, think of this way as a categorization for accounting. And you'll notice here when I'm looking at these clerks, I'm looking at pages KB, virtual memory KB, and AW allocated KB as the sum. I know that sounds crazy, but as it turns out, from an allocation point of view, these various clerks, which I'll scroll up, you can see here in a second, these different clerk systems may use 3 different ways of allocating memory, not always just locked pages. So let's run this and see what that looks like. So this is a way to find out what are the top memory consumers. And remember my diagram of the caches and the fixed memory and stuff? At a detail level, what are the top consumers in my SQL system? And so you notice here at the very top is the lock manager. That's interesting. I've actually not run a lot of queries to load pages, so that's not totally unusual. That's fixed memory, by the way, that lock manager. The buffer pool is what you expect. This is across my system, my buffer pool. Then look at something like XTP. That's like heckaton memory. I even got CLR memory. You can look down here and find like this is procedure cache. This is part of procedure cache. A lot of these different things are fixed, and a lot of these things, some of these things are caches. This is just a way for you to get a perspective of what are the consumers running around on my system. All right, let's try an example here. Let's go back and look at perfmon. So this is perfmon. Let's run a query that's going to go up to that ceiling. Let's come back here. So I've got this database called Go Cowboys, and there's no way anybody is allowed on this call to criticize my sports team's names, especially Anthony. He's not allowed to do that, or I may drop the call at any point in time. So I'm going to run my query here and try to load up some pages and see what happens. So you'll notice here that, here we go. Now notice my total, now in this particular case, my total server memory is above my target. Notice here, it's actually right around the same, but because of the way I've got this set up, it looks, oh, sorry, private bytes is, sorry. So here's private bytes. Okay, this is the part that's funny. I forgot about this last night when I was running this. I looked at this and I saw the green above the red. And I said, wait a minute, did total go above target? In this particular case, because of the way perfmon looks here, the total and the target are right almost on top of each other. Notice the total is just below that target line, so you don't even see the blue. Like you can't even tell that the blue is there, right? But really they're right next to each other. Now the private bytes though, as I said, is slightly above that, and it always will be. Notice what happened to page life expectancy. Oh my goodness, it was like 48,000, it went down to like 48. That's because as I started loading buffers into cache, the server realized because I'm so squeezed on my ceiling, my page life expectancy is not all that great at this point. Well, let's have some fun here. Let's go over here and let's change some stuff. Let's go lower the ceiling by changing max server memory and see what happens. Let's go down. And now you're running and you're like, well, Bob, you just made a change. How come it doesn't take effect immediately? This is because one of our background threads called the resource manager is polling and looking at that change to that value periodically. So it's not an immediate change, but notice within seconds this changed. And what happened to our system? Notice here the red line, which is the ceiling, went down, and the blue line, which is total, went down with it. And notice page life expectancy dropped down to 0 at this point. Like I don't expect anything to stay around in cache, but private bytes remain slightly above this. So you can see, can you see here the blue line is just a little bit right under that red line right there. And then here is our private bytes and page life expectancy. Now, if I go back to running my query again, and I set this back up to the ceiling, you can go back under perfmon and you're going to see what's going to happen. Just like we talked about, you expect the red line to go back up, but the blue line, all of a sudden we're going to be able to see the blue line now because the total, I'm not using it. So you can see our ceiling's back up again, and then notice the private bytes is slightly above that value. So let's have fun with another scenario. I always, in my support days, love breaking SQL Server. So here is a VM. I've got an Azure running SQL Server. I don't want to break my laptop, so I'll just go break a VM in Azure, a SQL VM in Azure. Now right here, if you'll notice in my perfmon, my total is about 300 meg and my target is about 12 gig because I've got max server memory set to 0. So let's have some fun. Let's go set max server memory to the lowest possible value, which is 128 meg, and see what happens. So let's click that. That ran for me. And what would you expect to happen here? My total server memory is 329 meg. My target, here goes down to 128. And look at this behavior. This is the one scenario you're going to see where the total is above the target. Why is that? That's because that total memory of 269 meg is fixed memory. We have squeezed all our caches down. Everybody's tried to relieve pressure in the system, getting rid of everything that can be into the backing store, and fixed memory is still around. So no problem. I think I'll go fix this. So I'll run spconfigure to go back, and I click it, and uh-oh, I'm out of memory. Now, why am I out of memory? Because we are so starved of fixed memory. And remember, we set the ceiling down, so we can't grow. So we don't have enough memory to even run a query. And if you go to your error log here, you will find that happens. So let's go type out the error log. Actually, let's do it this way. Let's go look at the error log for Notepad and see what happened. This is an out of memory condition in SQL Server. It looks something like that. You'll see that 711 error, and then you'll notice here that I start getting a dump of what memory status looks like. So DBC's memory status is almost dumped out to the error log. So when somebody ever gets one of these errors, I start looking at some of these values like, what's going on here? I got a lot of available physical memory. That's not the problem. But notice here, I can see right away this problem right here. I can see my current committed and my target, and that is a bad problem right there. So why would that happen? Well, I obviously adjusted max server memory too low that it can possibly be, but external memory pressure could kick in this case if it was really a bad server and cause a similar type situation. So you're thinking to yourself, how do you get out of this thing? You can't even stop the service in this case. So I brought up this. So I'm going to go kill SQL Server. Let's go in the task there. And then I'll do a little trick. So the trick is I want to start up SQL Server in single user mode, also with this -f trace flag right here, -f trace flag for what's called minimal configuration mode. This is going to let SQL Server use default configure values regardless of what's an SP configure stored. So it's going to use max server memory at 0 to start the server. And I'm going to use -m to tell it, let me get in there with Management Studio. So I'm going to run this. Whoops. I got to be in the right directory. Let's go here. So you see the server is starting up, and then I get to come in here, and I will go to say file, maybe new query. Is this going to work? And it will. And I'm going to come in here, and I will run my query, and I fix the server. So then I can go and I can shut down SQL and get back up again. So there's your fun demo to how to break SQL Server. Let's do one last demo, because you have to have a session in this conference, I've heard, with a debugger. Somebody said that that's a requirement. So let's go back over here. Let's go to a command line of my local SQL Server. Let's see. Let's get rid of this guy to make things interesting. Let's get rid of him and him. Yeah, him as well. Okay, this is just the command line of SQL Server. Let's go ahead and stop SQL Server. This is on my laptop now. I'm back to the laptop where I was running SQL before. Okay, so then let's go do this. Let's go a debug session. And so you're asking yourself, like, what do you do in the debugger? Well, I'm going to run the Windows debugger. I'm going to load public symbols, and I'm going to use SQL Server from the command line. So let's do this. Okay, so here's my Windows debugger. What it's doing is the debugger is going to start up the SQL program, not attached to it. And I'd like to see how SQL uses APIs. So I thought you'd find this interesting. I'm going to show you this API. This is the API we use for AWE. Since we're a NUMA system, even if I'm not on a NUMA computer, we always use this API. And I know to set a breakpoint on this because we're using the kernel 32 library. Now, this is the part that you don't know, that you have to just know, unfortunately, is that these are really mapped to a DLL called kernel base. So I'm going to set a breakpoint called kernel base, and let's go and pick that guy. This is the way we debug, guys. We just go out there and find the APIs, and we're going to set a breakpoint, and we're going to go. And boom, I've stopped. Now, the K command is going to give me a thread stack. So what is going on here? So first of all, this is us booting up SQL Server for SQL OS. So even SQL OS needs its own memory. So we're going to use the SQL OS systems. Notice I've got this memory clerk here, and then I'm going to come up here, and I've got something called a block allocator with an SOS. And if I scroll up, eventually what's going to happen is that even SQL OS itself needs to use this API call. That's kind of like our own API call, but then directly calling the kernel call. So we're actually going and allocating physical memory at startup. Much of the memory at startup is going to be fixed memory. So let's go again. That one's not interesting. Let's see, let's find one that's interesting here. I was going to show you this one. We're starting to create a cache store here. This is a good one. So many of you are programmers, know the new operator in C++. This is us. We create our own new operator. We overload the new operator, our code, and the new operator results in all of this code right here. All of this code right here is the new operator calling all of our code to allocate. Ends up allocating memory within the APIs. Let's see, one more. lock monitor. Ah, this is the one I wanted you to see. Look at this one. This is us loading SQL CLR. So we're calling into CLR. Notice that, right? This is literally the CLR code. So the CLR code comes along and says, hey, I need some memory. I need to allocate memory. Well, we've got it hooked into SQL CLR so that it calls back into SQL Server to get memory, to call SQL OS, to call memory within the operating system. So this is how SQL CLR routines allocate memory. It's a callback system where we've registered with SQL CLR, so all of it's controlled by SQL OS. So there you go. This way now you can go along and say that Bob Ward did bring up debugger, maybe not as sophisticated as say Argenis is going to do. He's probably going to do a lot more sophisticated debugging sessions, but that's my debugger of the day. So let me stop for a second. Hamish and Reed, got any kind of crazy questions out there before I keep trucking?
Yeah, I have a couple of questions. Thanks, Bob.
Okay. Yeah.
Question here. What happens internally when min and max memory are both the same? Dynamic memory won't work then?
Yeah, no, dynamically, so if you set min and max the same, it is fixed at that point, right? So if you set this, if you put max at 4 gig and you set min at 4 gig, first of all, we don't allocate min up front. Okay, so when you start the server and min is at 4 gig, we don't just jump to 4 gig. Now, large pages is different. We allocate max at the beginning. So it is true, though, that once we get up to the max, right, we get up to the 4 gig range, if you've got min set that and we get pressure in the system, remember the external memory pressure, we don't drop below min. So once we grow to that max level and min is the same, we will stay at that level. But by the way, that could cause all sorts of problems. Not sure I recommend people immediately going into that mode, but that's kind of how it behaves.
Nice. What are the situations where you would not recommend granting lock pages in memory? What are the situations you would not recommend it?
You know, to be honest with you, I just always use it. Now, somebody, this is really interesting debate. There's even debate in the SQL engineering team about this some. So we don't do that in Azure today, by the way. We don't by default do that because we have not seen working set trim problems occur in Azure. You know, when I'm talking for the people that built SQL OS, using AW APIs can actually be a little bit faster than using normal virtual alloc APIs. So, you know, I guess the problems I have seen in some cases is people set locked pages and they didn't set a max server memory value. And then Windows started having problems because we use so much memory that Windows can't trim out. So the pure Windows person may say that you shouldn't be doing that because we can't properly kick in our trimming algorithms. Man, if I was running a production SQL server, I would definitely go take a look at putting this thing on because I have seen working set trim issues occur with Windows where plenty of physical memory is available. It is fair, though, that if you're going to use locked pages, I would set a max server memory value that is not 0. I would try to find a value that's slightly below physical memory, maybe 1 or 2 gig, and experiment with that to see whether I don't want to waste too much memory. But my personal experience, when customers would call me in support and they'd have issues, I'd say turn it on. So.
Awesome. Would the Windows paging still take place even if you have locked pages and memory option configured?
The answer is yes. We talked a little bit about that. So Windows paging happens, period, for any process, okay? So let's say you have a scenario where you have locked pages turned on, the privilege is set, and SQL is using locked pages. So absolutely 100% Windows can page the SQL. It looks at SQL Server as a process, says, I'm going to do some paging. So what does it do? Well, it looks at the working set of a process to do its paging. And so in this particular case, if SQL is using locked pages, the pages that we use for locked, which is like buffer poolant, for example, Windows cannot page them because it's not part of the working set. Windows can only page memory that's part of a working set. So, however, there is other certain amounts of memory that Windows can page out, like thread stacks, and there's a small amount of fixed memory that we allocate with virtual alloc and other APIs that could be paged out. So yes, Windows can do paging for SQL Server, even with locked pages, but what's not going to get paged out are really important pieces of memory like the buffer pool and plan cache, etc.
Awesome. What about setting a fixed size, i.e. 4 GB, for the page file? Is this a good practice?
As far as the Windows page file goes, is that what the question is? Yeah,
Yep.
yeah. I would use the guidelines that Windows has set up for paging. Linux is the same way. First of all, make sure you have a page file, and then put it on the appropriate disk. So Windows has guidelines out there about what should the size of the page file is, and it's usually a factor of how much physical memory you have on the machine. So go look at the guidelines for Windows. It's been a while since I've looked at that, but that should not be a SQL Server decision. That's a decision for just running a Windows Server, period, independent of SQL Server.
Okay, excellent. Do you want me to keep going? We've got a few questions. Some of them relate to Linux and Azure. So
Linux and Azure, let's hold those off because I still have some slides on those. Now, how long do I have till?
Another
20 minutes?
Yeah.
20 minutes? Yeah.
You have 30 minutes. You go until 10:35 Eastern, and it's 10:06.
Look at Ree, she's all over it. So yeah, let's if there's any other questions, let's answer them. Sure.
Okay, sure. Can you explain something about the flush cache logs and the SQL error logs? Why is it happening?
Oh, so somebody's seeing like flush cache occurring. Yes. Yeah. I have seen that before. There's a couple of reasons why that might occur. One is pressure that's occurred in the system. Another is, and I think I may have this on a slide, I don't remember, as it turns out, there actually are some commands you can run like alter database or spconfigure where we'll go flush the procedure cache. So if it's the same message I'm thinking of, those are probably those situations that are happening. If you're seeing that every once in a while, I wouldn't worry too much about it. But if you see it consistently, you need to go see whether you're running a certain set of commands that cause it or whether there is pressure going on in the system.
Bob, I wanted to quickly say Erin Stellato, who presents next, said you can go a little bit over, that she doesn't mind.
Well, that would be typical of a Cleveland Browns fan.
Well,
to say that. That would
you know
be
what?
normal.
She takes it back. You have to end right at 10:35.
Well, that's the Cleveland Indians fan in her now saying that. So. Any other questions, and then I'll keep trucking.
Yeah, sure. I see a lot of open connections on my server. Will that hurt memory? And what is the best practice to close connections?
Well, first of all, if you're worried about connections overall, about open connections, make sure you're using connection pooling for apps that make sense for those scenarios. Connection memory is very small. So if you've got a large amount of memory in your SQL Server, connection memory should not be chewing up a lot of memory on your system. However, there are scenarios where you can cause memory leaks with SQL Server by keeping things open. So I've seen one scenario I used to see, not as much anymore, but cursors, like server cursors. If you open up a server cursor and you don't close that cursor, we have to keep that memory open, and that's fixed memory because we can't flush a cursor to disk or something, right? So connections in general shouldn't be an issue. It might be indicative though of some other problems by leaving a connection open. So look at connection pooling, but a single connection does not require that much memory, but it is fixed memory. So if we're under a really severe memory pressure trim, we can't flush that out. There's no way to, there's no cache for connection memory, right? To write it at the disk. So.
Yeah, awesome. Can large query memory grants cause internal memory pressure in SQL Server? And where are the query memory grants allocated from?
I'll address that in an upcoming slide. Okay,
cool.
You want to truck on a little bit, and then we'll have time at the end. We'll have time at the end for sure.
Thanks, mate.
Based on what I got left. I just love it when I get called mate. I just love y'all's way you speak and mate. I love that. Okay, here we go. Other memory topics. So first of all, buffer pool logistics. We showed you about page life expectancy. There's some quirks there. You should kind of look. The community's spoken a lot about whether that's good or not good to look at. It is still good to look at. You saw in my example where page life expectancy, which is a rate that we have, right? It dropped to almost nothing. And that was because of pressure in my system. But what are other signs of maybe I don't have enough buffer pool? If you see a consistent set of page IO latch waits happening all the time, remember, when we first load pages from disk, this is normal. A page IO latch wait is normal, period, because this is just an indication of the time it takes us to wait for a page to be loaded from a disk drive. So don't think that the presence of a page IO latch wait is bad, but if you see them all the time and the waits are long, you probably need to go look at something. And then drop clean buffers is an interesting one. This is not intended to be used in production, okay? but I use this all the time to force pages to be loaded from disk. So when you run this command, we'll take any database page that is not dirty and free it up, basically, for memory. So then next time that you run a query, we would load that page from disk. So if you're out there wanting to test how fast can I load my database pages from disk, you would run this command on your database and then run your query again, and you would see IO latch waits kick in. So what about NUMA? NUMA is a commonly used, obviously, technology across major servers. And you should know we could spend an entire hour talking about SQL NUMA and how it works. And shameless kind of plug, but if you want to go back on that SharePoint, the site I have, ak.ms bobwordms, which I'll put that up at the end. Or if you can go back and find my past talks where I've talked about internal memories, which I can't remember what year that was, but I get deep into this topic. So NUMA, you need to know that one of the things about NUMA you want to do is make sure that on a NUMA machine, when you allocate memory from the local node. And so that's our goal in NUMA, which is why if you're looking at memory accounting across NUMA nodes with SQL Server, you may not be balanced, because we're going to try as much as possible to use local node memory if we can. The other thing you should know, though, is that local node page allocation is not a guarantee of local node access. What am I talking about? Like buffer pool. Buffer pool is spread across the entire instance. So it's possible for somebody to allocate memory for the buffer pool itself on a given NUMA node, but somebody else access that memory on a different node. There's not much you can do about that, right? But some memory is partitioned based on NUMA nodes for performance. And we had this problem a long time ago with something called memory objects you may have run into before. Mem objects is what we call them. And so we, along the releases of SQL Server, went along and we automatically handle this now. We partition these objects, which is typically for things like fixed memory, like the case somebody asked about memory grants. We partition these per NUMA node, so they're allocated and used on a given node, and it really has sped up performance, and not just sped up performance because you're using NUMA, but because these memory objects are typically, in some cases, shared. So somebody creates a memory object and then multiple threads need to access it. And then if it's partitioned by NUMA node, then of course it's much faster access and it's the performance is spread out. Let's talk about grants for a second. So memory grants are memory that are fixed memory. There's no backing for this, right? And we allocate this at the start of query execution. And we determine if we need a grant for things like sort memory or hashes. Let's talk about a sort for a second. If you were a computer programmer and you had to sort data, you're going to have to allocate a memory buffer like a linked list or an array in your code to do the sort. Let's say you're reading it from a file. You want to read from a file and you want to sort that data. Well, what you're going to do typically is allocate memory and then sort the data in memory. Same thing for SQL Server. If we're going to do a sort operator, we're going to allocate memory to do the sort. A hash join has the same type of process. We need a hash table. We're going to allocate memory for it. That's why we need a memory grant. And that memory is going to be decided at the start of query execution based on the plan. Well, the problem is this. If the estimates in the plan to feed these operators like sorts and hashes, if the estimates are too low from what's really needed, we might have a problem. Houston, there's a problem. So let's say that the memory for a sort, the estimate is like 1 row. So we allocate a memory grant for a sort of 1 row, which is more than one, it's not like a byte or something. But let's say all of a sudden we come to actually do the sort and it takes 1 million rows. Well, we have memory for the sort, but we don't have enough of it. We cannot dynamically grow that memory grant. So what we have to do is we have to use tempdb as a backing store for the sort memory. And we call that a sort spill, which results in poor performance. What about the other direction? What if the estimates are wrong feeding that operator? So we think we need to sort 1 billion rows and we only sort 1 row. Well, guess what? If these memory grants are too large, it can result in some bad behaviors like resource semaphore waits or plan cache eviction, which is kind of what that question was about. So these grants get too big, we have to actually take memory from other places, and plan cache is actually one of those, or if there's too many of these, you can get waiting scenarios. So what do you do about it? Well, first of all, in many cases, there's an opportunity to go look at the plan to find out a problem with estimates in the plan. But from an overall server perspective, resource governor can be used to limit the total amount of grants on the server. And one of the problems that we had with Resource Governor up until SQL 19 is it was a percentage number that only supported 1% or greater. So on a 1 terabyte system, that's still a lot of memory. So Resource Governor now, actually, oh, sorry about that. Resource Governor now supports values less than 1%. The other thing we did in SQL 17 and 19 is we adopted a mechanism through intelligent query processing where you change your compat level of your database. And we now can try to go take feedback from the query and change the grant the next time. So I said it's fixed memory allocated at startup. If we allocate that memory at startup and then we finish the query, we know if it was too low or too high at the end of the query. So what we can do in cache is we can adjust that value for the next time the query runs and avoid these too low or too high scenarios. That's called memory grant feedback. It doesn't change the estimated problem, but it actually can fix the symptom of the problem, which is a poor grant, which leads to, as you see in these cases, performance problems. So what about memory leaks? I showed you an example of a memory out of memory condition in SQL Server. So SQL Server itself manages all its memory. So if there was a leak within the SQL Server memory itself, let's say one of the developers that were doing memory grants, they own that code, they were leaking memory grant memory. Well, what would happen? What would happen is you'd get out of memory errors in SQL Server and potentially this kind of message 701. Why is that? Because that is fixed memory that doesn't go away and cannot be paged out. And so if that, remember that box I showed in the beginning where that gray thing was called fixed memory? If that thing is huge in your server, we can't shrink that. So if memory pressure kicks in, we all of a sudden can't get access memory for other fixed memory operations. So a memory leak within SQL Server is going to look like that. A external code leak, like let's say there was a DLL loaded in SQL Server that's not part of the SQL memory management system, that would look like a private byte leak. This is where you see that private byte leak line go way above the SQL Server total server memory. That would cause problems maybe within the Windows operating system itself, and that could generate external memory pressure or even eventually issues with the operating system. So unless there was a leak within the SQL OS allocator code, an actual private byte leak would be somebody else's code that's causing the problem. And by the way, on this memory leak for SQL Server, I mentioned one example where you could cause the leak that's not a bug, and that is opening up like a server cursor where you never close the cursor, because that's fixed memory that we cannot cache out. Okay, so let's talk about plan cache eviction, because this is a major performance impact that can happen. The buffer pool is a little more important, obviously, but it gets more memory than plan cache. So first of all, if memory pressure occurs because we're hitting that target, okay, and let's say external pressure occurs, or a large memory, let's say one of these three scenarios occurs. It's internal pressure because we're hitting the target, external pressure occurs, so we have to lower the target, which could result in internal pressure, or you get these large grants. That's going to cause us to go in and evict caches from plan cache, which is going to cause performance problems because what happens? We have to go back and load and recompile your query and put it back into cache. There is something called a clock hand in DMVs you can look at. Think of like a clock where we move a hand of a clock, and then eventually when it hits a certain number, we take an operation. So these memory pressure scenarios will cause the external clock hand to move for a given cache entry. And when it moves so many increments, then when we evict something from cache. So an internal clock hand, though, is a cap limit. So independent of these pressure problems, we cap the plan cache. There's a certain cap to it, and we don't allow it to be unlimited. So when you hit a cap limit, we call that an internal clock hand problem. So these DMVs will let you look at a given cache system and say, am I seeing a lot of movement of the external clock or the internal clock? So cache limits are more scenarios where maybe you're not being very smart about your cache, like a lot of ad hoc queries that are kept around in cache versus using stored procedures or something of that nature. And there's all this concept called cache wars, where we have other caching systems that are being used in SQL Server that could cause us to compete for this cache limit. So internal clock hand for cap limits and external clock hand for pressure. This is very important for you, because if you're getting a lot of plan cache eviction, you got to figure out which one of these problems am I running into so you can then accordingly take action. And then you asked about things in the error log. You might have caused this. Certain DBCC commands could cause us to flush the cache, obviously. There's also versions of this now per database. And some SP configure changes require us to do this. We've got those documented. you could be actually causing us to flush out the cache or to cause planned cache eviction. And then again, are you smart with what you cache? So I've had some people say, hey, Bob, I'm getting planned cache eviction. I'm hitting these cap limits. This is a problem for me. And I'm like, okay, well, what are you caching? And they're like, what do you mean, what am I caching? I'm like, well, do you have a lot of ad hoc queries that are getting kept into cache, or are you being smart with what you cache? There is also, I don't list it here in this slide, but we do have documented some trace flag you can use to actually up this cap limit. You can actually make changes and kind of slightly increase it if that is a problem for you. Okay, let's pivot now and talk a little bit about some containers, Kubernetes, and Azure, and then we'll finish with some questions. So first of all, SQL Server on Linux. So if you haven't heard about this or seen us talk about this, I wrote a book on it. A lot of people like Anthony and others in the community have blogged about it and talked about it. SQL Server Engine on Linux behaves the same as Windows. And what I mean by that is that the SQL Server Engine code is the Windows code inside Linux process. We use a concept called the SQL PAL. And remember the allocate API I showed you? We still use those APIs in the engine. What happens is the SQL PAL is allowed to trap those, not emulate them, but trap them and turn them into actual Linux kernel calls to allocate memory. So the engine itself, from a max server memory, from a ceiling, target, all that stuff, it behaves exactly the same as Windows. What the SQL PAL will do, which is, again, it's kind of, think of it as hurting the Linux process, is it uses a memory limit to expose to the SQL engine its maximum memory possible. So if you think about this, the memory limit MB, which is default 80% of physical, that is think of that as the operating system version of the SQL engine to see what it can go to. And you can adjust this if you want to. There's a configuration value for to change what is there. The lock pages concept is not applicable in Linux, but it can swap memory. So what we've run into in Linux, different than Windows, instead of working set trim problems, which again, it can do some swapping. But what happens in these extreme memory scenarios is this, the OOM killer. That sounds like a serial movie. It sounds like a movie, doesn't it? The OOM killer. So what happens in Linux is sometimes when Linux sees memory pressure issues in the operating system, it will terminate a process. Literally, it'll just kill a process. And that can happen to the SQL Server process, which is why we've had in some cases with customers to adjust this value here to affect so these problems won't happen. And we've got a really nice article in the documentation about how to tune other kernel parameters for Linux for memory. So again, if you're on a Linux system, the SQL Server behavior is the same for the engine, but you may adjust this memory limit MB depending on the configuration of what you're going to run on the system. What about containers? Well, right now we only support SQL Server Linux containers in production. So configuring the right amount of memory for container runtimes that require VMs is kind of important. Containers by default get access to all the memory in the virtual machine or the physical server. By default, imagine a SQL container behaving just like Linux here. That's exactly what it's going to do. It's going to run just like this by default. And these containers don't know about each other. So think about like the multi-instance scenario. If you've got multiple SQL Linux containers, now here's the part that's interesting. You can go in and take a container runtime like Docker and hear me?
Bob, you kind of drifted in and out for just a little bit there.
Yeah, I got some sort of message saying my internet connection was unstable, but I've got great connectivity, so I don't know if it's yeah, but are you guys now? Can you hear me all right?
Yes.
Okay, where should I pick up from just talking about here a little bit? What was the last thing you heard me say, Ree?
I don't remember.
It was like, what did you just say, Bob?
You talked about containers, so maybe like line 2 of your SQL Server.
Yeah, I'll just start over from this part here. So
Okay.
let me just start over. So first of all, containers are like SQL Linux.
Bob.
Going to behave like a SQL Server Linux with this upper.
Bob, you were drifting in and out again.
They don't cooperate with each other. They don't know about each other. Now, you can configure Docker or other container runtimes to limit the amount of memory a container process gets. But guess what? We don't know what that looks like. The SQL PAL code and SQL Server don't know how to recognize a container runtime limit threshold because this is the way it works. It's really weird. If you set a container runtime memory limit, the container gets all the access to the memory, but if it hits the limit, the container runtime will kill the process. So I do not recommend you use container runtime memory limitations. You should use SQL Server to limit the amount of memory you need in a containerized environment. Same thing for Kubernetes. Anthony is one that brought my attention to this back last year. Kubernetes, you configure the amount of memory for a given node in Kubernetes, okay? SQL Server is not aware of Kubernetes policies for eviction. So like what can happen in Kubernetes is you can have a pod running with a container and Kubernetes gets low on memory and it'll take that pod and move it to another node. It's almost like shutting SQL down and moving the thing. Or if there's no other nodes, it'll just kill it. Well, we don't know about those policies. We haven't written our code to say, oh, let's go see if we're running in Kubernetes. Should we adjust our memory policies? So you need to configure the right amount of memory for your node. Excuse me. You need to configure the right amount of memory for your node, or make sure you use the SQL Server Linux configuration policies to adjust and run in that environment. So that's just a few little nuggets about Linux containers and Kubernetes. What about Azure? So first of all, for Azure Virtual Machine, it's the same as SQL Server. Remember, this is just you running in the Azure infrastructure. And so the guest operating system, whether it's Linux or Windows, take everything we've talked about today and just treat it the same way. Now, you should know, though, that you may be picking sizes for Azure VMs. And so something called the memory optimized sizes that you see out there, you have all these choices for sizes. There's a family type. You're going to get a higher CPU to memory ratio if you're choosing the sizes within Azure. What's more interesting is Azure Managed Instance. With Managed Instance, the memory limit is going to be fixed per vCore. So a given vCore option you pick for Managed Instance, you get a certain amount of memory per that vCore. And in-memory LTP is only available with the business critical choice for Managed Instance. Now here's the interesting part. We're going to see a demo in a second. The memory limit is enforced by a Windows job object. A Windows job object is not a scheduler concept in Windows. It is a concept in Windows where you can take a process and you can enforce resource usage on that process like memory, CPU, and affinity. So behind the scenes, we will use a Windows job object to enforce these memory limits because you don't know how we're installing a managed instance. You don't know the VM behind the scenes. We pick and choose that for you. So we may pick you to run on a VM, but we're going to enforce these limits that we've already established, right? So you might get access and see things from a SQL perspective that you have slightly more memory in your VM, but the memory limit's enforced by the job object for a process. A similar concept for Azure SQL Database. Now the memory limits are more scaled. It's not a fixed amount per vCore. It's more of a scaled number that the higher vCores you go, kind of the more memory you get. We'll still use Windows job objects, and you can even get up to 4 terabytes of memory with our new business critical M series hardware choices. Same thing, MMLTP is only with business critical. Now you got this thing with something called serverless. In serverless, you have a min and max for cores. And so what happens here is we have min and max for memory limits for serverless based on those choices. Now, how does this work? Well, serverless is all about auto scaling and about pausing on idle scenarios. So in order to reclaim resources, if you're not using this serverless, something interesting, we may reclaim memory from your instance. And the way we do that is we're going to lower that ceiling on you. We're going to take that and we're going to treat it like an external memory pressure scenario because that's the only way for us to get memory back. If you go back and think about those diagrams, the only way for SQL Server to deallocate memory from the operating system is to lower the ceiling, right? To lower down the ceiling so that the usage of memory gets lowered. So if we lower the ceiling, the memory usage goes down. What does that mean? That means that in scenarios with serverless, when it's idle and you go back and use it again, we're going to have to warm back up the buffer pool cache and other types of caches. And then for hyperscale, the memory limits are the same as in a general purpose scenario. Today, but let me go look over at a VM I've got. Wait, that's not the right one. Let's go here. This is an Azure VM that's connected to both an Azure database and a managed instance. So for Azure database, let's still look at this first. First of all, you have something called here. Let's see. Let's run this thing. That's going to show you some data like your CPU limits and so forth. Unfortunately, it doesn't show you this memory limit number. So you need to look at something called DMOS job object. It's a new DMV. Hey, Ree, can you hear me? Ree,
yes,
okay?
I can. Okay. Yes, you do. You cut out for like a second or two, but you're good.
Yeah, it's really weird because my internet connectivity says on my side I'm really fine, but that's okay.
It's a Dallas thing. It's fine.
Ooh, oh my goodness. All right, so I may have to get on when Reed presents next time, and that's some fighting words. So DMOS job object is a new DMV for.
Hold on, Bob. You've gone quiet again. Bob,
How about now?
I can now.
Okay.
Yes, so you were out for about 10 seconds.
Well, I apologize to everybody online. Welcome to the world of running a massive virtual conference. All right. So,
And there's a whole lot of people in this session too. So
yeah. Well, hopefully everybody can still hear me okay.
yes,
So
we
just
can now.
to
You're good.
reiterate, DMOS job object is a DMV special to Azure, and it's going to show you the true memory limit you get for Azure SQL database. I also want to point out though that because Azure database is running behind the scenes on a dedicated SQL instance for you, even though you don't see the instance, you still get access to things like memory clerks, so you still can dive into those kind of things. Now, this is Azure managed instance. Managed instance is different. It's like a SQL Server instance, so you get to look at things like OS sysinfo and process memory. And notice here in OS sysinfo, it looks like you have like, I don't know, 46 gig of physical memory, but notice from DMOS job object, you only have 41 gig. This is an example of us using job object to limit. And again, it's not because we don't want you to get access to all the memory. It's just that we decide behind the scenes what VM infrastructure to put you in. And we need to enforce the limits that we've documented. So that's how we do that. In fact, in an error log, here's an error log entry for managed instance. You guys used to seeing that, like detected 46 gig of RAM. So I don't want you to get in these scenarios where you're looking at SQL instance level diagnostics and you're like, hey, what's going on here? My max server memory, I can't get my target to that number. Well, that's because the target is going to use that number. So keep that in mind. The target or the ceiling is going to use this memory limit MB number, not that number when you're looking at your overall information. In fact, you can see that from OS sysinfo. So if you run OS sysinfo, you can see here that the committed target, that memory object number, and not to the physical memory that you see in the VM. Okay, so we got about 3 minutes left, and all I have left here is resources for you. We'll finish with a few questions. All the decks are here. I will put up the deck and any of the scripts I showed you. I'll put that up on the 8KB GitHub that those guys set up. This is kind of some interesting information. We do have some architecture information in our docs. People don't realize we have that. We talk about buffer pool and plan cache and lock pages and so forth. So go check that out. And then there's a really good article that the CSS team keeps up to date. These are recommended updates and configuration settings for all the different things, a lot of things we talked about today that they have experienced over the years that you should be using on your enterprise server. Okay, was that, I mean, people can give me all sorts of feedback they want. Hopefully that was somewhat 400 level. I don't know, Hamish, was that 400 level? Was that too low? I don't know.
So there are a couple of pieces of feedback that we got. The best slide ever on SQL Server memory that I've ever seen. 6 minutes in and I'm already learning stuff. So a lot of really positive comments. So yes, this was definitely a session, the session everybody expected from
Well,
you.
if anything was negative on there, I bet it's Argenis. I bet Argenis is sneaking in a comment like, this guy's terrible or something. That's probably what he did.
It's absolutely Argenis, you're correct.
Yeah, it's got to be him, absolutely. So
yeah. No, that was a great session. Thanks, Bob. The cool thing is I've written some notes to talk to a DBA on Friday, New Zealand time. So we were talking about memory stuff. And
nice.
So yeah.
Any final Q&A you guys want to ask me before we wrap up?
Yeah, sure. Reed, do you have any questions on your side? Or we're off the same page?
You and I are off the same Q&A. So Bob, there have been a couple of like lower level questions that I've tried to take care of before we get here, so to make sure you can get to the 400 and 500 level stuff. So I'll let our same questions. Hamish, go ahead.
Sure. What happens in Azure SQL when you do it? If you did hit out of memory condition, would you expect to trigger a failover yourself? Or how do you monitor memory in production for Azure SQL?
Yeah, so first of all, we detect outages like that. So those are like failure conditions where we're going to fail you over. And you got to remember that no matter what Azure SQL option you pick, now for VM, by the way, that's up to you. Okay, for Azure SQL Database or MI, we've got automatic things in the background to detect if your SQL server is not available. You got to remember, even a general purpose installation is almost like a failover cluster instance. We can fail you over to another node and get you up and running again. So in many cases, when there's some sort of condition causing you server issues, you don't attack it because we've already failed you over anyways. But you still can monitor your memory usage of things that we talked about. And remember, you can't lower the ceiling. So you can't change max server memory. So the only reason that you're going to start having some issues potentially is a leak within the SQL code, which we would then fail you over. In fact, we would go detect that and go fix that somewhere. Or there's just massive pressure. But remember, we control what runs on these servers now. So some of these scenarios I talked about in Azure are not even possible because we control what runs on them. So we monitor and make sure we don't have external pressure stuff going on. We control what else runs on the server. And then if you have some sort of failure condition, we're going to actually fail you over. So that's kind of the beauties of platform as a service, right? We kind of handle a lot of this stuff. Does
Excellent.
that answer your question?
Sure does.
Yeah.
Thank you. Yeah. I'm just appreciative of the time.
Yes, thank you.
Yeah. So what I might do is just do one real quick last one.
Okay.
What is the best, quickest way to deal with resource semaphore in a live production SQL instance?
You need to go find out what the queries are doing. I've even seen resource semaphore waits occur because you just have way too many queries that have query plans with sorts and hashes, even if the grant is correct. So just go find out what the queries are doing. Then go look and see if this memory grant problem, like if they seem reasonable, go see if you've got a over memory grant issue. I will tell you that on SQL 19, with this memory grant feedback, I haven't anybody hit that because the feedback's kicking in and adjusting the memory. But if you do hit that, your choices are, of course, to go into Resource Governor and kind of control the amount of memory grants or go fix the actual problem yourself.
Awesome. Well, thanks, Bob. I tell you what, it's,
I'm going to stop sharing at this point, so let you guys kind of take back over.
This has been a wonderful session. It's definitely been worth staying up till 2:30 in the morning. Thank you so much.
Oh, Hamish, thanks for doing that. And thank you again for everybody on this call that's supporting this effort. And thanks all the organizers putting this together. We really appreciate it.
Thanks, Bob.
No, thank you very much, Bob. Okay, I'm going to share my screen just to get the...
Do I get a chance to shout out about the Browns instead of the Cowboys?
Not while I'm on the call, you don't.
You get a whole 75 minutes to do nothing but that, Aaron, if you want.
My goodness. I was trying to be nice.
You see, Bob, I was actually nice to you today and you blamed me for everything.
Yeah, the funny thing is I've got a bunch of other stuff to do today. I'm not even going to be on their sessions, so there's no telling what they're going to say. There's no telling.
I'll send you a report later.
I knew Ree would help me. I knew Ree or Anthony's going to look out for me. So yeah, but I can't trust Anthony because he's going to talk about the Eagles the whole time. So,
hey, you know what I learned yesterday? I just put 2 and 2 together. Ole Miss and Baylor is the Texas kickoff this year. Just
I saw that. That's going to be fun. Yeah, I saw that. Yes, so some smack talk coming up for that for sure. Well, thanks again for everybody. Good luck to all the good luck, Aaron, Argenis, all the rest of the presenters. Enjoy the rest of the day.
Thank you, Bob.
Thank you very much, Bob.
Thanks.
And to everyone out there, we have a link on the screen there for session feedback. Please go there. We've got one for the overall event and ones for the individual sessions. So please go fill those out. We really want to get your feedback on what you've liked about the event, what you haven't liked about it. Please let us know. So I'll leave that up for a few seconds there, and I'll switch back because next we have Aaron Salatamon. Aaron, you pretty much ready to go?
Yep. Whenever you're ready for me to start, I'm here.
Yeah, we got about 5 minutes, I think. So I'm just going to rotate through the slides a little bit.
Wait, we've got about 10 minutes if she's starting at 10:50 Eastern. Not to be the clock keeper, but
somebody has to be.
10:50.
Oh, is it 10:50? Sorry, my bad.
Yeah,
it's all right.
I printed the schedule and literally laid it right next to me because I don't want to be.
At least someone here is organized.
I got him. Usually the grown up in the room.
I did the same thing, Reeb. I just wrote it down. What time Bob starts, what times I start, what time I have to be done. Janice, you just hanging out, seeing what's going on?
I came here to make fun of people as well.
Okay.
It's my favorite thing to do. Anyway, no, I actually have a work meeting, so I joined briefly while, and then I have to do that, and then I'll be back.
capturing all the questions for Bob.
By the way, I'm loving this format, you guys. I'm serious. Like, this is awesome. Like, we should do more of this.
Well,
Maybe, I mean, not me. Like, not every
Right.
time me presenting. Right? Like,
So-
I'm not gonna commit to that. But hey, this is
that question is in the session or the event eval. How often do you want to see this happen? Like quarterly, monthly, yearly, weekly?
cool. Well, you see, I sort of struggle with. Oh, weekly is not going to happen. That's for sure.
Right.
But,
No, I'm just kidding. I'm just
I
kidding.
mean, let's not kid ourselves, right? But Zoom and Teams fatigue is a real thing.
Yes.
And I don't know that pushing, online conferences on everybody very frequently is going to be, as successful as whatever. But the format
I can't
is,
look at you and not laugh
there
right
was
now.
there was a need for like super high level content out there, sorely needed. And I'm so happy that you guys put this together. Thank you.
Yeah, I think that was the core concept when Mark and Andrew dreamt it up, was to fill that gap. Not that like all conferences are great, but I think like having this niche is hard to pitch at a conference, because we've all submitted advanced level sessions to a SQL Saturday and you get 4 people in the room, right? And that's cool because it's a tight niche audience and you can get into it. But I think this format aligns with the topic level better because you can cast a wider net more easily.
Nerds unite.
Pretty much, absolutely.
You're on fire, bro.
I'm literally on fire now. Everything's fine.
That's all good. That's all good.
Just a reminder too for everybody on the webinar right now that it is being streamed to YouTube, and the whole stream will be recorded there, and we'll also probably be breaking these sessions, or each of these sessions up into their own video and putting them up there. But yeah, you don't have to worry about missing anything. It will definitely all be available online.
Yeah, and stuff like memory management. Yeah, there's been some recent changes lately, obviously in 17 and 19, but that's core fundamental stuff, like kind of foundational knowledge that is, I think, stuff that you can build on especially in your troubleshooting systems, and having that under your belt.
It was great seeing Bob break out the debugger as well.
Yeah.
A couple of comments that pinged up for me was, I got this from the source code, which I found particularly great.
That was so unfair. Like, seriously? I mean,
You didn't take
that
the
was
source
he was
code
like
with you.
rubbing it in our face, like, oh, I have access to the source code. Seriously. I love Bob. I'm messing with him, of course.
Hamish, I'm impressed you're still standing, bud.
Yep. Yeah. I am literally standing. I'm at a stand-up desk. Yeah.
Here. So Hamish doesn't feel alone.
I'm standing.
Are you?
Yeah. I always do for presentations because normally I stand when I present. So when I'm at home, it just makes sense to do it as well.
Brilliant.
So about Hamish feeling alone, he lives in an island in the middle of the Pacific. So yes.
But he has 4 children, right? Hamish, 4 children? 7, I don't know, 8, a lot.
I once answered that. Someone asked me how many children I had, and I said at least 4.
Yeah, that you know of anyway.
I don't mind, Yeah, I live in a little island way down. We don't even figure on a map sometimes. I'm okay with that at the moment.
Don't send people over here. We don't want you.
Nice.
Okay, we're about 5 minutes ago. What I'm going to do is stop sharing my screen, so Erin, you can start sharing.
Sure.
There we go.
So let's share. Let's pick which one we're going to share.
There we go. That looks good.
Yep, looks good.
Let me just switch to Management Studio. Maybe. There we go.
Looks good.
Cool.
All good.
All right.
Okay.
Now I'm gonna have the Q&A up, but I just don't think I'm even gonna bother because That was a lot.
Yeah, just keep it closed. We'll manage it. Don't worry.
I know you will. I'm not worried about that.
Okay.
One thing to attendees, please use the Q&A section for asking questions. We're not monitoring the chat, so if you ask a question there, it might not get picked up. So please use the Q&A panel.
Argenis, you have time to go get Cheetos, right? Before your session. I think that should be done at the end.
Everyone is so obsessed with the Cheetos. I
You
will make
started
it
it.
happen. I guess I have to. I will make it
Are they the
happen now.
crunchy or the flaming hot?
You know, you've seen the gif of him like just dumping Cheetos, or the video
Yeah.
of him dumping Cheetos all over his face.
I mean, it's a natural human reaction to Cheetos, right? You just want to stuff them in your face.
No, you can have my Cheetos. I don't eat Cheetos.
Oh, come on.
I don't. Sorry.
My daughter used to take her Cheetos to school when she was on that kick, and then she would eat them with chopsticks so that she wouldn't get her fingers orange.
That is bizarre and brilliant at the same time.
That sounds like some serious chopstick skills.
Right?
To like
the fun of
handle a
eating
Cheeto.
Cheetos.
You know, Mohammed, I want to try your Afghan sauce thing with Cheetos. That'll be interesting.
What is that?
Oh, so Mohammed Darab's in the chat. He makes hot sauce, like some kind of hot sauce, and he brings it and gifts it to people, but he doesn't ship it to Atlanta, oddly. I don't know how that works, how it doesn't ever make it to Atlanta. Mohammed.
No. All right, I gotta get out of here. Good luck, Erin.
Thanks, bud.
Yeah, I got to go too. All the best, Darren.
Thank you.
Thank you, everyone. Have a good event.
Hamish, thank you very much, fella.
Yes, thank
I
you.
might
Thanks,
see
Hamish.
you later. All right.
All right, mate. Take it
Yes.
easy. Bye now.
So David says that he likes Cheetos in the US. I'm going to continue on this, but he doesn't get the different flavors in the UK. And David, I'm going to say that we don't get curly whirlies in the US like you do in the UK. So I would trade. And if y'all don't know what curly whirlies are, then I think you're missing out.
I was about to ask, a curly whirly sounds made up, but if it's
No.
British, never mind.
It's a caramel ribbon that's covered in chocolate, and it's this thin little bar. It's not even a bar. It's like it's a curly thing. That's why it's curly whirly. And they're my favorite. Oh, there's a link. Somebody put a link in there.
There's a couple of links.
UK chocolate's good. It's my favorite thing to
true.
do when I'm in the UK is go to the grocery store and buy a bunch of treats, right? Candy and whatnot, and then bring them back home, and then we eat them. Like taste test
So
them.
is anybody else like picturing Aaron in the grocery store in the UK, like a kid who's been given $100 in a convenience store before a road trip, and they're like just raking stuff off the shelf?
I have a picture. I have to find it. I have a picture of Jess and I, and we just have like our arms full. Like I had to buy a bag to carry it all out because I forgot, because I forgot to bring one. And it was several pounds worth.
Good. Nice. Okay, 1 minute, Aaron, and then you'll be on.
All right. Brian, I think that picture was on Twitter. I think Jess posted it when we were there for bits last year.
I think you should build it into your sessions.
Yeah, there's a lot I should build into my sessions, but I have issues with how long my sessions can be. So, working on it.
Page IO left curly whirly.
You know that we are at nerd status when that happens. I love it. Okay. All right. It's 10:50, friends, so I think that I'm good to get going. Thank you for joining, and I specifically want to give a shout out to Anthony, Mark, and Andrew for the chance to speak today. I really appreciate it. It's always an honor to be selected, and it's not anything I ever take for granted. So thank you, and thanks to Ree as well. Ree is moderating for me today. So we're going to talk about statistics in SQL Server, and just a couple things as we get rolling here. This is my yay me slide, and the most important thing on this slide is my email address, aaron@sqlskills.com. You have a Q&A, question and answer panel where you can ask questions, but if you don't get them answered today or you think of something later on, feel free to send me an email. I'm a consultant for SQL Skills. I list the team members up here because sometimes I refer to one of them during a session. So Kimberly and Paul are the owners, Jonathan, Tim, and myself are consultants, and we provide services and training. And if you want to learn more about the things that we offer, please visit our website. Just a couple of reminders. I feel like we've said this a few times, but just so that you don't have to ask again, the scripts for this session along with the PDF are going to be on the GitHub site for 8KB. And this session is being recorded, will be recorded, will also be available on the 8KB YouTube channel. And again, please put your questions in the Q&A. Chat is not being monitored. Chat's great for talking about chocolate, but anything related to questions, go into Q&A, please. So we're starting out with the abstract at the long ago advice of Buck Woody, which is let's make sure what we're talking about and why we're here. And this conference is about the internals, right, of SQL Server, how things work. And statistics are fundamental. You've got sessions today about memory, which you just heard from Bob, about IO from Argenis, TempDB from Pam, and AGs from Joey. And with regard to specifically things like the resources, memory, IO, CPU, so much of that and how those are used comes back to statistics. So it's essential. And I will debunk Bob's comment in his session about having to use the debugger. I didn't get that memo. I'll be really honest. I'm not using the debugger today, but I still think that this is good, deep content. And if you're not familiar with SQL Server or are just starting out and haven't done a lot with statistics, this is definitely going to be a ton of content for you. So this is just the abstract as a reminder of what we're going to talk about today. And our roadmap is a little bit of a review, talking about viewing statistics, what happens when they go bad, and then updating them, because there's really some important things to consider around updates. It seems pretty simple, but I'd argue that it's not. So the reason that we care so much, the reason that I care so much about statistics, this was one of the first topics that I talked about when I started presenting, is because this is the information about your data in your database, right? And specifically, it's the distribution of data in a column or set of columns in a table or an indexed view. And this information is stored as a blob in system tables. And it's vital for the query optimizer because it uses statistics to estimate how many rows are going to come back in a query, right? It's basically estimating what's called cardinality. And that then determines a ton of other things, right? This then says, what index should we use? Or do we need to scan a heap? Or do we need to seek or scan a non-clustered index? And how much memory do we need, right? Bob talked in his session about resource semaphore and memory being allocated for a query, right? That comes from statistics. So these are absolutely essential because good, accurate estimates are going to help the optimizer generate a good plan, right? That's always what we're looking for, is a quote unquote good plan. So a couple notes about options related to statistics to make sure that you've seen these and you kind of know what they are in your database. The first one is auto create statistics, which is enabled by default. You'll see it's set to true here. The next is auto update statistics, which is also enabled by default. General, I recommend leaving both of those enabled. Auto create, actually, I always leave enabled. Auto update statistics. There may be scenarios, but there are really some considerations around that. And in general, I'm going to tell you that I want you to have auto update enabled. Auto update statistics asynchronously is defaulted to false. There's a lot of people that say you should enable that. That's one of those settings that I want you to understand what it does so that you can make the decision. We'll come back to that later on. And then auto create incremental statistics is specific to partitioning. So if you're not using partitioning, don't worry about that. If you are, then it's probably something that you do want to enable. So how do we get statistics in the database? And the majority in your database are created automatically without you probably even being aware of it. So every time you create an index, a filtered indexed, or an indexed view, and I'm specifically talking about row store for this session, the majority of the time, whenever you create one of those indexes, a statistic is created. So for example, if we created a non-clustered index on the sales orders table on the order date column, and we query sys.stats after creating that index, what we will see here is a statistic. And where I sometimes find people get confused is that the statistic for an index has the same name as an index, but those are two entirely different entities, right? A non-clustered index or a clustered index, that's a physical representation of the data on disk. And a statistic is a blob that tells about the distribution. And for an index, they do have the same name, but they're two different entities. Now, we can also have statistics for individual columns in the database get created automatically. So if you query or you join on a column, you get a statistic. So in this example, we're querying on expected delivery date. And expected delivery date is not a leading column in any existing index on sales orders. So when I query that column for the very first time, and then I look in sys.stats, you'll see that I get a column level statistic automatically created for me by SQL Server. And I know that it's automatically created because of the naming convention. Nobody would probably ever name their statistic _WA_sys and then the numbers and letters that you see after it. So when you see that prefix, you know that it's a system created column level statistic. And not just when we query those columns, but also when we join on those columns. So if I expand this a little bit and join on the back order ID column, I also, when I check sys.stats, see that I have a statistic for that column as well. This is expected. This is normal. This is necessary for the optimizer because those statistics also provide information about the distribution of data in those particular columns. Now, as I said, you can create statistics manually. You can create them for individual columns. You can create them for across multiple columns and for filtered values in a column. This is not something I do frequently. Very rarely have I created single or multiple column statistics. I have created filtered column statistics for cases where I have a table that's really, really large and has a lot of skew. Kimberly has a great presentation that talks about skew in data and creating filtered statistics. She did a past session on that back in, I think, 2013. And it's on our website if you want more detail on that. I'm going to take a quick detour for one slide to mention column store and in-memory tables. The statistics that exist for column store are not the same thing that I'm going to talk about today. They have information about row groups and about the segments, but nothing like the density vector and the histogram that I'll refer to with row store. In-memory tables, which are not exactly row store either, but they do have index and column stats, although you cannot create a filtered statistic there. And there's a couple notes about that as well. But today's session is really focused around statistics we see for the row store tables. Now, how do we look at these? Because it's great that they get created and they're there and that's awesome, but I really want you to understand how to see them because this is going to help you understand how they're getting used by your query. So sys.stats is the main system view that I use to look at those. And you can also use stats date to see when the stat was updated. DBCC show statistics is it's my favorite DBCC command. I know that's dirty, but it really is. And it has three parts to it: the header, the density vector, and the histogram, which we're going to dive into. And in later versions of SQL Server, they've added a breakdown of some of this information. So DMDB stats properties has header info, and DMDB stats histogram is the histogram. I still tend to go back to show statistics, as you'll see here when we pop into this. So let's open that up. So I'm working with a copy of Wide World Importers that I've inflated. So just to make it a little bit more fun in terms of the data that we have. And I want to look to see what we have here for the indexes on the table. And I just like to always point out when I do that, that SP help index is built in and it's nice, but I really like Kimberly's version, which is an SP help index that she's written, because it gives me information like the index ID, and it doesn't just have the index keys. It also has any included columns. So when I'm tuning troubleshooting, I want to know if there's included columns in an index, and I go to this. I can also dig more into the internals with her script as well. But today we're really going to focus on this index right here, this index that's on the customer ID column on the orders table. And if I look at the statistics for this object, you can see that we've got our statistics for our clustered index here, for our non-clustered index here, and then for the column level stats that were automatically created by SQL Server. I like SP help stats here because it also lists the column. And that's the only way, unless you do a little bit more creative T-SQL, to quickly find what column a column statistic is on. But this is deprecated, but you know, it's still there, like a lot of other things that are deprecated. Now, show statistics is what I like to use to look at the statistics for a column. So let's look at what we've got for this customer ID. And we'll start with the header, right? This is when the statistic was last updated, which is just a little bit ago. I'm on Eastern time. So 10:13, this is when stats were updated. Number of rows in the table at the time of update, number of rows that were sampled. And statistics, even though they represent the data that's in the column, they are not constantly updated like an index is, right? The index always represents what's in the table. The statistic is not. It only represents what the data looked like at the time of the update. I also have, if I scroll over here to the right, some information about filter, if it's a filtered index, and then a persisted sample percent if I'm using that option. The density vector is here in the middle. This helps me understand the uniqueness of this column. And then down here, we have the histogram. And this is what I want folks to understand how to read. So we have customer ID. And this range high key is basically a different customer ID, customer ID 1, 4, 10, 15, etc. And the range rows, I'm going to hold for 1 second and hop over to the EQ rows or equal rows, right? So for a customer ID of 1, we have 5,346. For customer ID of 4, we have 5,457. Now there's several hundred customer IDs in this table, but in my histogram, I only have 200 steps max. I only have 188 in this one, which means that very often, not every row, not every customer ID is going to be represented in my histogram, which is why we have a range rows column. The range rows says that for every value between the previous entry and the current one, that's the number of rows that exist. So between 1 and 4, we have 10,891 rows. So for 2 and 3, basically we have 10,891 rows. And then distinct range rows is the number of distinct values in that range. So 2. And then the average is the math, right? 10,891 divided by 2. It's really easy when you break it down like that. And this is what the optimizer uses. So we have a couple alternatives. Again, I had mentioned this, DMDB stats properties and histogram for looking at this information. And I do like the stats properties because it gives me the rows and the rows sampled, as well as the modification counter, which we will also come back to. And again, here is the histogram. So the exact same information we saw before, right? For the customer ID value of 4, 5, 4, 5, 7 rows that equal that. Now let's enable the execution plan with our runtime statistics. And we're going to take a look back in this histogram specifically for customer ID 42. So let's scroll down here, and this is the row for customer ID 42. And it says there are 5,295 rows for a value of 42. So if we run our query and take a look at what SQL Server says, right? It says right here, this is the number of estimated rows, 5,295. That matches what was read or what was returned. So this estimate is accurate, right? And it pulled it right from the histogram. So what happens if we pick a value that's not in our histogram? So let's take a look back here, right? We had used 42 before, right? That matched. Let's take for a value 52. So 52 is not in our list. It falls between the 50 and 55. So we have 16,212 values or rows between 50 and 55. Three different distinct values. So the average there is 5,404. So what we should see here when we execute this and we look at our plan is we see that the estimate is 5,404. Okay, so even if the exact value isn't represented in the histogram, it still can obtain an estimate for that. Now, what happens if I use a local variable? So I'm going to declare my customer ID, set that equal to 42, and run that here. And we get a little bit different here, right? Instead, when we look at this, right, the estimated number of rows is 5,845, not exactly what we saw before. Now, why is that? It's because it doesn't know at optimization time what this is. So it uses the density instead. Remember, I had mentioned that and I said, I'll come back to it. So let's go back to that right now. This is the density vector. And this is basically how unique is this column. And the estimate that it gets in that plan is basically taking this density value, so 0.00158, and let's just make sure that's what I have in my equation, yes, times the number of rows in the table. So if we run that here, we get a 5845, which matches, right, what we saw in this plan, 5485. I'm horrible sometimes with remembering numbers, but there we go, right? So in some cases, it can actually, right, get the value exactly from the histogram, but sometimes it cannot. And so it has to use the density vector. It's important to understand the difference because in some cases it can be exceptionally wrong. Let me hop back to my slides here for a quick second. Let me minimize this. And I want to give you a visual for the histogram. So there's a question, you can have 201 steps. Yes. So 200 steps, one additional step in a histogram if you have a null. My customer ID doesn't allow a null, so we don't have that in mind. But here, if we took a histogram and we took that table basically and we flipped it on its side, this is what you would see, right? This is our distribution of data. And again, not every customer ID value is represented here because we have a limit of the number of steps that we can have. Now, sometimes when you're trying to understand the distribution of data, you probably do something like a count, right? Select the customer ID, the count from sales order, group by that customer ID, and then order by count descending. So when we look, I'm going to go back for a sec here. When we look here, right, I can see that there's definitely some skew in my data. I even see it a little bit better here, right, as that kind of tapers off. I like this visual representation to remind myself of how that data looks. Now I'm going to hop back here. What happens if I use a local variable again, but rather than an equality, I use a less than? So let's see what we get here in terms of our estimate. Notice that rather than seeking our non-clustered index, this switches to a clustered index scan. And the estimated number of rows that we get here is a lot larger. It's over 1 million. Not the same as what it returned, right? Our estimate's way different. And that's because in this case, when we're doing greater than, less than, our estimate is 30%. So if we do the math here, 1.1 million, right, which matches what we saw in the plan. So there are some cases where it can't do an actual peek into the histogram and do the math. So it has to come up with another way to estimate that data. Now we're going to take our query and we're going to push that into a stored procedure, because I'm going to guess a lot of folks have a stored procedure and have stored procedures in their system. And we're going to run this for the first time with a customer ID of 42. And 42 is a fairly unique. You understand that here that we get that same plan shape we saw before with a seek and a key lookup. And if I hover over this, we go back to the same value that we had before with that 5,295 rows. That's what it estimates. Now this plan, because it's a stored procedure, this gets cached. And so the next time I run this for a value of 823, we have that same plan in cache, but now you'll notice that the estimate, which was based on that initial value of 42, it doesn't really work here, because now we're getting 22,000 rows returned. And maybe this isn't the best plan for that particular value, but this is what happens when we have a procedure and it gets cached. So this can sometimes be problematic if you have a large amount of skew in your data. Now, if we do something a little bit interesting, like not pass in the customer ID, but pass in something else, and then declare the customer ID and set the customer ID and use it in a query, we haven't given the optimizer doesn't have the information that it needs at compilation to know what that customer ID is. And so its estimate ends up going back to the density vector. So I run this for a given order ID. And when we look at this index seek here, right, it goes back to the density vector value that we saw before, 5,845, even though just 177 rows are returned. That works out okay for that particular order ID. But for this one, it's a little bit different, because here we get, again, our 22,000 rows returned, which may not be ideal, because that's a lot of data, and that clustered index scan might be more efficient in that scenario. Now, what happens if rather than just doing some inequalities here, we do a little bit of a range of data? And we're going to expand that query that we started with, and we're going to also join over to order lines. And we're looking at a range of order dates. And I'm going to run both of these queries together and look at the plans for those side by side. So here you can see that we end up with kind of similar plans, but not. We both start with a clustered index scan. And when we look here for a 1 month date range, right, we're estimating about 1,900 rows or so. And that's what we get in the end. Down here with this clustered index scan for a larger date range, we're up to 98,000 rows. But we get some differences here in that with the larger set of data at the bottom, this feeds into a hash match. And what we see on the order line side is an index scan, because the estimate against order lines also depends on how many rows it thinks is coming out of the orders table. And in the case where we have a smaller amount of data coming out of the orders table, it doesn't scan an index against order lines, it does an index seek. So estimates don't just affect that one table, they're going to propagate, right, and affect the entire set of tables and the plan that gets generated when you're joining tables together. And in the worst case scenario, what can happen is that a poor estimate can propagate all the way across the plan and choose non-optimal parameters, or excuse me, non-optimal operators. And just as a reminder, we do have statistics on order date, even though that's not in an index. We do have a column index, excuse me, a column statistic that gives us information about the date. So the optimizer can use that. Now, we're not going to be very nice here. We're going to mess with the optimizer a little bit, and we're going to look at the number of rows and the number of pages in this table. So in this clustered index, we've got 3.6 million rows, and we've got about 34,000 pages. So what happens if we mess with the optimizer? And don't try this at home. This really should say, like, don't try this in production. Don't do this in any important database at all, because you can't actually undo it as completely without updating stats and things like that. So we're going to say update statistics, and we're going to specify a row count of 1 million, which is less than a third of what's actually in the table. And we're going to drop the page count to 9,000. So I tried to kind of do a realistic assessment of, if I drop this to 1 million rows, what's the appropriate page count? So it's about 9,000. So we're going to totally lie to the optimizer. And we're going to rerun both of these queries, exact same input values, right? One is for 1 month, January. The second is for June. And now this is completely, these plans are similar to what we saw before, but our estimates are very different, right? In terms of how many rows it thinks it's going to return, right? This is 522. We still have a similar plan. And for here, our estimate is 26,000, which is way less than it was before. Now, if you look at the shape of these plans, they're the same shape that we had before for both of them. But what we've done is we've influenced not just the number of rows that it thinks it's going to return, but also how much memory it needs for the query. Again, one of the things that Bob talked about in his session was resource semaphore, right? And the fact that that grants memory to queries based on its estimates. And so here, we didn't have this before, but now you can see that for our sort, we have a warning. Because what has happened is that we didn't have enough memory allocated because the estimate was wrong, and this has spilled to disk. The irony of this session today is that I've spent the past 2 weeks working with a customer on issues related to statistics, and it first manifested as a bunch of queries with sorts and hashes spilling to disk that didn't previously. So the estimates were off in their environment because stats hadn't been updated. And they have lots and lots of large tables, tables that are 100 million rows and higher, that didn't have good estimates and thus were spilling out to TempDB. So particularly with operators like hash and sort, which rely on those estimates to determine how much memory, these statistics really become critical. And if we open up the properties here for our plan and we go onto our select, you can see here the memory grant initially is 2528. This is in KB. And for our next query that it requested a lot more, and it still wasn't enough, right? Because we totally lied to the estimator, or the optimizer, about what it needed. Now, this statement kind of cleans up statistics. And I say kind of because if we make that change and then come back and look at what we have in sys partitions, you'll see that the row count still sits here at 1 million. My page count fixed right up, but I would have to do an update statistics to get that to be correct. I'm just going to leave it there for demo's sake, because I like showing how poorly this can behave. I'm going to make a change here where I'm going to turn row mode memory grant feedback off. This is a new feature in 2019. And if you were listening to Bob's session, he made a comment that with this in 2019, he hasn't seen the same type of memory grant problems. So I'm not saying that you should disable it in any way, shape, or form. But for this example, we're going to take that query and we're going to put it into a stored procedure and run it without memory grant feedback. And I'm going to run it the first time. This is rude. I'm going to run it the first time with a small amount of data estimated to get this plan into cache. So this looks okay. We've got this sort and we have the nested loops. So this is the only place where it's really going to request a significant amount of memory based on our estimate. And so if I run this for 6 months worth of data, we can see that this spills, right? You can see in the pop-up that we've got the warning that this has spilled to disk. So this wrote 504 pages. And as we get even higher, this spills even worse when I ask for more data, because again, the estimate is based upon that those values from the initial compilation. And we are not allowing it to get any kind of feedback. And this is what's happening in 2017 and below. And you don't have an alternative until you upgrade. And what we see here with this sort is now we're not talking just about a few hundred pages. We're talking about 9,920, right? And this took significantly longer to execute than the previous iterations. So memory grant feedback is very helpful. It is not, in my opinion, a complete replacement for making sure your stats are updated. So if I rerun all 3 of these again, after updating, changing the database option, to turn memory grant feedback back on, when I look at my output here, right, this is the plan that gets cached. I still do get a warning here. And if we look at the properties for the plan, one of the things you'll note is that if we look here at the memory grant info, this is kind of helpful, right? We can see the memory that gets estimated here. And before, this wouldn't have changed. But in terms of the memory grant info, it doesn't change after this first execution. But on our second execution, this should pop up. Now, I probably needed to do a recompile in here. So let me just drop this and recreate this. After changing that option, I would have expected the plan cache to clear. So we're going to make sure that this is enabled. It's possible I didn't run that. And then run all of these again, because we should see that memory grant feedback kick in. Again, that can help in a scenario where we have wildly varying data and it's difficult to make your code handle that. Or in a case where statistics are just woefully out of date, or where you've got an issue with how the data is moving through the plan, and you want to kind of let SQL Server help you out and address that. So let's see, 2464 here. Let's come back in here. If it's still in 264, I'm going to just call this demo a little bit of a wash and not worry about it for the moment. But that should be in play here in 2019. I'm not sure why it's not running for me perfectly. But I'm going to pause, take a drink of my water, see if I got any questions.
We do have a few questions. So let's see. Why is auto create statistics still an option to turn off? As in, when would you benefit from having no stats for columns in tables?
Auto update or auto create?
He says auto create stats.
So you're saying, why haven't they removed the option? Because there's probably someone out there who doesn't have it enabled, and it would be a problem if they did. Like, do I know that person or that company? No. Do I think it should be off? No.
Okay. Regarding statistics, is there any way to manually update stats asynchronously?
Is there any way to manually update stats asynchronously? I don't quite understand that question, because when you manually update statistics, you decide when they're going to update, right? So you can decide, I want to update them now or later. The async option means that when the auto update kicks in, rather than updating right when the query that uses that statistic executes and basically holding up that execution, it does that in the background. So if you can maybe rephrase that so I can understand a little bit better.
Okay, so Ruben, if you're still listening, that was your question. If you want to offer clarity, we'll try to get to it. How is the density vector value calculated?
It's based upon the uniqueness of the statistics, so or the values in the column, right? So how many unique values do I have in this column? Based upon the number of rows in it, that determines that density.
And is the 30% figure for range queries hard-coded or based on some estimate of a value's position in the total table data range?
That's hard-coded. So whether I used a value of 1 or whether I used the max value, the estimate's 30%. in that particular scenario.
And a question of clarity, do you get 200 rows per partition or per statistic for the histogram?
If I'm using partitioning, I believe that's specific to partitioning. So if you turn on incremental statistics, which is that database option, then you're going to get histograms for the partition. But the kicker, and then you can update statistics at the partition level. But the kicker is that partition level statistic information gets folded into the table, or excuse me, the index level statistic, and the index level statistic is what the optimizer uses. So I have a blog post. I have one or two that talk about that. It's a deficit, in my opinion, with regard to partition statistics.
Let's see. Let's grab one more. Does feedback use only the previous execution? So can you get a ping pong effect where it adjusts up and down when you run against wide variations back to back?
It can, and if it is going up and down too much, it can eventually just turn itself off. So it will adjust based upon the different values that you're entering. And it can, if it's going up and down, up and down, up and down, it can decide to turn itself off.
Okay, I will let you go ahead and get back. We'll save any other questions.
Cool. I'm gonna run something for my next set of demos. I'm gonna hop back here to the slides. And this is really just one slide before I hop back to a demo, because I'm a very visual person. And I think that statistics are something that you really need to see. So I don't spend a ton of time in my slides. But I want to have a little prep here now for how the optimizer uses statistics. You've seen this a little bit, right, in the sense of estimating how many rows are going to come back. And we messed with this in that last demo for memory grants. So it's going to figure out, okay, how many rows do we have? And based on those rows, how much memory do I need to allocate for a hash or a sort? It's also looking at that estimate to decide, how am I going to go get the data? And so you pass in your query to the optimizer, and it's going to decide, right, what object am I going to use? And by object, I mean index. Am I going to use a clustered index, a non-clustered index, an indexed view, right, or a heap? What am I going to do? And then am I going to seek or am I going to scan that in order to find the information? Again, based on how much data I think it's going to return. It's also going to influence the type of join. We're going to see this in the upcoming demo. And we looked at it a little bit in the past one. Sometimes we get a nested loop, sometimes we get a hash match. And then again, how much memory are we going to need? Now there's more things that it influences. This is just kind of where I'm focusing today based on time. So part of the optimizer is to estimate all this, decide what objects you're going to use, and then put that plan together and pass that along. So what happens when stats go bad? And I've purposefully made stats go bad in this demo. So before, in that first demo that we rolled through, I had everything all good and up to date. Now I do not. We're still using the same database, wide world importers B because I blew it up. And we're going to look at customer ID statistics here. And this is a little bit different than what we saw before. Before we had a full scan, right? 3.6 million rows, and we'd sampled all 3.6 million. Here we've got a default scan. And a lot of times I'll tell you the default scan is fine, but there are cases where it's not, depending on your distribution of data. So we have in this histogram, we end up with actually 200 steps rather than the 188 that we had before. But we're still working with column ID, excuse me, with customer ID. And we're going to turn on statistics IO and time. And we're going to run this query that we ran before, but now we're going to join to order line. So before we just queried orders for customer ID 42, now we're going to query both orders and order lines. So we get that little bit bigger plan. Let's make sure that I'm viewing the plan with my runtime stats in there. And here we go. So here's my index seek, and our estimate is just a tiny bit different because we are using a default sample. So it doesn't quite have the numbers that we had with the full scan. So here it's estimating 5,488. We actually come back with 5,295. So that's not too bad, right? That estimate isn't too out of whack. And if we look at what we have for IO, against that orders table, we get about 16,000 reads. And against order lines, we get 49,000. Now let's try with a different customer ID. Excuse me. We're going to go with 823. Also an important error in SQL Server. Now, we get the same shape, right? The same plan shape. We've got an index seek with the key lookup. And if we look here, what it estimated, about 5,500 rows, but now we get 22,000 rows returned. So estimate and our actuals are off, right, by a factor of 4. And it doesn't look so bad when we look at the plan, right? It's hard to tell sometimes just by looking at a plan, oh, this isn't great. But when we look here, now we went up to 279,000 reads and 67,000 reads against orders. Let's see what happens with 422. And there's a method to this madness. And this is taking a little bit longer, right? Now we're up to 3 seconds to execute. And same plan shape that we had before. And now our numbers are way off, right? This estimated 2,700 rows, and it actually returned 119,000. And if we look at our IOs, we went up to 1.1 million against order lines and 366,000. So this is just way out of whack. And you look at this demo and you're like, wow, that's a lot of reads. I'm thinking, you know what? This is a lot of reads, particularly if it's a query that runs a lot. And 3 seconds in a demo doesn't feel that long. But to users who are used to queries returning in 100 or 200 milliseconds, 100 or 200 milliseconds, when you throw a 3-second query at them, they know. Like, I've talked to those users and they know when things are slow. They can't tell you why, right? But they know that it is not what it is supposed to be. So I'm going to take note of this data and let's just look at stats really quick. So if we look for 422 in our histogram, right? It has an estimate of 2,700 rows, but obviously that's not correct because we had we had a few thousand coming out of that. And now we're really going to mess with the data. We're going to update a whole bunch of rows in orders to have the customer ID of 422. So this is kind of rude because, again, we're kind of messing with the optimizer here, but I want you to understand what can happen if these are out of date. And I'm going to turn on the live query stats, because this is one of the things that I run into in troubleshooting. I'm going to run this query. It's going to have the same estimate as before. It's going to have the same plan as before. But when you watch the live execution, right, you can start to see, right, that over here on the right, this index seek was supposed to be 2,700 rows, and it's way above that at this point. And that takes about 9 seconds to complete. And in a production environment with even more data, something like this takes even longer, because this estimate with the seek and the key lookup into a nested loop is incredibly inefficient for this many rows, right? This should be a merge or a hash going on. And this is very often where I see issues with statistics bubble up as problems. A lot of times that we get plans that have nested loops when we really should be doing hashes or merges, and these just take a long time. And these don't drive IO like our other queries, and they just kind of trickle along. They just take a long time to execute. Now, I made that whole thing possible by turning off auto update. So I totally messed with that setting. I told you to leave it on, and then I went and turned it off. Now I'm going to turn it back on. And back in the context of our database, and let's make sure that we have our plan with our runtime stats. We do. At this point, we're going to look at what happens when we query 422. And remember, before we had an estimate of like 2,700 rows for that. And now, if we take a look after this finishes, what do we get? We have a different plan. Right? Now we have a clustered index scan, and it feeds into a hash match, as I said, because now we have much better estimates, right? It thinks 683,000, actual was 688,000. So when I turned auto update stats back on, and then I ran that query again, it said, hey, I'm going to update statistics because they are woefully out of date. And it did. It still updated them with the default sample, but this is 1134, right? So this just happened. Let me hop back to my slides for one sec. Automatic updates, I think for the most part, are a good thing in SQL Server, right? You need to have the auto update statistics option enabled. And the auto update kicks in when the number of modifications to the column for the statistics exceeds a particular threshold. And there's two thresholds that you've got to be aware of. There's the old threshold, which was 20% of the rows plus 500 changed, right? When that threshold was hit, then it would go ahead and update. It would mark the statistics as invalid. And the next time you ran a query that used those statistics, it would update them. The new threshold is the square root of 1,000 times the number of rows in the table. And this new threshold is way smaller than the old one. Because if you think about tables with 100 million rows or 10 million rows, 20% plus 500 was a long time to get to. And so for some tables that are really volatile, that are larger, customers needed this new threshold, right? They needed them to update more quickly. So this is the default behavior in 2016 and higher if you have compatibility mode 130 or higher if you're on a later version. You can enable this on earlier versions using trace flag 2371. So that goes all the way back to 2008 R2 SP1. So I just wanted to point out that update because now we're going to talk about these automatic updates with SQL Server and what happens with our plans. So particularly, I want to talk about the plans as they relate to our procedures. So here's stored procedure. Looks just like our query, right? We're just passing in customer ID. So we're going to run this first with a customer ID of 192, and we're going to run it 10 times. And it's going to go through and it's going to give us the plan for every single one. And this plan is an index seek with a key loop. So this is a more unique value. You've seen, right, that we're shifting between two plans because this is a parameter sensitive query. So this time around, our estimate was 5,800. It was just a little bit under that. So, but it was pretty accurate. And we ran it 10 times. So now if we look in the plan cache, we should see in the plan cache, right, an execution count of 10. And this plan was created at 1137. And we also have our plan over here along with our text. That's great. Now let's understand a little bit more about this modification and this threshold and when we're going to have an update. So if we look at sales order and we specifically look at our non-clustered index and the statistic for that, right, we can see that this was last updated at 1134, right? These other ones haven't been, but here at 1134 was a default sample, right? Was not a full scan. And under the old threshold, we would have to modify 737,000 rows before an auto update would kick in. The new threshold, as I said, significantly lower. This is 60,000. So let's see what happens when that gets kicked in. So we're going to go ahead and we're going to update about 60 and change. I think it is 70 and change. There we go. And if we look back here at that same output that we looked at before, right here, we can see, okay, we've had modifications of customer ID that exceeds our 60,000 threshold. Now, at this point, right, the statistic has been marked as invalidated, but it hasn't been updated yet. But when I run this stored procedure, it will note that and it will go ahead and update them. And so if I look here in the plan, everything kind of looks the same here, right? This is the same shape. Our estimate compared to our actual is pretty good. It's spot on. Did statistics really update? Yes, 1139. We have a little bit later time, still with the default sample. And if I double check back against sys.stats, my row modification counter was reset, right? So when it updates statistics, it resets that row modification counter. And if I check within the plan cache, my execution count is now just going to be 1, right? Plan generation num 2, right? Creation time 1139. So updating stats causes my plans to recompile. Now, sometimes this is what causes an issue because maybe you have that good plan in cache, which works really well for most of your data. And then your stats update and the plan recompiles. And the next execution is with a not so good value. And tracking that, finding that can be a little bit tricky, which is where extended events comes in. We can track auto updates to recompiles to understand if that's what's causing a shift in our plan. Now, query store is also extremely helpful here in looking at plan history, but this helps us pinpoint that the plan changed because of a recompile. So for the auto stats event, we're going to filter on our database ID. And for our recompile event, we're filtering on specifically on statistics update. So we'll go ahead and start that up. And then we're going to start the event session. And I'm going to, within Management Studio, we're going to watch live data. And I'm going to try to view this side by side. This worked when I had a larger resolution. Hopefully it still works good now. So we're going to go ahead and update some data because I need to modify data in order to have the auto update kick in, right? So we'll go ahead and make this change. And at this point, all we've done is change the data. The stats are invalidated. And if you look here, right, you'll see that this just says loading stats without updating, loading stats without updating. So the auto stats event fires a fair bit. So you definitely want to filter if you use that. Now, if we look to see how much data has changed at this point for this particular statistic, we can see that we've got about 100,000 modifications. That exceeds that threshold. So now if I rerun my stored procedure, here's my execution plan, right? A little bit different. And I'm going to pause over here in this viewer and take a look and go back up because we saw it, right? Here is the recompile event right here. And the recompile has the object name, right? My store procedure name. My recompile reason is that the statistics changed. I have the statement as well here. Where did this go? There it is. And I have auto stats tied to that. So here is my other for an auto stats entry, which is that it was actually a statistics update and it tells me what statistic updated. So sometimes when you've got some volatility in your tables and you've got plans that seem to be shifting a lot, this type of event session can help you narrow down and confirm that statistics is the problem. So we'll go ahead and stop our event session. And I want to roll through one final scenario here, a potentially problematic one. We're going to recompile that stored procedure. We're going to force that to happen. And we're going to run it with customer ID 414. And this plan is that more unique value plan, right? Which has our index seek and the key lookup that feed into the nested loop. So this works really well for our more unique values. And if you think back to the distribution of data in this column, it's pretty flat for the most part. This plan works for a lot of the data. Now we're going to update data one more time, but this time we're not going to update the orders table. We're going to update order lines, and we're going to mess with order ID. And now in a production environment, we obviously don't go updating data willy-nilly, but data gets added, right? And data gets modified. And this is a query that joins to two tables. So the statistics for multiple tables are involved in a plan. And if we look at our non-clustered index here, we can see that we have a decent number of modifications across the board. We've just exceeded that threshold of 8,600 here for this non-clustered index, which is what we were using in that plan. Let's just double check, right? Let's confirm, right? This sales order lines order ID non-clustered index, that's what we just modified a bunch of data in. And if we look at this plan in cache for our procedure, right? It reads against that. This is the orders table. Here it is. Against that non-clustered index. So we haven't touched orders. We've only messed with order lines. Now, what happens when we run this with a different input parameter after modifying that data? if we look at our plan shifted. And I want to use Query Store to show you this just in a little bit better detail, because it's the fastest way for me to do it, to be quite frank. Let's bring this back to center. Right over here, if I switch this into my grid view, and this is my query in question, right? You can see that I have these two plans. And if I open them up and compare them side by side, you can very easily see the difference here. Now, when we look at this data, right, the duration total isn't really what I'm interested in. I'm more interested in average duration. And when I take a query from 200 milliseconds to 800 milliseconds, right, people are going to notice. In the demo, it's not as easy to see, but in a production environment, when this happens, right, you suddenly get notified of, hey, what happened here, right? All the time I'm trying to run this, now all of a sudden, all these executions are slower. And if you don't know that that plan changed, you're like, what the heck happened? What went on? And so, you know, you can look in cache and you can say, okay, we've got, you know, this plan. This doesn't look like a good plan. I'm not 100% sure why we got this plan. Maybe we have an issue with statistics, right? This is an initial troubleshooting response so many times, right? And so you look at the orders table because that's what drives this query. And so people tend to go there first, and you look and you're like, oh, man, we don't have a full scan. I wonder if we need to have a full scan. And so you fix it. You fix it by updating with a full scan. And here's the thing. A lot of times that seems to quote unquote work because you just caused a recompile. However, there are cases where updating statistics doesn't recompile. And I'm going to run this again with this input parameter. And you'll see that we have the same plan against that clustered index. So we updated stats, but the plan did not get invalidated, right? I can see that they're updated. I updated them with a full scan, and that's exactly what happened. But if we look in the plan cache, this has eight executions, right? It just executed and it didn't recompile. And this is one of the things that is a take-home message right here. In SQL Server 2020 and higher, when stats are updated, if no data has changed, we didn't have the modification counter change, then plans won't invalidate. It'll update stats like it just did, but my plans, they weren't invalidated because stats hadn't changed, and so the optimizer saw no reason to do that. Now, before 2012, if you updated stats and you had auto update stats enabled, plans were invalidated, regardless of whether data had changed or not. But there's a fun little caveat here. And I mention this because I know that some people still have below 2012, right? If you updated stats and you had auto update disabled, plans were not invalidated. So this was kind of a tricky scenario. And I mention this specifically not for, no offense, those of you who are on older versions, but for those of you that are on 2012 and higher, if updating stats is your first response, that may appear to fix the problem, but it really hasn't solved it. In some cases, it's not going to do anything, right, if data hasn't changed. So I think that's a really important thing to be aware of. So you need to manage stats. They're going to update automatically if auto update's enabled. And this can be asynchronous and probably isn't necessarily a bad option for you to have enabled. Just understand that when you have asynchronous update enabled, when it encounters a statistic that's been invalidated as part of a query plan, if async is enabled, it's going to go ahead and run that query with whatever plan was in cache, and it will update stats in the background. If you have that disabled, which is the default, it updates stats right away. If that's a problem, if updating stats right away means that queries are being held up, in 2019, you'll see a new wait type on that, wait on sync stats refresh. So this is something to look for if you think that auto updates are occurring a lot in your environment and it's causing problems. Now, I put the threshold comparison in here because I think this is just an interesting thing to note, right? Notice how much lower that threshold is in the new scenario compared to the older one. And For cases like a table that's 1 billion rows, it only takes 1 million modifications. And one of the environments that I've been looking at lately that has a couple billion row tables, one is like 2.5 billion. They have 200, 300, 400,000 modifications a day, which means if I'm not managing statistics in some way, they could update in the middle of the day. Now, that could potentially be a drain on resources, and I may want to manage that, which is why auto update stats I recommend being enabled, but you want to have something in place to manually manage stats. Whether you have a custom script that you've set up, whether you use OLA script to manage that, you want to have something in place. And the question that I always get is, what should that be? And there's a lot of other things, a lot of other considerations before I give you that kind of an answer. There are some options that are really useful. No recompute and persist sample percent. No recompute, when you update a statistic with that option, means that if my stat gets out of date, if my modifications exceed the threshold, don't automatically update it, even if auto update is enabled. So for some customer environments where they have really, 400, 500 million row tables, billion row tables, I'll put that on for them because I don't want those to go off in the middle of the day. Persist sample percent I use for tables that have a lot of skew and I want to have a full scan for. So I'll do a persist sample percent of a full scan for tables for indexes that are volatile, so that when it updates subsequently, it doesn't go back to a default sample. It always has the sample percent that I've specified, which is typically a full scan. That was introduced in 2016 SP1 CU4 and 2017 CU1, and obviously it's there in 2019 as well. So when your estimates in plans are off, you can have some issues as we've seen today, right? And some typical reasons, right? I don't have time to cover them all, unfortunately. Common one is stats haven't been updated, or perhaps the sample rate is too low with the default, or even if it is with a full scan, there's a really uneven distribution of data and that doesn't get captured in 200 steps. Ascending keys can be an issue. That's a lot better in the current releases. Table variables don't have the same kind of estimates that you get for temp tables. Local variables and modifying things in flight can absolutely confuse the optimizer. Linked servers, partition tables, as I briefly mentioned, and then again, in-memory OLTP. So what you're looking for is, do my estimates and my actuals kind of line up? And if they don't, then you have to start to dig in to understand why. So we rolled through reviewing stats, how to view them, what happens when they go wrong, and then updating stats as well. And I've got a couple blog posts to reference that the first one is mine. The second one is Kimberly, which goes through that problem I just talked about with stats not updating, with stats updating, but plans not recompiling. And then a couple of things related to maintenance, because I suspect that some of those are going to come up here. So I have time for questions for Ree, and I'm going to leave this up here for a minute, just as a reminder that you can download the scripts, and please make sure you provide some feedback. So what else do we have here for questions?
Okay, so we have a lot of questions about updating stats and updating stats. So I don't think I realized there's probably a market for a session on nothing but update stats. So let's kind of knock these out really quickly, and then we'll get to some of the heavier ones. Have you ever seen problems with updating stats with sampling, i.e. 25 or 50%? You may have covered that on the last slide.
I have seen issues with that. Frankly, I feel like it's either a default or an all. I've done some testing with like 25, 50, 75. And there comes a point, it's a blog post out there, there comes a point where I think that updating with 50 or 75% isn't worth the time. You might as well just update with a full scan, because it doesn't really save you anything in terms of time and resource use. So I wouldn't say problems per se, but I don't know that it's worth that effort to try to make it that granular.
Okay. Is there a way to increase memory grants of the query without updating stats?
You can set a max and min grant percentage. It's a query option that you can add, but boy, you got to know your data and you got to know what you're doing in there, because you're coding that into the you're coding that into the query. You can't modify that after the fact, right? Bob had talked about that, right? Once you get that memory for the query, that's what you get. You don't get any more, and you don't give it back until you're done with the query.
Okay, so I have two that I think are related, so I'm going to ask them together. Have you ever encountered a situation where auto update stats was a bad thing? And then there's another question: will auto update stats create any blocking?
So I'm going to answer just about auto update stats causing blocking, right? When you update statistics, it takes a schema mod lock. So it can kind of block in that scenario, in that you can't make any schema changes, but it's not going to prevent inserts, updates, deletes from occurring, right? It doesn't block in the same way that a rebuild would. Now, have I ever had a scenario where I turned auto update off? There was a time, and this was well over 8 years ago, when I worked at a software company, where we used to recommend that under the premise that we didn't want stats to automatically update during the day. But the thing is there are so many stats that get updated that you don't even think about potentially, that when you turn that off, you are missing. So I would encourage you to take this query. Actually, you know what? I dropped it at the end of this one. It's at the bottom. I didn't really show this query, but I have it because I like it and I wanted you to have it. This down here, and I'm going to comment out my predicate, which run with caution in production, because this is going to return a lot of rows. But there's all of these other statistics in your database for system objects. And if you do anything with temp tables, or if you have something that creates a table and drops a table, etc., it would help if I ran this in my database, not in master. You're going to have things that are being modified all the time. And some of these are smaller objects that need really frequent updates. So historically, in the past, yes, I had seen a case where I would have turned it off, but I will tell you right now, I don't have a good one for you.
Okay. Let's see. With the auto update statistics option, update stats with or without the full scan option? And if it updates without, how can I force the update with full scan?
So it's going to update just with the default. If you want it to do a full scan, then you want to use that persist sample percent option right back here. So persist sample percent, when you run that, it's going to say every time that stat gets updated after that, use that same percentage. So again, for those tables with skew, I'll set the persist sample percent of 100. So it's a full scan, and whether they get updated as part of a job or automatically, it'll be with that rate.
Okay, so let's jump to a few other questions. So is the auto updates to stats behavior now tied to database compatibility level in 2016 or higher? An example, for folks who run a DB in, say, 2008 R2 compat level on a 2016 SQL server.
Yes. So here's the threshold as a reminder, right? So that new threshold, if you want to use that and you're running 2016 and you're running compat mode 100, you need to use 2371. And actually the resource, come down through here in my resources, this second post, controlling auto stat behavior in SQL Server, talks about that specifically.
Okay. There's a whole lot of questions. I'm trying to.
That's okay.
We have some time. We have like 6 minutes left. Yeah.
I know.
So what will be the estimation for combination of multiple columns, not from the same index, without multi-column stats created explicitly?
So when you create a statistic, you can only create it on column or columns in the same table. So I can't create a statistic across, let's say, customer ID in the orders table and something else in the order lines table. So the estimates are going to come from the stats, and then the cardinality estimator, right, the optimizer, is what then has an algorithm to determine, okay, based on this stat and this stat, right, what's going to happen. And that ties to the CE, the cardinality estimator version, right, which changed between 2012 and 2014. In 2014, we have the new CE and a higher version. So now you have two basically cardinality estimators available to you, and they each have a different algorithm for how they do that. There's a good white paper that talks about that.
Okay. Can we insert a statistics step in Histogram for a particular order ID in one of the examples that you used?
No, you can't. You can't mess with that histogram. In Oracle, you can do cool things like exporting stats and importing them back in. You can't do that with SQL Server.
Okay. Can you recommend somewhere people could get some information on, it says columnar structure tables?
Column store?
It says column structure tables.
If it's column store, I would recommend Nico's blog. He is probably my go-to there. So hang on. I assume that columnar means column store. So here. So I would recommend if columnar means column store, go here.
Okay. So for your manual process of managing statistics as part of your maintenance, how do you recommend choosing what stats to maintain? Simply off of how long since the last update? Do you have a favorite way of choosing what stats to update when?
It's a process. I'm going to tell you that. There is no quick and dirty answer. I go a lot based on this information right here. So here's my general rule of thumb. If you have a maintenance window where you can get all of your stats updated every weekend, do it. Even with a full scan, right? Having accurate statistics doesn't hurt the optimizer. The challenge with stats is the resources that they consume and whether or not you need a full scan. So my blanket advice is, if you can even update them every night. I have some customers that are just 8 to 5, right? And their database isn't large enough that it needs multiple maintenance windows or whatever. If you can do them all, do them all. When you start to exceed that, then you have to start getting a little bit smarter. And this is the tool that I use to do that. So very often where I start is I start by understanding what are my objects, which are most volatile. And I also look at size. So I mentioned that I've been working with a customer for a couple weeks, and I looked at stats two ways. One was I looked based on the size of the tables, and I went by row counts. You could also do pages. And the other was I looked at modifications. So for tables, I said, where's a natural division of tables? And in their environment, they had a couple tables that were billion rows, a few 100 million row tables, and then everything else was like 30 million or less, right? 30 million or less, I can update those stats in a reasonable time frame. I can update those stats with a full scan every weekend in a reasonable time frame. My bigger tables, I have to know how long that takes and do I need a full scan or not. Now with the default sample, those can update in less than an hour, depending on how many stats are there. But with a full scan, it takes maybe 24 hours for a 2 billion row table to update, depending on the hardware, by the way, right? There's a lot of assumptions here. So I start with table size, and I also start with volatility. And table size, I can just do a point and click at any point, and I get an idea of what my tables look like in the database. You probably already know what your behemoths are, right? You probably know what your history and your log tables are that just keep getting bigger and bigger, and you can't stand managing because they're not partitioned. I get it, right? Those I'm going to separate out. My modifications, that's a different beast, right? The tables that are volatile, right? That are not just critical, but there's a ton of churn, inserts, updates, deletes. Those tables, sometimes I'm updating them throughout the day, right? So I might have a job that runs every hour, every 4 hours, that stats for those tables. And depending on how large they are, I might also update those with the full scan, right? Do they have skew? So those are the two places that I start. but it's really hard to just give you a do this and do this, because the factors that contribute are size, modifications, and then what do you need in terms of the sample? And I use OlaScript, by the way, as an aside. There's lots of options out there. What I like about OlaScript is that I can also manage fragmentation at the same time, but I don't have to. You can use OlaScript to just update stats. I can use OlaScript to update based upon a percentage of change, which I have a blog post that talks about that as well. I'll grab that in a second. And Ola stuff logs to the command log table in the master database, which means I have a history of what was done rather than anything ad hoc or in something that I've written. So I tend to defer to his stuff because it works and I like it.
Okay, so we're at time, but one last question.
Sure.
Is updating with a full scan different than sample 100% in a modern version as it was in the old SQL versions? And this is related to fixing corrupt statistics.
Full scan on 100% should be exactly the same thing. I don't remember when they were not. That's an interesting point, but those should be exactly the same.
So I have had a couple of questions asking where can they get your slide deck and if they're going to get the queries. And the answer is yes. You said you would make those available.
Yep. So I've already sent them to Anthony, Mark, and Andrew. They were going to post them for me. And
all those links are in the chat right now.
Okay, all those links in the chat. And then just as a reminder, if you have a follow-up question related to that, feel free to send me an email. And I'm going to throw up here another blog post that I have. This is updating stats with OlaScript. So I've already said this, but I talk about a couple different things of how to use his script to update statistics as well in terms of the threshold. So take a look at that.
So I did copy and paste all of the unanswered questions into an email to you. So you'll have a point of reference if somebody follows up with you later, and their names are there if they're logged in with their name.
Awesome.
So that should help you.
Awesome. Well, thank you. Thank you, Ree, for moderating. I so appreciate it.
I love doing this.
Thanks to all of you who have attended and listened today. I hope that there was some info that was of value there and that you learned something new. And again, if you've got questions, just let me know.
Great. Awesome.
All right.
So Mark, are you going to step back in and take over now? Aaron, if you'll stop share. Oh, there you go. Yeah, they can take over now.
On it.
Anthony's taking over for this break.
Oh, am I? Well, thank you, Aaron. That was amazing. And yes, the content that you gave to me is on GitHub now. So that is available for everyone to use.
Oh, there's Joey.
Hey,
and Matt and Pam. Everybody's here.
It's a party.
And my content is on GitHub already. As of like 10 minutes ago.
Pam's was there before.
What?
Right,
the slide deck may not match the slides that I'm presenting because I
interestingly enough, I think I was pull request number 1 on the GitHub. Like I thought that was awesome. I was like, woo.
Nice.
Can I tell you that I predicted that you and Bob would have yours up there first? No offense, Joey.
You did?
I did. Oh yeah. I'm like, Pam's is probably already up there.
No, this is like the best I've never done this before. So
yeah, I'm usually terrible. They're usually bugging me like weeks after my session.
Oh, I'm the same way. That's why I was like, this is not going to be me. But I did it. I had it done and sent before I started.
Woohoo.
I know.
Nice. Good times. Fantastic sessions so far today. I'm looking forward to the ones the rest of the day I can't attend, even with Joey's insanity level session.
Oh, I'm looking forward to that one.
I'm going to eat lunch.
Funny story, and I'll tell it again when we're presenting. But the environment I wanted to have isn't as complex as I have because I couldn't freaking get an AG to work in Azure yesterday over a hybrid connection. It's the weirdest thing. All network traffic is working. The AG just would not come online. And
you're probably just not holding your mouth right.
Yeah, I think it's something with my network, but I don't know. It's a VPN. Everything else worked. So we're not in Azure. We're in a data center.
Dun, dun, dun. So, Aaron, make sure you check out the chat over there. There's a lot of compliments to you.
Oh, I'm like moving
it's
all
always,
my screens.
Always good for you.
There's a lot of input for this conference. I'm like bouncing around, like trying to figure out what to pay attention to.
Yeah.
So
we're
the
gonna, that's
answer
when-
is when you speak, nothing.
Right.
When you're speaking, your
Right.
moderator will handle everything else. So ignore it all.
I want to say, Erin, that we asked for lots of demos in the session, and fair play.
Yeah.
I didn't pull out the debugger, but I'm a demo girl, so I was all over that.
I'm feeling woefully inadequate. I have only one demo and I am not using the debugger. So I might be in trouble here.
You're fine.
I'm using Wireshark, but no debugger.
Oh,
It's
why
a network debugger.
make me look bad?
No, see, here's the thing, Pam. Like, I had somebody like challenge me, like, could I do a session with no demos? And I don't think so. Like, I don't know what I'd do. So
Yeah.
I think it's great that you can only have one.
I like to talk a lot. In fact, my presentation is actually a story. Like, it's literally like past, present, and future. So I don't know. Some people like it. The funny thing is, when I did this, the session I'm doing, I did it past a few years ago. I think it was a few, I don't know. It's all blending together. I got comments like, oh, this was so amazing. I'd love to hear the history. And then like the next line down was, too much freaking history. I don't want to hear all this. This is boring. So it's kind of a love it or hate it. So.
Nice. What is it? I posted that one time, Erin. I will not be accepting advice at this time. I was baking bread and I ended up like completely covered in dough. And so we posted this picture and I was like, I will not be accepting advice at this time.
That's a good one.
So
That's when
I've
I told
used
you
it.
about that's when I made the cake, right? You
Yeah,
had the you
yes.
had the bread fail and I had the cake with too much salt.
Uh-oh.
Oh, that's right. So yeah, way too many people. When I post something like, oh, you should try so and so. No, I'm not. No.
So hang on, I got all these questions in here that are still open. Should I be answering them?
Yeah,
No,
go
we-
ahead.
Oh, I
Take
mean, if you want to answer them there, yes. Otherwise, I'll go through and dismiss them all. But those are the ones I emailed to you.
Okay.
We've got about 10 minutes till the next session, everyone. And that's Joey's session on Deep Inside Azure SQL High Availability. Is the only insanity level session that we have today. So
It's
really
slightly
looking forward
less-
to it.
It's slightly less insane because of the lack of Azure. I really had this cool plan to have an availability group replica in India, and the rest of ours were going to be in LA. Yeah.
I'm just hearing excuses, to be honest.
Hold on. Let me add here that slightly less insane is still insane.
Sane.
Right? He didn't say, oh, it's totally sane now. Everything's
Yeah.
normal.
Yeah, there's a lot of debug X events in this session.
One of my favorite.
Yeah, Aaron, you should be happy. I'm using like all the X events.
Because you can't use Profiler, can you?
This is a place where X events are far superior to Profiler. I use them all the time when they're superior.
Yeah, over time, X events should hopefully become far superior.
You know, you say, Pam, over time, but we're 12 years in.
Yeah, they already are.
When we develop a new feature, we're adding X events. We're not adding profiler events. So
I was thinking about something today, specifically with this. Availability groups, one of the first features that I think were fully developed in that X events time frame. So there's a very rich set of X events in place. And that's just kind of an interesting scenario.
Yeah. Well, yeah, and you're going to see that going forward. That's what I mean by going forward. Hopefully the user interface for managing them will get better too, but the events themselves, I mean, there's just so much good information in there that you can't do in Profiler. So I know.
I did use Profiler yesterday when we were trying to figure out why the AG wouldn't join in India though.
Yeah, I mean, sometimes it's just like so easy to click, I'm running a trace. I get that. I do it too. But yeah.
It showed me that the same SQL I was running was running.
Yeah.
So for all attendees, we have the speaker speaker feedback URL on the slide there. Please do leave us feedback about the overall event. And there's also individual links to the sessions there. So Aaron's just finished the session. Please leave feedback so we can pass it on to Aaron. There. let her know what you thought of the session and whether or not if you like burritos or not. I've seen a few people saying that they don't like burritos, and I just don't understand.
Where did that come from?
Yeah.
Oh, it's,
wow.
it's one of the questions on the speaker feedback.
Is that like the bowl of M&Ms with no brown M&Ms, like the Van Halen rider?
Oh, you mean to see if people
Yeah.
are paying attention?
Yeah.
Kind of, yeah.
Please answer yes here so we know you actually read the question.
Yeah.
Or Jenna should kill me with these backgrounds, dude.
Perfect. So now that I caught your attention. Now you have to keep an eye to make sure that when you count exactly how many hits it hits the corner.
Oh, I thought I had it then.
What are we supposed to count? What?
Oh, when
How
the
many
DVD
hits the
icon
corner?
hits the exact corner of the screen.
Oh.
I like you, Argenis, but I'm not gonna keep staring for that long.
I don't like him that much. I mean, I love him, but
Right.
I don't like him that much.
Oh, but I'm glad you're back, Argenis, because I was like watching on the YouTube stream this morning because I was, making breakfast and driving my son to school and stuff. So I didn't want to, be on Zoom. And I really wanted to comment about Cheesies versus Cheetos. And I figured I'd hold my tongue because you guys were talking about Cheetos and Cheesies are just far superior to Cheetos, in my opinion.
I'm not sure what those are.
Wait, hang on.
Are they a Seattle thing?
Oh God,
No,
Aaron's going to
they're
get
Canada, they're Canada thing. I could run upstairs and get some, but I'm not going to. Because actually, Argenis, I have 2 bags for you from Canada from when I went to SQL Saturday.
I'm just shocked that you haven't eaten them yet because you have my full permission to do so.
Oh, Cheez-It.
Is that what you said?
No. Okay, hold on.
So we have Cheez-Its in the South,
Cheez-Its
Aaron. I
are-
know what
yeah.
Cheez-Its are.
I thought that's what she said. Now I'm hungry.
Okay, so go on Amazon and search for Cheezies. Cheezies. Cheezies.
Hey, do you understand why they're so close? They got Z's.
I do. I totally do. However, Cheezies are
with the
more
box of
like
Cheez-Its on
Cheetos.
her
They're like
desk.
crunchy Cheetos, but the flavor is just out of this world. And I first had Cheezies. When did I first have them? I have some friends from Canada and they gave them to me and I was like, oh my gosh, these are amazing. But I'm like, they just taste like Cheetos. And then I went back and I had Cheetos and I realized how lacking flavor Cheetos are when compared to Cheetos.
Wow.
And
So it's like Cheetos compared to the store brand Cheetos.
yes, probably. I mean, I haven't had store brand Cheetos in a while, but yeah. And you can order Cheezies on Amazon if you're not anywhere near Canada. But every time I go to Canada, I come back with Cheezies and Kinder Eggs, but don't tell anybody because they're illegal here.
We might need to modify the
Joey, I'm going to stop sharing my screen
evals.
now and you can take over.
Okay, cool. I'm ready to go.
So I just
Yeah.
want to comment. Anthony Nocentino in the Slack channel said Cheez-Its plus Old Bay is awesome. And I just want to tell everybody that's on this call right now, all 400 plus people, Anthony is broken.
Why? How is that broken?
That
sounds
pretty good.
awful.
Is it not good? What do you do?
It's
Do you
good.
do you shake up a bag with Old Bay and Cheez-Its and
Or like
Yeah, pretty
butter
much.
and bake them, or
yeah, that's what I was wondering. Butter and bake or no? Just
Well, you
just
could do that if you bake it. Obviously, it would stick better, like with a little bit of oil or butter. But I just toss it on there individually, and it's pretty awesome. So hit me up on Twitter. Let me know what you think about
I'm
that
gonna have to try
experiment.
this now.
I know.
Okay.
I'm tempted.
I wonder if that would be good with like ranch mix if you did
Oh,
it
yeah.
that way.
Yeah,
that-
Joey, I can see your screen.
You get 0
Alright.
Michelin stars.
So to take one away.
Start talking about SQL Server again, or do we need to stop talking about Snap?
We got
Right.
2 minutes. You're all right. We're just doing. I'm just making sure Joey can share screen. Do you want to switch to a demo? Make sure we can see everything as well.
Yeah. You're good?
But yeah, the slides look good. Possibly make that a little bit bigger if you can.
Yeah, that was just VMware. I can zoom in here too.
Yeah.
I have-
Okay. Cool. Yeah. No, I can see it fine. It's just a bit small for me.
Yeah. We shall zoom in.
No, that's great. Okay, and we're back on the slides. You've got about a minute to go. Okay, so we're all going to dive off now and let Joey kick off in about a minute. Just for the attendees, we've got the Q&A panel there. If you have questions, please ask them there. If you have comments or want to interact, please use the Slack channel. We're not really monitoring the chat in Zoom too much, we do have the Slack channel for ongoing conversations. So if you have a comment, please go into Slack. Please keep Q&A just for the questions. Thank you very much. And Joey, off you go.
Thank you very much. Welcome to Deep Inside Azure SQL High Availability. If you're not familiar, Azure SQL is the new broad marketing term for a SQL Server and Azure SQL Database and Azure SQL Managed Instance. We'll talk a little bit about Azure SQL Managed Instance and Azure SQL Database at the end of this, because it's really cool what Microsoft is doing to provide high availability for these platforms. But the key focus and where we're going to be demoing is on Windows and SQL Server. Yes, SQL Server exists on Linux. If you're unfortunate enough to have to build a cluster or availability group on Linux, you've gotten to experience the joy that is Pacemaker. Well, that's kind of interesting tech. I wanted to focus on what I think most of you and what I see mostly in the field are using, which is Windows Server failover clustering with always-on availability groups. And we're going to kind of take a deep dive inside of that technology. We're going to talk about how it works, how it interacts with Windows Server failover clustering, some of the complexities of the process, and how we build those solutions. I'm Joey D'Antoni, you're at 8KB, and this is June 17th. So why did I choose this topic? It's something I had been really interested in, and I've gotten to work on really since the beginning. Back when I had my last actual DBA job was when SQL Server 2012 was being developed, and I was working at Comcast. And we ripped out and replaced a lot of our failover cluster instance environment as SQL 2012 came out and switched to an availability group topology. We got a lot more flexibility that way. But there were a lot of problems along the way, and I've run into a lot of problems with customers, and these things are really tricky to troubleshoot. There's a complex intersection of networking, clustering, and database functionality with availability groups. And how can I best explain that? Well, I'll tell you about the demo system we're going to be working on, and what I really wanted to build for this. So we have 3 nodes running on a VMware cluster in our DC-AC data center in Los Angeles. It's not actually our data center, but it's a colo. What I wanted to do is extend that out to Azure, and I got that all working, and I got my Azure node added to my cluster. We've got a permanent VPN in place to Azure, but I couldn't get the Azure node to come online in the availability group. Clustering work, file transfer work. There's some hidden networking problem somewhere that's not surfacing itself in any other way that was preventing me from getting the AG online. I've been working with this solution for 10 years. I've got a lot of networking experience. I couldn't get it to work. So those are some problems that can happen, and networks are tricky, and we'll talk more about that in a second. We'll also talk about troubleshooting and how to best troubleshoot and what the order is, and having a deep understanding of what's going on can help you troubleshoot and give you some headaches. Poor configuration can limit your overall throughput. What I really wanted to showcase was having a synchronous replica at a high rate of latency, but I'll explain how that happens anyway. Worse than that, it can cause you to lose data. So Microsoft calls this feature always on availability groups. It's mostly always on, but if you have poor configuration, you can have major problems, and it can cause more downtime than you would have uptime. Just in case you don't know who I am, and I don't expect that you do, I'm Joey D'Antoni. I'm Principal Consultant at Denny Cherry & Associates Consulting. I'm a Microsoft Data Platform MVP. I've been working with SQL Server since version 7, and I'm old. I started with SQL 2007, that time frame. Been working with this technology for about 20 years. You can find me on Twitter at jdanton. I also blog at joeydantoni.com. All the resources I'm using, all the slides are already on the GitHub site. So they'll be there. There's not a ton of scripts, but I'll talk more about the configuration. So this immaculately drawn slide, because I couldn't get the second curve to draw pretty, is the environment we're going to be showcasing today. We have 3 VMs, and they're on, I think they're on different hosts. I didn't really pay attention because I'm not trying to protect for availability, and Arjunish really liked my curly line, I could see. We have multiple databases here, but each of these database icons represents an availability group of databases. So I think I have 4 databases, because we're going to do some stuff with HammerDB, and we're going to do some stuff with just smaller databases so we can isolate transactions. But one thing to note is that we're sending 2 streams of network, and that's what those red lines represent. So even though the orange represents the network connection between the machines, the red represents the log transport streams that are going to be taking place. So The way availability groups work is SQL Server reads the transaction log on the primary, sends those transactions to each secondary. And this is something to think about if you're in a complex topology where you have several replicas that you're using for DR. It's not just one network stream you have to think about, it's multiple. By default, if you're in synchronous mode, SQL Server does not use compression on that log transport. It's sent uncompressed. If you're in asynchronous, it's sent uncompressed. And the reason for that is the theory being is that if you have asynchronous, you're sending the data over a greater distance, so the compression would be of benefit. This is all tied in with our good friend Active Directory and a Windows Server failover cluster. So one of the things you need to be concerned about is having the right Active Directory permissions to create a computer object, and then assigning either the permissions to your cluster computer object to create an availability group listener, or assigning pre-staging an AD object. So you have to get AD involved. And to speak to that, also while building this environment, we had some Kerberos problems that are kind of inexplicable to me, but we had to pull out set SPN. Fortunately, I'm domain admin in the DCAC environment, and we could kind of easily do that. So availability groups are complicated. Software applications are written with little error handling on network applications frequently. Availability groups are a little bit better about this, but what we do when we build an availability group is we move from a standalone system into a distributed systems topology. As I mentioned, Kerberos is always lurking. And I kind of have some tenets here on the left-hand side that we know are always true. The network's always reliable. We always have enough bandwidth. Topology never changes. You never have to move a data center or anything like that. No, none of that happens. It's free to send stuff over the network. So WAN costs are also free, and we always have the same network and environment. If you don't know, and I have the asterisk there, these are what are known as the fallacies of distributed computing. This is about a 20-year-old system, guidance from some folks that worked with Sun, and it's still all true. I will say there are some exceptions for this a little, in that if you're in the cloud, things get a lot more homologous, but it's complicated. So when you're trying to go from on-prem to the cloud or on-prem to another on-prem environment and you're dealing with multiple colos, network connectivity can be kind of super important and at the same time fragile. So it's really important before you even think about implementing a distributed, an availability group that's distributed across sites. We're not going to talk too much about distributed availability groups, but that's a same kind of technology. This technology is very much dependent on having a constant network stream. So if you don't have good, robust networking in place, don't try to implement this between two sites. It's going to be heartache. Just use log shipping. Actually, that should be the secondary title of this presentation. Just use log shipping. It's much easier. So just to show, this is what I really wanted to build. We had the 3 nodes in LA, and I really, really wanted to get Bombay, which is South India, SQL HA online. And we got as far as adding it to the cluster. SQL Server came online. I could copy backups there. I could do everything. The AG just wouldn't come online, and I will investigate. I think it's something deep in Azure networking that I haven't been able to isolate, but that's where we are. So let's dive in. All right. The first topic I want to talk about, and I'd like to credit Alan Hurt, my good friend, for a lot of my knowledge on this topic, is failover clustering and availability groups. Unlike SQL Server failover cluster instances, which are truly a clustered service, availability groups have more of a loose coupling with failover clusters. At the same time, it's tightly integrated. So why do I say that? With failover cluster instances, you use failover cluster manager or cluster.exe to manage your cluster resources. With availability groups, all the management's performed through the SQL Server side, and SQL Server at a low level is responsible for implementing the relationship with SQL Server and the cluster. So you don't do a whole lot with clustering other than getting the cluster in place in order to build your AGA. So this is probably one of the more common problem scenarios I've run into with customers in dealing with availability groups. there's this, each node in the cluster runs a single cluster service. So it runs a process called cluster.exe, which operates the failover cluster and also monitors all the resources that are owned by that cluster. So this resource host operates as a separate process called rhs.exe. And it's the interface between the cluster service and the individual cluster resources. So this resource host is going to operate on the cluster resources when called upon. So SQL Server in this place has a custom resource monitor DLL that interacts with rhs.exe. And this manages the online and offline operations and health monitoring for cluster resources. With SQL Server, this resource DLL determines the health of the AG based on two things. So the first is an availability group lease mechanism that's built into SQL, and availability group health detection. So the resource DLL exposes resource health through is alive. So can it see if the service is up and running? And on the primary node, the cluster service would initiate failovers by whenever that is alive call would fail. And then it would go back to the resource DLL and initiate a failover. So if SQL's down and you have automatic failover in place, the failover will automatically happen. And that's managed by the combination of rhs.exe and that resource DLL. The cluster service also sends heartbeats to other nodes in the cluster and acknowledges that it received heartbeats. If a node detects a communication failure from a series of heartbeats that went unresponded to, it will broadcast a message causing all reachable nodes to reconsider their view of the cluster health. So if node 3 is down, the node sending the heartbeat, which is the node that owns the core cluster resources, will then say, oh, hey, nodes 2 and 3 are down. This event is called a regroup event, and it maintains the consistency of the cluster state across nodes. If after that regroup event, Quorum is lost, so Quorum is the thing we have in the cluster to avoid what's known as split brain. And what split brain is kind of the worst possible scenario you could have in any kind of distributed computing environment. That's where two separate nodes try to take over as master or as primary, excuse me. And when that happens, all hell will break loose. Fortunately, we've got mechanisms in place called like Quorum to prevent that from happening. So if Quorum is lost, then all cluster resources are taken offline. So losing Quorum is bad. We'll see what happens when we lose Quorum. I'm going to screw with VMware in a little bit to cause that to happen. If a partition exists that does have Quorum of that cluster, the AG will be assigned to one node in the partition and then become the primary node in the replica, while all of the other nodes become secondary replicas. So this lease mechanism here is what enforces that relationship. So this is very important, pretty low-level stuff in the cluster. So the primary function of that lease mechanism is to take SQL Server offline if the cluster can't communicate with the instance while performing failover. The cluster performs the offline operation on that AG resource, and the cluster service will then make an RPC call to that rhs.exe process and then take the cluster resource offline. The resource DLL also uses a stored procedure to tell SQL Server to take the availability group offline, but there's always the potential that, especially with a troubled node, that this procedure could fail or have a timeout or something like that. The resource host also stops its own thread during the offline call. So in the worst case, SQL Server will cause the lease to expire in half times the lease timeout, which is a defined value we'll talk about when we go into the demo. And then failovers can be initiated by multiple parties in this scenario, but it's importantly to know that the cluster state is consistent across the cluster and across SQL Server instances. Our worst case scenario is where a primary loses connection to the rest of the cluster. Each node in the cluster would determine a failure at similar times based on their timeout value, but only the primary node can interact with that SQL Server instance to force it to give up the role. So that's effectively why we have this lease timeout mechanism. However, it can cause availability group problems. And the biggest ones I've seen are high CPU for extended periods of time, where none of those health check processes can complete. So if you have CPU running at 100% for an extended period, this can cause problems out of memory conditions where the server can't have enough memory to run. And I've also seen it at a customer where we had network saturation causing it to run. We had two pretty big machines and we had really fast storage. So we were on all flash storage. And we only had at the time a 1 gig network between the machines, which I didn't realize because it was a colo and I didn't see the environment. And all of a sudden we reached a threshold where we started getting a lot of lease timeouts caused by this. And the only way to fix that was to beef up the network, which was tricky because the machine was out of ports. I think somehow we got it to 2 gig. We couldn't get 10 gig infrastructure in for whatever reason, because all we really needed in that scenario, because the machines were next to each other, was a 10 gig crossover cable, but we couldn't even do that. So we have failover levels in SQL Server, and this is kind of an important thing to note. You can set this in SQL, but you probably shouldn't. That resource DLL of the availability group performs the health check of the primary by calling this stored procedure called SP Server Diagnostics against the instance that's hosting the primary. It runs at an interval that's a third of the health check timeout threshold for the AG. And the default is going to be 30 seconds for that. So that means this is going to run every 10 seconds. If that procedure runs slowly or is not returning information, the resource DLL will wait for the full interval of the health check timeout before determining that that primary is completely unresponsive. If the primary is completely unresponsive and you have automatic failover in place, the failover will take place. And so this doesn't perform checks at the database level. Starting in 2017, you have the ability to do check on database level initiation of failover. But whether the diagnostic data and information returned by this proc warrants a failover depends on the failover level of the availability group. The default is on critical server error. So these are things, I believe it's above 719. Orphan spin locks, write access violations, etc. You can knock this down. You can knock it all the way down to 1, which is only service being down as causing a failover. Or you can knock it all the way up to 5, which will say if there's an unsolvable deadlock failover. That seems a little, I can't imagine any scenario where I'd use 5. I have knocked this down before, and it was that same scenario I was describing with the lease timeouts that were related to networking. We were just trying to stop the pain. So we knocked it down to 1. It didn't really help anything. As soon as we got a better networking in place, we went back to level 1. So troubleshooting paths for your AGs. Always look in the SQL Server error log on each node first. It's important to look on each node. I can't always tell you whether to look on a primary or a secondary, because there are some things that get reported to the primary and some things that get reported to the secondary. I'll give you an example. It's not something we're going to go into detail about today, but availability group seeding is a new feature that was introduced in SQL 2016. And this is a feature that uses a VSS backup and streams the backup under the hood. So you don't have to do the whole process of applying a primary and then a log backup to get the secondary in sync. And I was working with some pretty big databases, so this was an easy way to do this, and I was using it recently. Well, I was seeing some failures in the DMVs. The DMVs aren't super documented for that feature. And I looked in the primary log and I couldn't really see anything. But when I looked on the secondary log, I saw there were some backups failing with move errors, because there was a minor directory structure problem on the secondary that I had to address. But I wouldn't have known that unless I looked in both logs. And that's very much the case with availability groups. You need to look at both sets of SQL error logs. And for the most part, the SQL Server error log is your best resource for troubleshooting a problem. There's an always-on health event that I think records when the procedure gets run. There's not a lot of information there. I've never successfully used that for anything in terms of troubleshooting. Typically, the cluster log is needed for deeper problems, and we're going to look at that. The cluster log is big and it's long. I like to use Linux tool. I've done this before where I've used Linux tools to grep the log. I'm in a demo using PowerShell to parse the log here in a second. I've also increased cluster logging. By default, it's at level 3, and I've set it to level 5, so we'll have a little bit more information in the log. And we have these categories, and this isn't something to really speak to too much, but it tells you how to parse the log, because like I mentioned, the cluster log is very long and very detailed. The cluster nodes are always talking to each other. So that whole regrouping thing and making sure everyone else is alive is something that's really important to the cluster. So it's kind of very, very verbose. It's also by default in GMT. They do now put at the top of the cluster log, I think, a note about that, and we'll take a look at that. So let's dive in. And just to let you know, this is the main VM we're working on here. Hold on a second, I just need to arrange some screens and not do that. Hang on. There we go. We're in the machine I wanted to be on. And so the first thing we're going to look at, and I'll zoom in a second as soon as I get failover cluster manager up, is failover cluster manager. So let me zoom in. And like I mentioned earlier, this is a 3-node cluster running in our colo, and we can get there by looking at nodes. My mouse is a little drunk and zoom in. Sorry about that. So here, if I click on nodes, I can see I have 3 nodes. They all currently have an assigned vote. One thing that's really important to understand related to Quorum and your cluster staying up is voting. Starting with Windows Server 2012, we have what's known as dynamic voting, which means if my availability group node 3 node goes down gracefully, which means I shut it down and it can go down cleanly, it will then lose its vote. Which means I need to have, right now, the way this is set up, I have node majority configured. I should probably have node majority in a disk, but I don't have that in place right now. Since it goes down gracefully, I can still lose another node. And if node 2 goes down gracefully, I can lose another node. The only way you can lose Quorum with dynamic voting is if a number of your nodes all go down at once ungracefully. And what do we mean by ungracefully? That means if we pull the plug, or as I'm going to do later at the end of this presentation, because it's going to break everything, if we go into VMware and we power off the nodes, that will do the same thing as somebody pulling the plug. Generally speaking, this graceful failover handling makes it pretty rare that we have Quorum failures now. You can turn off dynamic voting, but don't ever do that. It's only something you would want to do in a demo. I got yelled at by somebody on the clustering team for demoing it because I was teaching clustering, and we had a customer who had an older version of Windows that didn't have it. Okay, I'm lost in my own zoom in screen here, so we're gonna get it back to failover cluster manager. Okay, so we're going to navigate to our AG role. This is our AG. And by the way, this is running on Windows Server 2019. The screens here look a little bit different. So I can see it's running. It has a medium priority. This is all created by SQL Server. I didn't define the priority. I see I have an IP address associated with this. It's 172.30.4.113. So if I navigate to this resource tab on the bottom, and then I right click on my AG resource. This is the actual resource for the AG. By the way, if you've got experience working with failover clusters, you might remember that you manage them through here. Don't do that. Don't do that with SQL Server. Perform your failovers through Management Studio, PowerShell, whichever SQL thing you would like to do. However, there are a couple of things here that are important to note. So if I go to properties, those 2 things we talked about, health check timeout, or 3 things, failure condition level, and lease timeout, are all settable here. I have increased lease timeout before on servers where I was consistently getting them. Typically, if you're increasing the lease timeout on your servers, it means you have to tune your code because your code is terrible and sitting at 100% CPU for a while. But it is something to be aware of that you can adjust that here. You shouldn't adjust failover condition level. That's something that should be done through SQL Server. So I'll zoom back out because I think I have my fonts big enough in PowerShell. Matt, can you see that, or do I need to make the font a little bit bigger?
I can see it. To be fair, I'm sitting very close to my screen, so a little bit of zoom probably wouldn't hurt. Yeah.
I'll just make the font a little bigger. So you don't get the cluster log by going into failover cluster manager. It's a little bit different than that. So there's this command called get cluster log, and you can specify a destination. And here I might say ctemp. This is another one of those fun cluster commands because there's a lot of interesting, fun stuff with clustering. It'll take a second to run. And it's going to pull the log from each of our nodes. Node 1, I think, is it's my AG primary right now, but I think it's my cluster primary as well. So node 1's log is likely to be a little bit bigger. I have verbose logging turned on, so this log is also going to be relatively big. So there I can see we have these files in place. And you can see by the size of them that node 1 has a bigger log than the other 3. I'm going to open one of these in Notepad++ just to give you an idea of how big it is and how hard they are to navigate before we do some fun operating system stuff. So there's a lot of stuff in this log. Let's just zoom in and kind of. So we see that UTC equals local time plus time zone offset. With daylight savings, the time zone offset of this machine is 7 hours. The logs are generated in UTC. So if you don't use the get cluster log use local time option, they will be generated in real time. Here I can see my node information, my cluster operating system version. I can see my quorum configuration where everybody's got a vote. I can see the various types of resources that are in the cluster. I see my AG nodes and my listener, my cluster IP address, and my ownership. So there's a lot of information here. This first bit is just informational. This is all the information that's about the cluster. And if I scroll down, I start to get into events. And you can see there are a lot of events. So it's not super manageable to look through this log and analyze that. So there's kind of 2 ways you can go at it. And I'm going to do this by resource name. I'm using PowerShell in order to do this. I'm going to do res and then select string. So this is going to cat the cluster log and then pipe it to a select string where the pattern is res and HADR-AG. This should give us information about SQL Server availability group operations, and then I'm going to pipe it to a more so we don't get overwhelmed. And this will take a second to parse. And here I can see query processing health. I've bounced this node a few times this morning. So I can see that my health state has changed from warning to clean, then clean to warning, and vice versa. Let's see if we get anything else interesting. Here I see where my lease thread was terminated at 12:54, which was a couple of hours ago. Here I can see my disconnect, and this is the execution of a failover and what it looks like from the cluster. And here I see my iOS, I see things coming back online. My states are coming back to clean. And then I can see my my system health query processing information. So all this is really cool. There's a lot of stuff in the log. We can also parse, let's parse for RCM API. These are also control events that are taking place in the cluster. This is SQL Server sending stuff to Azure. As you can see, this is really detailed information. It's pretty rare that you will have to use it typically when you're going to go here is when you're using when you're doing a failover or you've had a failover that's unexpected, and there's nothing in the SQL Server log that's telling you what the hell happened. So you don't understand why a failover happened, or maybe you saw one like lease timeout message in the error log in SQL, and you want to better understand what's going on. That's when you go to the cluster log. As far as I know, no one has built a good cluster log parsing utility. I like to use, I'm kind of an old school Linux sysadmin, so I really like to use Linux commands in order to do that. But I also have used like PowerShell, like I just did. So, okay, let's dive in a little bit more into our availability group and how we can monitor them. So as I mentioned, system health is kind of useless. However, there are a bunch of extended event areas that we can go to where we can get a lot of information about our availability group. So here I'm just going to do a demo. Let me zoom in. And I'm not actually going to build this session. I just want to show you a couple of things. So there's two categories you care about. And a lot of this goes back to the original name change. So this feature was originally called a Hadron, but there is a class of events called always on. So there are some that have been added later that use the always on event category, and some that use the HADR event category. The other thing to note is with extended events, there are channels. A lot of the interesting availability group events for detailed analysis are in this debug channel. The official wording on the debug channel is that it's only supposed to be used in conjunction with support. Be careful with it. The one thing I will tell you is that if you turn this on, it will log a lot of data. So it's these debug events, and we're going to talk through them when we talk about log transport. And this is where this session goes insane. There's a lot of each step of the process, which is an 18-step process of how a data gets written to the secondary, is captured by these always on debug extended events. So let me exit out of that, and then let's look at an event session. In this event session I created just has a couple of events, and the main thing it's going to show us when it retrieves information, it's going to take a little while to do that, is that the cluster lease is renewing. So this is going to run, I think, every 10 seconds based on defaults. It might be every 5. We'll see it pop in. So 9:51, we had an HADR AG lease renewal. This is simply SQL Server talking back to the cluster. And I was zoomed in the wrong way, so we weren't getting updates. So every 5 seconds, we can see that that event runs. And if we dig into the data in the event, we just see the event, the new timeout value, and we see that the renew succeeded. So Matt, do we have any questions so far?
We do. We actually have 5. So what I'll do, I'll run through those briefly, and if you want to defer some to the end or a blog post that'll work. Actually, we have 6 now. So the first one we got is, did you ever see the IO throttling as the cause of lease timeouts on Azure?
IO throttling is the cause of lease timeouts on Azure. I have not. That's a potential, but generally speaking, the IO throttling in Azure kicks in before I've had lease timeouts. I literally just built an AG a couple weeks ago where we're getting really bad IO throttling because we went a little too cheap on the VM size. And we haven't had any lease timeouts, but man, the IO sucked. So we actually upgraded the size of the VM.
Okay. Next one we got, the failover level slide. What's the default value for that?
Default is 3. Pretty much never change it. That's one of those things I would probably only change under the instructions of support.
Fair enough. Next one we have is, what's your opinion of the failover detection utility that Microsoft gives us?
I think it's okay. It does a pretty good job of collecting data and analyzing. I still just, once you get comfortable parsing the query log or the cluster log and get some tools in place around how you can parse that, which is effectively grep and maybe awk for those of you who are Linux types, or their PowerShell equivalents. By the way, I did have to learn select string this morning. I didn't know that. I'm sure Anthony's laughing. To me, that's an easier way to get what you need, especially if you know the time frame where the failure happened. I am going to show a tool from Microsoft later there that I think is really cool about latency.
Okay. Let's see. We've got the next one we have is somebody wanted to know what the issue is or what the problem is failing over an AG or kicking that off using failover cluster manager.
SQL Server is unaware, so it's a hard failure, and you will likely have data loss.
I can speak from personal experience that can happen. Ask me how I know.
I've also seen it where the AG will come up in like a very inconsistent state after that,
yeah.
And you have to kind of piece it back together from the SQL side.
Yeah, fun to do for like a demo or a lab. Not so much fun for real. Do you want to take a couple more now, or do you want to hold those?
Yeah, I can take 2 more now.
Okay. This is kind of a two-parter. The 3 nodes you mentioned in the demo. The question is, what if one of your nodes is in a different data center and the link fails? Does that change Quorum vote options, i.e., move off default?
Yeah. So if the link fails, you're kind of in trouble because you can't kill that vote. It's very common practice, and I probably should have mentioned this too, if you're in that scenario and you have a DR node in a second data center, to make it non-voting, because you don't want it to impact your high availability. The better solution that I would say is to run distributed availability groups, but this is enterprise only in 2016 and higher, which would let you and it's complex to set up, and there's a bunch of things, and that's why I'm not talking about it too much, but you would in that case have a cluster in each data center. It's actually what Microsoft does for Azure SQL Database, which we'll talk about later.
Okay, we're still getting a few more in, so I'm going to toss one more your way, and then we'll hold some till after the next demo. So the last question, I guess, for here is, what do you not like about the always-on health event session? Is it missing data that can be seen other places?
Yeah, it just doesn't have a lot of data. There's nothing particularly wrong with it. It just doesn't have the level of data you would need to like troubleshoot the way the cluster log would. That's effectively the only problem. There's nothing inherently wrong with it. It just doesn't collect a lot, which I think is on purpose because it's running all the time and they want it to be lightweight.
Right. Yeah, so we have, I'd say probably 5 or 6 left. So just toss it back over to me when you want to handle this.
Sounds good. I'll go through the demo and then because I need to talk about Azure too. Understanding log transport, this is really the key mechanism that we have for data protection. So at a grossly simplistic level, the transactions get read from the transaction log on the primary. And I don't think this bullet point makes any sense. So I'll just say what I meant to say. When you write to the primary, if you're in synchronous mode, that your transaction on the primary is not committed till it reaches and is hardened on the transaction log on the secondary. That means it's got to go through the log buffer, which we will have a beautiful detailed slide that I borrowed from Microsoft that walks through the whole process on the next slide. This can obviously cause increased latency on the primary replica. It's also going to kind of work as a resource governor. So there's a couple of things here to keep in mind. Your latency can be affected by network bandwidth. So as I mentioned before, a 1 gig network will not suffice to move all the traffic, especially if you have good storage underneath you. Having poor IO or inconsistent IO subsystem performance can also cause problems. If you're on a version older than SQL Server 2016, there are some pretty major limitations in the overall availability group throughput. So the feature and process got completely rewritten in 2016 to do a number of things. But one of the things that the problem was people were moving to faster storage, like Pure, thanks Argenis, you owe me $20, and other all-flash arrays like that. So that the software itself couldn't keep up with the speed of the I/O. And I think prior to SQL Server 2016, and these are all kind of unofficial numbers that I've seen in testing, you could get up to about 100 meg, maybe 150 meg per second. Throughput. Now you can get up to about, I've seen 250, I've seen close to 400 on a couple of systems. And there's just a lot of variability in how this can affect it, which is why I mentioned sunspots. So what does this process look like? This is pretty complicated, and this is a really cool slide because it walks through the whole process. We begin a transaction, and we have we complete the transaction. Oh, on the primary, it gets written to the log cache. The log cache is a small circular buffer that then flushes that transaction to the log on the primary. We get a log flush complete message. Then we get the log flush to the log block pushed to the log pool. And then that log is captured and then sent to effectively a queue called HADR messages that gets sent across the network to our secondary, where it's then received and then applied into the log cache and then flushed into the transaction log. And then finally, the transaction commit is acknowledged. That commit is then sent back through both of those messaging queues. And each of these things has an extended event, as you can see, that are associated with them. And it's then finally sent back, and then that transaction is committed. And all of this happens in milliseconds. If you're doing it right. If you're doing it wrong, it can be really ugly. But this is the process. The other part of this process to pay attention to is, so I'm going to mouse over here. Remember, the transaction is sent to the log, and that's when the transaction is acknowledged committed, when it makes it into the log. It is not, however, in the data files. It gets played back using redo threads and redo pages into the data files. If you're on SQL Server 2016 or higher, this process is parallel for the first 7 databases in your availability group, as determined by database ID value. So effectively, if you had databases 7 through 20 in sys databases, databases 7 through 14 would have parallel redo. Databases greater than 14 would not. This was used to protect from thread starvation. That's a place you can get in trouble when you have a lot of databases in an availability group, and that can be, or availability groups on a server at the same time. That's something to be aware of. But what that means is, especially if you're using this as readable secondaries, even though they're transactionally consistent, and if you were to bring the database back online, you would, the transaction log would recover, and all the standard crash recovery things we've grown to know and love in SQL Server would take place. We don't, however, have any direct control over how fast that data gets played back into the secondary. That just means you don't know when it's going to be there, and your users may see inconsistent values. Okay, so the first thing I kind of wanted to show you guys is this code that I have in place, and I have this in place on both the primary and one of my secondaries. And this code's effectively going to process this whole process, so we can see as each step happens. And I'm going to turn it off and then turn it on again, because that fixes everything in computing, as we all know. And let me connect to one of my secondary replicas. It would help if I used the right server name. Never type in a demo. So let's do the same thing there. And I wanted to show you guys this and girls, this first through one transaction. So I'm just going to create a table in a database. And let's go ahead and turn on that extended event. And then we'll watch the live data. And we'll watch live data on this primary too. And so I didn't save this query to the GitHub repo because I figured you could recreate it yourselves. We're just creating a table. So here, if I go to SQL 1, I can see, you don't want to see a countdown timer. I can see this whole process take place. So I see that we captured a log block. And we see the log block ID, the timestamp of the start. We see the block size was 11. The block was flushed to the log pool. The messaging queue captures that log block. It then compresses it. So we see the compression take place. And we see that this is database ID 6, and we see the timestamp. We see the uncompressed size. So SQL Server is tracking all this information. And we can see this walk through. So we see that it receives the hardened LSN message. That means it took 17 milliseconds to process, because we see that processing time. We see this all the way through to the log write and file write. And if we look on the secondary, we're going to see a similar set of information. So we see that we receive the message, we decompress the files, we push the block to the log pool, we do a log flush, we send that hardened message. The send is then considered complete. And then finally, we get the timestamps of the log hardening. SQL Server is collecting a lot of information here. So this is really useful data. Let's zoom out. Sorry, I'm lost in my zooming. Okay, so we're there. And so what I wanted to show you, and make sure we're good on time, I think we are, is that, let me verify the state of my availability group. I think we're in sync. No, I don't want to fail over. That would be bad. I wanted properties there. So we have two replicas that are in synchronous commit with automatic failover. So effectively, that means this AG is in synchronous commit. So let's go ahead and start up HammerDB. And by the way, in lots of work with throughput testing, the best way I've come up to stress test an availability group configuration is to use HammerDB to build really big warehouses, because it's all insert activity. It's not very real world, but it will show you the max throughput. So here I'm going to have 10 users create a TPCC schema in a local database that's part of my availability group called HammerDB. And we'll watch the transaction counter come up. And I should probably stop these extended event sessions because they're going to be really expensive. And we can see we're up to 34,000 transactions per minute. 42, and this should settle around 42,000. We're running in synchronous, so remember every transaction that happens has to get propagated out to both of those logs. So that's a big challenge there. We're settling at about right under 50,000. So what I'm going to do is flip these, and we can do this on the fly. This doesn't take any downtime. We're going to flip to asynchronous, which means we're not worried about writing to the second or committing to the secondary log anyway. We're kind of spraying and praying. Oh, I have to run these in different order. Hang on. All right, now we can switch to asynchronous commit. And the cool thing, since we're running HammerDB, is we're going to be able to see the performance impact of this. And I should use asynchronous. We can see our performance is going to steadily pipe up. It'll take a few seconds to update. We see we get this big jump where it goes up to 58, and it will probably escalate a little bit more. And the reason for that is just that. It's the latency that is incurred by having to write to the secondary. These machines are on the same, I don't know if they're on the same host, they're in the same rack, so they're interconnected. It's VMware. You'll see some dips, but in general, you'll see a much higher overall throughput with this latency. You can track the latency. So if you're using that X events capture, and I've linked to a blog post from someone at Microsoft that will show you how to use that data to track it. But in that same blog post, there's also this tool that will give us an AG latency summary. So here, if we zoom in, we can see where most of our latency was taking place, and it was on the primary commit in the secondary processing. So we can see our secondary receive was extremely low, because as you would expect, and we see the remote harden was the other piece, and that's where it's hardening to the secondary. But we can dive in and get detailed data. So we can see the statistics from the primary. In this report, these reports are coming off of the X event data that I collected. I did this earlier because it takes a while to process them. But we can see all these averages. It's a pretty cool chart. This isn't something you generally have to worry about unless you're having a performance problem and you're trying to analyze it. If you are, this is really useful. And I think that big downtime is where I flipped from sync to async when I was doing this demo earlier. Really cool utility. It's a little bit wonky to use, but it's fully detailed and open source, and it's on GitHub. Really handy tool to have if you're trying to understand a log transport problem. And then I wanted to just show you what it looks like when Quorum goes down. So let's do bad things. I know you probably can't see this. I'm just zoom. I'm in VMware, and I'm going to kill the nodes. So I'm just going to power off nodes 2 and 3. Don't do this in production. Don't even do this in dev. You can do it in your lab. I'll give you permission for that.
Just to let you know, while this runs, you've got about 10 minutes left.
Yeah, I'm good. Where is my power for? There we go. So the thing I'm doing here that's so bad is by powering these nodes off, they just go away. They're not going to be able to communicate back to the cluster that, hey, I'm going away, peace out. So if I go back to failover cluster manager, I'm still running. I see that node 2 is down. We haven't figured out that node 3 is down. We're probably in trouble because I think this is node majority. They still have a assigned vote. So let's see if we're in trouble. We're still online. I don't know why. Let's see. Let's check quorum settings real quick, just so you can see this. I do see I have a critical cluster error. And here I can zoom down and see that I can't renew the lease for the IP address. So let's see, we should be down by now. It's hard when you want failure to happen. We're still somehow online, and I'm not sure why, but anyway, don't do that. Don't spawn failure. All right, so that was the log transport demo. The final thing I wanted to talk about, because I mentioned it, and I think a lot of people are interested, and it's something Microsoft really used to not talk about. And then about 2 years ago, they published documentation on what they do for high availability in Azure. And this is specific to Azure SQL database more broadly than VMs or anything like that. I think that kind of high availability story is a little bit better defined. I'm not going to focus too much on the core Azure principles. I'm just going to talk about SQL stuff. HA and DR in Azure pass. So we have a term that we use at DCAC that I believe Kerry coined, and it's called Azure Magic, trademark pending. And effectively, this is when Azure does stuff and it just works and you're not 100% sure why. There's a lot of this throughout the platform that a bunch of smart people built, and things just work and they're easy. On the other hand, there's sometimes Azure magic, like not being able to add that availability group node, where I don't know why it happened, and it's not my network, so it's hard for me to see all the packets, even though I get a lot of view. But let's talk about what Microsoft does, because it's pretty cool. It's not that different from what we do. The first thing to understand is that there are 2 tiers, and they do HADR completely differently. So there's business critical, which is on the right with the availability groups. There's also general purpose, which is on the left. If you're on the older versions of the Azure SQL database, premium is on the model that's on the right, and basic and standard are on the left. Having a basic understanding of Azure storage is really helpful to understand how this works on the general purpose side. Azure storage has 3 copies of your data. So whenever you write, there's not RAID per se. It's just that a write is not complete until it's written to 3 copies. So it's effectively RAID. It's just a little bit different than what we would have in an old school storage array where we talk about RAID 5 and stuff. Effectively, you only ever have a primary replica. It's using its local SSD for tempdb, just like you should on your VMs. And then the data is stored directly in Azure Premium Storage. It's actually stored as blob attached storage. So if you look in a standard database, you can look in sysmaster files and you'll see your files and they're HTTP attached, which is actually a feature that's been in SQL Server since 2012. I wonder why it got put there. Effectively, the storage is serving as your high availability. So this is almost like a failover cluster model, instance model, or a container model, where if that compute goes away and there's a failure, the node will come back up on another node. Failover time's a little bit longer because SQL has to come back online, but it's also not very long in my experience. These failures are pretty transient. The other thing to note here, it's just we see the applications connecting to the control ring. When you connect to your database at .database.windows.net, it hits that control ring and then connects to the secondary. The difference is for business critical is that you're connecting to an AG. Everything is stored on that local SSD, nothing stored in remote storage except for your backups. And a failover is going to happen just like an AG failover, and these are in sync. And then that we have 4 nodes, we can connect to the secondary and read it. That's really the big difference. If you're using DR, this simply uses distributed availability groups. So whether you're on GP or business critical, it recreates this infrastructure in a second region. And if you're using failover groups, Traffic Manager will route that traffic seamlessly, just like an availability group listener would. All right, so in summary, distributed systems are really hard. There's a lot of complex stuff going on in an availability group. Microsoft, but through AGs and failover clustering, abstract a lot of that complexity. But these are not trivial systems you're building when you're going into an AGA. It's really complex. Azure does simplify this process by having completely homogeneous infrastructure and owning the entire network. And oh yeah, by the way, they own the source code too, so that helps. So when there's problems, they can adjust the source code to better suit. I'm gonna blow past this references slide. This is on the GitHub page for this session. There's some really good stuff. This is pretty much what I use to build the session. And then my info, and I'll take questions from Matt.
Okay, so we have 13 of them. I know we've got, next session starts at 1:35 Eastern, so I'll kind of keep feeding these to you, but I'll probably stop here in a few minutes because we want to give Pam some time. And that session is going to be awesome as well. So let's dive into it. So this is about where you talked about kind of the failover levels. The question is, were those failover levels or failure condition levels, are they the same or different?
Wait, could you repeat that real quick? I didn't hear you for a second.
It says, were those failover levels or failure condition levels, are they the same or different?
I think that is the same. If I'm wrong, yell at me. I don't remember I know what you're talking about, but I'm missing if there are 2 terms.
Okay. Said, this is kind of a comment and a question rolled into one. Said, I read somewhere there's a 6th failure condition level as well. Can you shed any light on that?
I've never tried to set either 6 or 0, so I do not know.
Gotcha.
Or
Okay.
3.5.
Do you believe it's useful to change the TTL option for a listener DNS registration?
Very good question. And yes, I do. So TTL is time to live for a DNS setting. So where this is particularly useful is if you have a multi-subnet AG, where you have one node in say, I don't know, Los Angeles and another node in Mumbai. In that scenario, if you were ever planning to fail over to Mumbai, you would want to lower the DNS time to live. There's also a multi-subnet option, multi-subnet or all IPs register option that SQL Server configures by default, but it kind of depends on how you built your listener. If that's in place, that's something you should set. You should also instruct your developers to use the multi-subnet failover equals true option in their connection string so that both subnets are attempted to connect.
Good stuff. This one is pretty broad, so if you want to handle it somewhere else, that's fine, but I'll throw it out there. It says always on with availability zones. Is that a best option?
Always. So if you're not familiar, availability zones are this option in Azure where your workloads are just deployed to different Azure regions, or no, excuse me, the same Azure region, but different data centers within those regions. And it's a pretty good option. I've been implementing on my recent implementations. Availability zones aren't available in every Azure region yet, so it's not something you can always have. The one caveat to doing that is I read this blog post from Microsoft, but talking about SAP, which goes counter to everything I've ever elsewhere read about availability zones that said there isn't necessarily a latency guarantee and you should always test latency. The other not really issue, but thing you need to know with availability zones is you have to use a standard load balancer instead of a basic load balancer. And there's some level of cost that's pretty trivial. It's, I think, on the order of $20 or $30 a month for a standard load balancer, where a basic load balancer is free.
Okay. I know we're at time now. I'll keep giving you questions until Pam, Andrew, Anthony, or Mark yells at me and tells me to stop.
You're all good. You've got 50 minutes before Pam's session is ready to go. So yep, carry on.
Yeah, okay. I'm not going to yell at you. It's all good.
Okay. Does pausing or resuming the AG have the same impact / functionality as taking the AG role completely offline from Cluster Manager?
No, that's a good question there. Pausing the AG is something you can do on the secondary, and it will pause log transport to that secondary. Where this really tends to come into play is after you've had a bad failover scenario in or a failover with data loss, and the secondaries will come online paused, and you have to resume them. Depending on the nature of your data loss, you may have to reseed them. Failover with data loss is bad in a lot of ways, not just because you lose data. Recovering from it's really quite challenging as well. Taking the node offline in the AG would stop transport, but it would stop transport on every database in the AG too at that point.
Yeah. This anonymous person is asking, how do we check if SQL Server is doing parallel redo or not?
Good question. I believe it's logged in the SQL Server error log, because it is something you can turn off with trace flag. There were some bugs around performance with parallel redo very early in 2016 that mostly have been fixed. I think it's somewhere in the DMVs. I don't recall exactly which one, but it's one of the availability group DMVs that I believe shows it. But it's logged to the, if it's enabled at all, I think it's logged to the SQL Server error log, and you would see that on the secondary.
Okay, let me work my way through a couple more of these. Are there any tools that can simulate network latency or packet loss in a VMware/lab environment?
Yes, both VMware Fusion has it, and I know ESX has it, where you can reduce the network throughput to an individual NIC on a VM. I didn't do that for this because I was intending on having a remote secondary that I didn't have. But it's good because we were short on time anyway. Yeah, so that's controllable. That's a good way to simulate lag. Generally speaking, lag's okay if you're async. If you're asking questions about lag and you're talking about synchronous, you probably don't want to use synchronous replication.
Yeah. So here's a nice lightweight one. How do you handle flow control gate weights? Is there any way to determine how many messages a transaction will need?
That is a nice lightweight question. That will probably become a blog post. I don't know off the top of my head. I'd have to do some research on that.
Okay. Let's see. And I will send all of these to you because we still have some coming in, so we're definitely not going to get through all these. Here's one. Is there a way to increase the redo rate on a secondary replica? If data is generated on the primary at a higher rate than it can be redone on the secondary, then there's latency. Do we have control over the rate or speed at which logs are redone on the secondary?
Buy faster CPUs and storage, and more of them.
Just like racing, if you want things to go faster, spend much more money.
Yeah, and it's always just like in racing. It's not just a little bit more money; it's exponentially more money.
Yes, yeah. Let's see. When using read scale out, there's a small latency from a write to the primary node until the change is available to query on one of the secondaries. Do you have any numbers from customers on this latency? That's pretty open-ended.
Yeah, I mean, it's really kind of back to that last question. It's really going to depend on your hardware on the secondary, to an extent your network, because it depends if you're sync and async. I'm going to give what Jonathan Cahias always says, replication's honestly a better solution for read scale out than, and I curse myself for saying that because I really don't like replication, but it's a better solution for read scale out than availability groups are, especially if you're looking for that near real-time reporting. Most of the folks I know that have done that have been a little bit disappointed with who need not that use the secondary. I have a couple of customers that use readable secondaries extensively and they're fine with it. Like we kind of built a scale out data warehouse at a customer doing that, but it's kind of a traditional data warehouse with kind of standard ETL processes. The data is not changing in real time always. Yeah. But if you're in a situation where you're like looking at a transactional system and you want to read off a secondary and you want to know what the latest transactions are, that's not the best architecture. Using an AGS for the readable secondary is not the best architecture for that.
Yeah. Here's a good one. Any solutions for re-indexing big tables generating massive log records for AG databases? For log shipping, it says we can switch from foldable clogged and vice versa. So is there something similar here?
Very good question. And this is very much a problem throughout the history of availability groups, especially on the older 2012 and 2014 code that didn't work as well in the secondary. The best solution for this is 2017 plus, and it requires enterprise edition, and that's resumable index maintenance. Effectively, you rebuild your indexes in Windows, and alternating from when you're rebuilding your indexes, you back up the log and then resume rebuilding your indexes to control log growth. It's a little bit challenging to implement. I mean, challenging. You have to write a little bit of code and think about it. But that's really kind of a good way to do that. If you're not on one of those versions, there's not a great solution. And if you're on 2012 or 2014, it just sucks.
Okay, let's see. According to experience with HammerDB, what penalty percentage or whatever can be considered as normal for sync versus async?
Generally, and this is one of those things where it depends on the speed of your system. I've seen, and Bob Ward's got a good blog post on this from when 2016 came out. I've only seen, I think, 250 megabit per second throughput with sync AGs, and that was working on physical hardware with really fast storage and big physical hardware. It's just kind of the upper limit of the throughput. So if you like extrapolate from that, what you could get without that, it could be a pretty big penalty. If you're on smaller servers that have less overall throughput, it's not as big of a penalty because your max isn't that high. So it's very much dependent on hardware.
Indeed.
Like in a VM, you're probably talking a few percent, especially if like the VMs that I was using, which were close to each other, it's not going to be that big of a penalty. But if you're on like big physical boxes, it can be a pretty substantial penalty because you'll hit the upper limit of what the AG can do.
Okay, all right. Well, I'm not being yelled at, but I am told this would be a good time to wrap this up. So that was an awesome session. Thank you so much. I'll send you the rest of the questions in an email. We do have a handful left, and they'll be great seeds for blog posts or something else.
Yep, fantastic. Thank you very much, Joey. Okay, so we've got the speaker feedback link up on the screen there. So please do follow that link. You'll see another link to Joey's session and a link to the overall event feedback. Please leave us your thoughts. Let us know what you liked, what you didn't like, so we can make this better, and we'll pass on your comments to Joey as well. How's everyone doing? How's everyone's heads? Are they melted yet? So I had to refocus on a couple of slides Joey had there.
Yeah, he's got good eyes, huh? Are you guys ready for me to start sharing my screen?
Yes, actually, Mark, do you want to stop and we can hand control over to Pam?
Yeah, that works. Stop share. Okay, you should be able to do that now.
All right. Let's see here. There's a button. Oh, there it is. It's bright green. How did I miss that share screen button? Okay. This over here.
Okay, we can see a space background.
Brilliant.
That's the whole presentation.
Yeah. All right. We're just gonna do a 75-minute meditation. No, although that would be awesome.
Yeah, we can see your notebook there. Exploring
yes.
memory optimized.
Okay, so I assume the font looks good there. It's pretty big.
Yeah, that's good for me.
I've also got, you'll see command prompt, and you'll see perfmon in here, but that'll be later. So let me.
Yeah, all looks great.
Okay, good. Let me. Oh, okay, go right there. Okay. Minimize that. And let me go ahead and get my slide deck going. So I have been turning on, subtitles.
Yep, you can see them there.
Okay, so I don't know if Zoom has an option to do subtitles. I can turn it off because sometimes it's a little taxing on PowerPoint, but.
I actually don't know. Mark, do you know?
We had the question from an attendee earlier. It does not without like a third-party app. So yeah, please leave it on. That would be great.
Okay, I will. Yeah, I'll leave it on unless it starts causing problems. It's pretty good. There's a little bit of a delay, but
yeah,
it's pretty accurate. So
cool.
Yeah, we got about 4 minutes, so we're all good.
Okay.
All right, well, while we're waiting, then I would like to bring up some more events that we plan to host. They're kind of in the works right now, nothing definitive, but if there's any topics that people want more discussion on, and get a little more detail, be able to see some interaction between speakers and things like that, we're going to be hosting some events called Mixed Extents, where we're going to get it's going to be like a panel discussion, get a few people from the community, including ourselves, and just discuss a topic like index maintenance is one that came up pretty frequently in our conversations. So yeah, so any topics that anybody wants to see folks talk about, that they've got questions about, either give us some ideas in the when you're giving us the event feedback, comment on Slack, or even just shoot us an email at info@8kb.online.
Yep, absolutely. No, instead of a presentation style thing, we mixed extends to be more of a sort of roundtable discussion. So we might have a bunch of us in there just talking about maybe a contentious point in SQL Server, or maybe a point that has multiple different approaches, and we can see what people think and get chatting about it. So please, yes, as Mark said, absolutely give us some ideas, throw some stuff out there, and watch this space.
I'm going to talk about mixed extents in my presentation, actually. Good name.
Yeah, we've done well with the naming, we feel. We're very pleased with it.
Yeah, I'm liking it.
So if Andy Mallon's out there, Mixed Extents sounds like it'd be a good name for a cocktail too. Just saying.
We might have to get him involved in that event so he can post the event cocktail. I could get down to that.
Okay, so we've got about a minute to go by my watch. I'm going to turn my mic and camera off, and it's over to you, Pam.
All right, excellent. Should I do like a countdown, like T minus?
Absolutely.
Okay. Well, before we get started, so for the Q&A aspect, I'm generally one who likes to take questions in context, but it's a little hard to do that with virtual. So what I'll try to do is pause periodically and ask you if there's any questions in the Q&A. If I forget to do that and I just kind of keep rambling on and you see some questions that you think would be relevant to address in the moment, please do feel free to interrupt me if you like. I don't have a demo until the very end, so that's one of the reasons I'll try to pause and take those questions. Okay. Well, let's see. My laptop just switched to 1035, so I guess we'll go ahead and get started. So hi, everyone. My name is Pam LaHood, and I am a program manager on the SQL Server Enterprise team, the team formerly known as the Tiger team. Oh, gosh. You know, these subtitles are really funny because that's what people used to mistake my name as, Pamela Hood. It's not. It's Pam LaHood. That's so funny. Okay, anyway, I'm trying to ignore my subtitles. You can find me as SQL Goddess on Twitter. That's generally the best way to get me to answer questions for you. I'm happy to do that if you have follow-up questions. And also, I'll be hanging around on the Slack channel later, and I'll try to stay inside the Zoom meeting as much as possible today. So feel free to drop me additional questions after the fact. All right. So what are we going to talk about today? We are going to talk about TempDB. And if you've been a DBA, a SQL Server DBA for some time, I assume that you've had at least one problem with TempDB. If you haven't, you may just not know that you have. It's one of those very common pain points in SQL Server. And, you know, we heard Bob talking about memory, and we heard Aaron talking about statistics and bad plans. And the impact of what they said, I don't know if you guys caught it, was, okay, so we had to spill to TempDB. We didn't have enough memory, so we went to TempDB. TempDB is just one of these databases that gets beat up like crazy. So there are many issues that can happen with TempDB that can cause performance issues. So what we're going to talk about today is just a little introduction to what TempDB is and what it does. And then I'm going to give you some history. It's been a thorn in DBA's sides for a long time. I'm going to start with SQL 2000 and kind of walk through some of those problems. And the reason I'm giving that history is I really want you to understand what the underlying problems are so that you can understand the changes that we have made in 2019 and are making, and to understand, you know, when you might want to turn those on. And so then we'll round up with current best practices, how you should configure TempDB. And the last thing we'll do is a demo where I will show you the new feature in SQL Server 2019, which is memory optimized TempDB metadata. Okay, so let's talk about TempDB. First thing, what makes TempDB so special? Well, essentially, it is just a database. The structure of TempDB is the same as all of your user databases. The difference with TempDB is has the name suggests, it's for temporary storage. So nothing that gets written there is intended to be persisted. So it's recreated every time the server is restarted. So you restart SQL Server and we create a fresh copy of TempDB on startup with the original settings. And then also transactions are minimally logged. So we log transactions into the transaction log in order to be able to do a rollback. So if you want to roll back a transaction against a temp table, we need the transaction log to be able to do that. But unlike in your user databases, we don't ever have to do recovery. So when you restart SQL Server, your user databases have to go through a recovery process where they roll through the log, redo, undo. Since we are recreating TempDB from scratch, we don't have to do that. So we can minimally log everything. It's really just there for rollbacks. So it's in some ways a lighter touch than your user databases, but it still functions very much the same. What's very different, however, is the workload.
because it's used for temporary non-durable storage. Objects are being frequently created and destroyed, which is different than the usage patterns on most user databases. For most user databases, your schema is relatively fixed. You're not constantly creating and dropping tables, adding columns, removing columns, things like that, adding indexes, dropping indexes. For the most part, your schema is relatively stable in a user database. That is absolutely not true in TempDB. We are constantly creating and destroying objects. And if you're writing stored procedures, I bet you lots of you have stored procedures where you create a temp table and then you put an index on it. Maybe you add some data, put another index on it. There's lots of changes that are happening to TempDB. And it's very high concurrency. So there's only one TempDB on your instance, and you may have several different applications that connect to several different user databases, but they're all dumping temporary storage into that one TempDB. So there's generally high concurrency, especially if you have a heavy OLTP system where you have many threads doing all kinds of work. And then even worse, if you're already having resource contention on the system, which means even more things are dumping into TempDB, it gets a lot of traffic. So even though it's one of these kind of throwaway databases because it's temporary storage, it is actually very critical to performance. So as both Bob and Aaron said, when data can't fit in memory, it has to be stored in TempDB. We spill to TempDB. We're spilling to disk, things that we can't fit in memory. Those things should be in memory though. And if they were in memory, the access to them would be very fast. So if we have to spill to TempDB, when we go back to access that data, it's naturally going to be slower than if we accessed it from memory. So it's incredibly important that TempDB is as fast as possible because it's being used as overflow for things that should really be in memory. So you want to make sure it's on fast storage, and you want to make sure that it's optimized according to all of our best practices. And that's what we're going to talk about a little bit today. Okay. So what goes into TempDB? Well, of course, temp tables go into TempDB. So whenever you create a temporary table in a stored procedure or just in a regular batch, that's going to be stored in TempDB. Table variables are also stored in TempDB, and this is actually a common myth. Many folks think that table variables are in memory only. That's not actually true. Table variables are a little bit lighter weight than a temp table because of their scope, and they have a little bit less metadata, but they are actually stored in TempDB. So table variables go there as well. Row versions, so if you're using like snapshot isolation or read committed snapshot isolation, or even some things like triggers, DBCC checkDB, I think I actually even have a bubble for that. We have this row version store that's stored in TempDB. So we may be creating row versions in TempDB.
Hey Pam, sorry to interrupt you real quick. We're getting some clicking in your audio, and we're wondering if it might be related to the captioning you have turned on. Like maybe try turning it off for a minute and see if that helps.
Is it like this?
It's not the keystrokes. It's like actual clicking in the audio track.
It's clicking in the audio track. Okay,
Yeah.
Let me see if I can turn off that caption.
All right. Sorry about that.
Yeah, no, that's okay, because I do have a super clicky keyboard, so it could be that. But
Yeah.
If that doesn't help the audio, just let me know, because I can always switch to my headphones if it's something to do with my speakerphone.
Okay, we'll do.
Okay. So hash tables. So again, this is something that Aaron talked about. If we have hash operations or sort operations, anything in the query plan like that, that's going to spill to TempDB. So hash work tables, spools. If you see those spools in your query plans, triggers, I mentioned they use the row version store. Cursors, Bob talked a little bit about cursors. Depending on your cursor type, those can sometimes spill to TempDB. Sorts. Online index operations. So if you're doing your indexes with the online on keyword, then we're creating shadow copies in TempDB. DBCC checkDB I mentioned creates shadow copies in TempDB. Table valued functions. Statistics updates even put some stuff in TempDB. So you can see there's just a massive amount of stuff that gets dumped in TempDB. And in fact, I recall watching Brent Ozer do a presentation, I can't remember where it was, but he likened TempDB to the public toilet of SQL Server. So apologies for the crude humor, but it really is appropriate. Everything goes into TempDB. Okay. So let's start talking about the history of the performance issues that have come up with TempDB. And that'll sort of lead us into why we have some of the best practices that we have today for configuring TempDB. Before I move on, did the clicking go away?
Mostly, I'd say, or there's less of it at least.
There's less of it. Okay, it really might be the keyboard. I'll switch to the mouse and make sure it's not my keyboard. Okay, so let's start back with SQL Server 2000. So SQL Server 2000 was a period in time where a lot of things kind of started changing with not only with SQL Server, but with the IT environment in general. We started getting a lot larger servers. This is where we started shifting from 32-bit to 64-bit. We started getting a lot more cores. We started getting a lot more memory. And basically the concurrency against SQL Server databases really started to increase. And this is where we started seeing problems, excuse me, with TempDB performance. And so back in the SQL 2000 days, a KB article came out, 328551. It's the only KB article number I've ever memorized. I was a premier field engineer at this time, and I swear every customer I went to was having problems with TempDB. And it was manifesting itself as something called object allocation contention. I'm going to talk a little bit about that in a second. I have a slide for that. But this KB article, I just felt like I was rolling it out to every customer I visited. We were having to reconfigure TempDB, and it was kind of that first like indication that there was going to be a concurrency problem here that we needed to address. So this is where the advice came for trace flag 1118 and multiple files in your TempDB file group. And I'll talk about why that is in a moment. And there have been subsequent KB articles that have been released later, newer KB articles that talk more about configuring TempDB in general, but that was the first one. Okay, so let's talk about this object allocation contention. In order to talk about why this contention happens, we need to talk a little bit about how object allocation works in your databases in general. Now, keep in mind, TempDB is structured as a database like any of your user databases. So object allocation works the same way in TempDB as it works in any of your user databases. So this is actually analogous to what happens in a user database. It's just we do it more often in TempDB. So this is an example on the slide of a data file, tempdb.mdf. So this would be your primary data file. So, and the little table represents pages. So page 0 is a header page, and that's true for any data file, primary or secondary data files in SQL Server databases. And then page 1 is what's called a PFS page. PFS stands for page free space. And this is a page that contains information about the following, about 8,088 pages. And it says, how full are those pages? So if I need to add some information to a table, if I need to add a new object or a new page to an object, then I can look at the PFS page to see how full all these pages are and where can my data fit. So PFS is used anytime I really need to allocate space to an object. So after 8,088 pages, then there's another PFS page, it repeats. And so you will have multiple PFS pages in a given file, depending on how large the file is. So the larger the file is, the more PFS pages you'll have, and it's every 8,088 pages. So page number 2 is what's called a GAM page. And this is where the whole extent thing comes in. So GAM stands for Global Allocation Map. And the Global Allocation Map is used to track extents, particularly when you want to allocate a uniform extent. So I told you earlier, if you were hanging out during the break, that I was going to talk about mixed extents. So an extent in SQL Server is 8K pages, and that's usually the unit of data allocation. So if you have a table that's larger than 8 pages, anytime we allocate space to that table, we do a full extent. And so that's called a uniform extent because all 8 pages in that extent belong to that object. So anytime I want to allocate a uniform extent to an object, I go to the GAM page and it's a bitmap. So if the bit is 1, then that extent is available to be allocated. And if the bit is 0, then that extent is not available. So if I want to allocate the extent, I go through the GAM page, I find a 1, I flip it to a 0. Now that extent is allocated. And that's for uniform extents. And similar to the PFS page, the larger your file is, the more GAM pages you'll have. This one repeats every about 64,000 extents, then there'll be another GAM page. Okay, so that's page number 2, and that's for uniform extents. SGAM stands for Shared Global Allocation Map. And this one is used if I want to allocate space on a mixed extent. So mixed extents are where the pages, that, remember, an extent is 8K pages. So of the 8 pages, they may belong to different objects. So if I have an object that's less than 8 pages and I don't want to allocate a full extent, then I can allocate a single page on a mixed extent. And in order to do that, I would search through the SGAM looking for a 1. If it's a 1, it's then the extent is being used as a mixed extent and it has space available. And so I would find that extent, and then I would look for the corresponding PFS page to find the empty pages within that extent, and then I would allocate that page. So the SGAM is used in conjunction with the PFS page in order to allocate space on a mixed extent. And again, similar to the PFS and the GAM, after 64,000 extents, there's another SGAM page. Okay, so when you have object allocation in TempDB, and actually, like I said, this can happen in a user database too, although it's rare, you can start seeing contention on these pages. So particularly for TempDB, the one that you see often is the PFS page. So the way you can tell it's a PFS page is by looking at the wait resource when you have a page latch wait on a page in TempDB. And so we address these pages by database ID, which is the first number. So 2 is the database ID for TempDB. And then file ID, so this is file 1. And then the last one is the page number. So in this case, the PFS page is 1. So if you see waits on 211, then you're waiting on the PFS page. So the reason to have multiple files, and the reason we said to create multiple files in TempDB, is because if you have multiple files in the same file group, they all have the same structure. So they all have header pages, they all have PFS, GAM, and SGAM. So if we had some way of getting all the concurrent sessions that are all trying to allocate temp objects at the same time, if we can have them each hit a different file, then they would hit a different PFS page and a different SGAM page. So that's why we have the multiple files. And the other part of that best practice is those files need to be equally sized. The reason they need to be equally sized is that the way that SQL Server spreads out object allocations across files in the same file group is by using a proportional fill algorithm. So that means we're trying to keep the same percentage of free space in each file within the file group. So if all the files in the file group start at the same size and they stay the same size and they have the same amount of free space, then we're turning that proportional fill algorithm into a round robin algorithm because each subsequent allocation will hit the next file. And so that was the reason for that recommendation. Multiple files, and they all have to be equally sized, and that spreads the object allocations across all the files, and that allows us to get around this object allocation bottleneck. So that recommendation came out in SQL 2000, and it is absolutely still true today. I'm going to talk about some other improvements that might someday make that a moot point, but for today, this is absolutely still true. Multiple files equally sized, and that should help get around this. So back in 2000, you would see both PFS and SGAM contention. So the contention could be on 211 or 213. So remember that SGAM is for mixed extents. So the other side of that recommendation in 2000 was trace flag 1118. And what trace flag 1118 does is it turns off mixed extent allocations. So rather than if having a brand new object, we don't know whether it's going to be more than 8 pages, why should we waste a full extent? We said, forget it. That's an optimization that's not saving us anything. It would be much better to just allocate those 8 pages up front. Then I have to do fewer allocations and I don't have to hit that SGAM page as much. So that can also help. You may still see PFS contention, and then you may also see GAM contention at some point if you have really severe concurrency. But that's the reason for trace flag 1118. Okay, so that's object allocation, and that's where those recommendations came from back then. I think this is probably a good time to pause. Do we have any questions yet about what I've covered so far?
We do have a couple we can probably go through, or that might be able to be answered quickly at least. First one here, is TempDB always the same size, or can it be allocated more space as a configuration setting?
Oh, yes, of course, it can be. You can configure it. And in fact, We do recommend that you make it larger. The default size was 8 megabytes, which is usually too small. So we do recommend that you set it larger. Now, how large it needs to be, that is really based on your workload. There are no algorithms I can give you that says your database is this size, therefore TempDB should be this size. I can't really tell you that. The best way is to just kind of see how big TempDB grows and then configure it accordingly. Also, now when you set up SQL Server, we guide you through TempDB best practices. That came, I think it was 2016. I have it on one of my history slides as to when we introduced that. So now we will actually try to detect the environment to decide how many files you should have. And we try to kind of give you some better defaults. And we also give the ability to configure that during setup. You can also configure it. There's lots of blogs that'll tell you how to configure it. So yes, you can increase the size.
Awesome. Next one, are there any plans for having several TempDBs?
I'll talk about that one later.
Okay, that's an awesome question then. Could a huge TempDB of multiple terabytes slow down startup if you have slow storage? Would instant file initialization help in that case?
It could potentially slow down startup. So yes, instant file. I personally think instant file initialization is good on many levels. So I would definitely turn it on if you don't have any reason not to. But yeah, in potential.
Okay. Why is the limit set to 8,087 pages for page free space?
That's a really good question. I have no idea. That is before my time. But I might be able to ask some folks of SQL Server trivia and find out why it's 8,088 pages.
Okay.
I think it actually has to do with the PFS is a single page. It's one 8K page. So, and it's the reason why it's 64,000 extents is that's how many bits we have after the page header. So that's how many bits we can fit onto the page. So I'm sure with PFS, it's more than one bit to describe the fullness. So I'm sure that's how many bytes we had on a page. So
probably just math.
Yes, I think it's just math. I can't do that math in my head right now.
Me neither. Do you recommend TempDB to be twice the size of the largest index on the instance?
I don't know where that came from. Like I said, there's really no algorithm between database size and TempDB, because if you're never using TempDB storage, like if you don't create any temp tables and you don't have row versioning, you don't have all those things, then you might not use TempDB that much. So there aren't really any good algorithms that correlate database size or index size or anything. The only thing I can think where that might be something you want is if you're doing rebuild indexes and you're doing them online and or using sort in TempDB, then you may need it to be sized according to your index. But other than that, it's not really a correlation.
Okay, you want to do one more here?
Yeah, sure.
What command/DMV do you look at to see which pages page weights are actually waiting on?
That's an excellent question, and we will cover that later.
Awesome.
Cool. All right. So then I will move on from object allocation contention to another kind of contention that can happen in TempDB. This also started around the SQL 2000 timeframe, and that's metadata contention. So whenever you create an object, again, in a user database or in TempDB, there is metadata that needs to be recorded for that object. So what are the different columns that are in it? What are the data types in those columns? What is the name of the object? Where's the object located? All of those kinds of things are stored in system tables within the database. And there's actually several system tables. Right now, we've identified about 12 that are in critical path. That changes over time because as we add new features, like we add column store indexes and we add in-memory OLTP, as we add all these new features, we add metadata to support those new features. So over time, this actually changes. So around the SQL 2000 timeframe, we started also seeing this metadata contention. So what was happening was whenever you have, again, multiple threads all creating a table at the same time, not only can we potentially get object allocation contention, but we can get contention on the system tables that record the metadata about those temporary objects. So this also manifests as page latch weights, but the numbers will be different. They won't be PFS and GAM pages. They'll be other pages that belong to system objects. And this would happen whenever we were trying to insert into the metadata pages. So at this point, we realized, okay, we've got some contention issues that we really got to resolve in TempDB. So moving on from SQL 2000, we get to SQL 2005. This was a big change for SQL Server. I mean, rewriting of the engine, the introduction of SQL OS, there's so much that happened in 2005. What's relevant for this conversation is 2005 is where we introduced temp table caching. And the reason for temp table caching, oh, I'll wait for that. The reason for temp table caching was to get around that metadata contention. So the object allocation contention, you can get around that by reconfiguring tempdb and having the multiple files. And then the trace flag 1118. That works great for object allocation contention. And back then that got rid of it. But for the metadata contention, there's no configuration you can do that's going to help with that. So we started caching temp table objects. So when you cache a temp table object, when you delete that table, you don't actually drop the metadata. We keep a cache of all the temporary objects that are used through a stored procedure. And then we reuse the metadata for those objects when you call the same stored procedure and use the same temp table again. So with temp table caching, we have many fewer hits to the metadata, and we're able to alleviate some of that metadata contention. So the other thing we did in 2005 is dump a whole lot more stuff in there. That's where row versioning came out. That's when table variables came out. So we start increasing stuff going into tempdb. So then we fast forward to SQL Server 2014. Nothing super relevant for tempdb here, but that's where in-memory OLTP was released. And so we'll come back to that when I talk about the improvements that we did in 2019. And then fast forward to 2016. So 2016, we've had all these years where these best practice recommendations, they came out in 2000, but they were on you, the DBA, to make those changes. You had to know that tempdb was an issue, and you had to know how to fix that issue. So you had to find that KB article, or you had to have gone to a presentation at SQL Pass and someone told you, or you called Microsoft and you had the problem and they told you to reconfigure tempdb, but it wasn't the default configuration. So starting in 2016, we said, hey, this should be the default. So in 2016, we configured tempdb by default according to our own best practices. Trace flags 1117 and 1118 become the default. So I already talked about 1118. That's the one that turns off mixed extent allocations. Trace flag 1117 is one that where you have multiple files in the same file group. If one of them auto grows, they all auto grow at the same time. And so that's a way, if they start equally sized, you can keep them equally sized even with auto grow on. So that becomes the default for tempdb. And we add the configuration wizard into the setup wizard. So there's a page within the setup wizard that allows you to change tempdb configurations according to your own best practices or accept the defaults that we determine based on your system. Okay, so that was a big win in 2016. We also kept seeing this metadata contention, even with temp table caching. That helped for a while, but over time, we really started to do something more to address the metadata contention. So one of the things we introduced is optimistic latching for metadata for temp tables in 2016. Okay, so metadata contention in SQL. All right, so in SQL 2000, without temp table caching, we were seeing metadata contention on the insert. Now, with temp table caching in 2005, we start seeing over time as concurrency increases, now we start seeing metadata contention on the drop or the delete of temp tables. And so we have to, when we drop the object, we have to delete the metadata. So we keep it in the cache, and so we don't have to delete it normally. But if something gets invalidated in the cache, then we need to pull it out of the cache. And when we do that, we're deleting the metadata. And in order to do that, again, you have to latch the pages that are part of those tables, and that's where we start seeing contention. So in 2016, we introduced this optimistic latching. So the old latching algorithm, and I'm sorry, I don't have time to go too much into detail about latching, but just suffice to say, this is not IO, this is in-memory contention that happens, and it happens when you've got multiple threads that are trying to modify the same page in memory at the same time. So if I have objects that if I'm trying to drop temp objects and I have to delete the metadata, then I have all these threads that are all trying to hit the same system table at the same time, and I get latch contention there. So with the old latch contention, the old latching algorithm, the way I would do is I would first get an exclusive page latch. So once I have that exclusive page latch, then no one else can even read the page, let alone write to the page. So I get this exclusive page latch, and then I scan to see, are there any rows that I need to delete? Now, keep in mind, there's multiple tables here, and there could be lots of metadata. The more tables you have, the more metadata I have to scan through. So this can take a long time, especially, as I said, metadata increases over time. When we introduce new features, we add new metadata for those features. So this scan can actually start taking more and more time. And so you're holding that latch for a long time. It's an exclusive latch, so nobody else can either read or write. So this is what things start to back up. So if I find no rows, then I just let go of that exclusive latch. If I do find rows, then I have to delete those metadata rows, and then I can release the latch. So what we did was we switched this out to an optimized algorithm that's optimistic. So the first thing we do is acquire a shared page latch. So what we're doing here is we're saying, I'm not sure if I have to delete any metadata, so I'm going to be optimistic and say chances are there's nothing for me to delete here, so let me just get a shared latch. And then I do the scan to see if the metadata exists. If I find rows, then yes, I need to promote to an exclusive latch, delete the metadata, and then release the exclusive latch. But if I don't find any rows, then I can just release the shared latch. And so at least with the shared latch, I may be preventing people from updating the page, but everybody can read it. So this reduces some of the contention on the metadata. Okay. So that came in 2016. So fast forward to 2017. And this is actually when I joined the product group. We were still hadn't released 2019 yet, and we're still supporting 2017. And I started getting bombarded with all kinds of customer issues with TempDB because this metadata contention just would not go away. So more TempDB improvements came in the 2017 timeframe. So we made some PFS changes to the round robin algorithms for PFS. We changed the way we do metadata cleanup to make it asynchronous. And we did some more work around that latching, that optimistic latching. Okay. So SQL Server 2017 CU7, 2016 SP1 CU9, 2016 SP2 CU1, and 2014 SP3. In these versions, we released a new PFS allocation algorithm. So normally what would happen is I told you about that round robin algorithm. So every subsequent allocation would hit a new file. So first allocation would go to file 1, then file 2, then file 3, then file 4. And then the old way, we would go back to file 1, file 2, file 3, file 4, and we would do that until they filled up and we switched to the next range of PFS pages. But with this change, now we round robin across all the PFS pages within the file, not just across the files. So allocation 5 goes back to file 1, but to the second PFS range and subsequent files and PFS ranges. And so what we do is we now round robin across all the PFS pages in all the files. So we're not just round robining across files, we're round robining within the file as well. So you can add more files, you can make the files larger. All of that just adds more PFS pages and it reduces the likelihood of PFS contention. So that was introduced in these cumulative updates and service packs. Then back to that latching algorithm, we didn't actually make a change to the algorithm, but what we found was we had not modified all the places where we did the latching. So we found more opportunities to apply this optimized latching algorithm. So we did even more of this optimistic latching. These improvements came in 2017 CU7, 2016 SP1 CU9, 2016 SP2 CU1, okay? Now, here's the big one. Here's my most convoluted slide. I'm gonna walk through this step by step. I also have a blog about this, so if this gets confusing, you can refer back to my blog and I talk a lot more about this. Okay, so we really had to change the way we clean up metadata because we have the temp table caching, we're doing all these things to try to reduce this metadata contention, and we just keep pushing the bottleneck further out. So here's what we did in the CUs that you see on the slide here. First things first, a drop of a temp table, it becomes a no-op. And actually that happened earlier than 2017. I never got a clear answer on exactly where we made that a no-op, but basically when we introduced temp table caching, a drop became a no-op. So you might drop a temp table in your stored procedure. We don't actually drop anything because it's all cached. So a drop is a no-op, okay? So because the drop is no longer deleting metadata, keep in mind that this temp table cache, while it is metadata that's on disk, it's also an in-memory object. We actually have a cache object in memory that tracks all these temp tables that ties us to that metadata, that kind of points back to that metadata. So just like any other cache in SQL Server, and I think Bob mentioned this if you were here this morning for the first session on memory, there's a clock hand that sweeps, okay? So in the event of memory pressure, the clock hand starts sweeping through the temporary cache and moves things to a deleted list. So again, we don't delete them right away. We just say, okay, we've got memory pressure, we've got things in the cache, we're gonna evict them from the cache, put them onto a deleted list, and then we have a separate process that's gonna go and delete that metadata. Okay, so this background process fetches one item from the deleted list, and then it removes the corresponding metadata. Now keep in mind, there is more than one system table. It's not like just deleting one row from a system table. It is deleting potentially hundreds of rows from about 12 different system tables. There are actually more system tables, but those are the ones that get hit most commonly for your workload. So I take one item off the deleted list, one temp table off the deleted list, and then the background process deletes the metadata from all the system tables. So guess what happened? We again started getting contention on the delete, because if this single background thread can't keep up, again, if you have a super busy workload and you've got lots of temp tables and lots of active threads, then that background thread's not going to be able to keep up with the memory pressure. So we enlist helper threads. So these helper threads are basically any thread that needs to create a temp table actually has to clean up a temp table first. So not only do we have the background thread that's cleaning up items out of the metadata, but each thread that's creating a temp table is also deleting one thing, fetching one from the deleted list and deleting it from the metadata. So now, depending on how many cores you have and how many concurrent threads you have creating objects, you could potentially have a huge number of threads all trying to clean up. So obviously that just kind of shifted the problem down the line. So what we did in 2017 is we changed this from there being one helper thread per core potentially to one helper thread per NUMA node. And each helper thread fetches 64 objects from the deleted list and deletes those 64 objects from metadata. So rather than doing one at a time, we're now batching to 64 deletes at a time, and it's only one helper thread per NUMA node, not all the cores on the system, okay? So this should drastically reduce that contention on those system tables. And this is in 2017 CU5, 2014 SP3, 2016 SP1 CU8. Okay, now the presentation would end there if this fixed the problem, but obviously I'm still talking. I've still got a lot more time. So spoiler alert, this didn't completely fix the problem. We still had customers who had severe metadata contention, even with all this work we did. So we knew for 2019, we had to do something big. We had to do something much bigger than what we had already done. Everything we did here was incremental changes, things that we could do in cumulative updates and service packs. But we knew we needed to make like a really big change for 2019 in order to solve this for good. So that's what we're going to move on to. So before I move on, in fact, maybe I'll just leave the slide up. I think it's another good time to pause for Q&A. Do we have more questions?
Absolutely. So let's see here. Does collation matter? The question is what to do with TempDB when you have two or more databases with different collations?
So that's probably more of a question for Pedro because it kind of impacts your query plans. It impacts code because what can happen is you might have to collate if you're joining between temp table and another database that has a different collation. That can cause issues with your application. Performance-wise, as far as TempDB goes, I don't think that necessarily matters. I mean, not related to what we're talking about today, but it could definitely have an impact on your query plans, and it can actually cause errors where things don't match when they should. So that's where collation kind of comes in with TempDB.
Okay. Why are table variables faster in performance as compared to temp tables, even though both are created in TempDB?
That's actually a really good question. So why are table variables faster? There's a couple things about table variables, and they may not always be faster, but they for some purposes they are. One thing, as it relates to what we're talking about here, they have less metadata because they're not truly tables in the true sense of the word. There's not as much metadata recorded, so there's less metadata to clean up. So that's one aspect. The other aspect is the scope. So table variables are locally scoped. So like if you open Management Studio and you open a query window and you execute a query where you create a table variable, as soon as that query is done executing, that table variable goes away. So because of that, there's actually less locking and less logging that needs to happen. Because it's locally scoped like that, you can't roll it back. We don't roll back changes against a table variable. So we don't maintain that same transactional consistency of a table variable. So we're not logging it. We don't have as much locking because it's locally scoped. So there's less locking, less logging. It generates fewer recompiles depending on what version of SQL Server you're in. We don't recompile based on table variable changes. And the reason we don't have to do that is we just throw out a random estimation of how many rows are in that table variable. So we used to just assume one. I'm sorry, this is going off memory. I don't have it close in my head, but I think we used to assume one, and now we assume 100 rows. And again, that's another thing that's changed in later versions of SQL, where we introduced the ability to actually force recompiles for table variables. But that's another aspect where they may be faster because they don't trigger recompiles. That can be a bad thing and a good thing, as can the estimate, because again, there's no stats for those things. So that estimate may or may not be right.
Okay. As TempDB recreates after server reboot, do actual physical files get recreated, or does it just clear the TempDB object?
I'm not positive, but I believe it actually recreates the file, because if it goes back to the settings. So if TempDB has grown, so like for example, if you leave it at the default of 8 megabytes, it's going to grow over time. When we restart, it goes back to 8 megabytes. So I believe it recreates the whole file. I've never looked at what exactly it does. But for example, I don't know if it's deleting the file and then building it new, but it definitely goes back to that original setting. So it's effectively a new file.
Okay, maybe one more. Are there differences on the TempDB cleanup on bare metal versus virtual machines?
Are there differences in the TempDB cleanup on bare metal versus virtual machines? No. In fact, I don't know anything that's really different in SQL Server on bare metal versus virtual machines. There may be some things, but in general, SQL Server is kind of agnostic to the platform that it's running on, and which is why we can port it to Linux and containers and all those things, is that we're not really looking at the underlying architecture. We do in some cases, so there may be some, but I don't know of any off the top of my head, and certainly not the TempDB processing. Keep in mind that the NUMA node stuff, so if you're not presenting NUMA to the VM, and I'm not cognizant, I being SQL Server, I'm not cognizant of any NUMA configuration, then that could be different, just because SQL Server may not think it's on NUMA, or it may think it's on NUMA when it's not. That's the only really difference, and that's just has to do with how you configure NUMA settings in your VMs.
Do you want one more?
Sure. We'll do
Okay.
one more.
With SQL Server now performing round robin on all PFS within a file, is the recommendation still to have multiple TempDB files? If so, why?
Yes, so it can go either way, as in larger files or multiple files, but I sort of think of it as a two-dimensional array, and I don't know that one is better than another, but I think that the round robining across the files, it just, to me, I don't know, maybe it's just because I'm used to it, it makes more sense to me. So I still have the multiple files. Also, depending on how large you set it up front, it might take some time to grow, and then you won't have, like, maybe you won't have enough PFS pages, because the size of TempDB is not necessarily related to how many concurrent sessions you have, and making sure you have enough PFS pages is a factor of how many concurrent sessions you have, which is why the general recommendation is tied to the number of cores on the system. So I feel like having the multiple files just kind of allows you to tie that more to the number of cores on the system. And then if you need to adjust from there, you now have two knobs to adjust with, either adding more files, but then it's hard to manage, or growing the files. I hope that kind of makes sense. And also keep in mind that new round robin it's relatively new, and we haven't had a huge amount of experience to draw from with respect to best practices, but I generally just find having multiple files is still the best way to go. Okay.
Awesome.
Cool. All right, so we'll move on. Okay, so new and improved. So here we are moving into 2019. 2017 has been out there for a while. We've been battling TempDB battles in my team for a while, and we start making improvements. And as we're like working on 2019, we're finding even more contention points in TempDB in 2017. So we've talked about the table metadata, and the way that manifests, I mentioned to you, is page latch waits. So you'll know that you have metadata contention if you see sessions that are waiting for page latch, and the wait resource is a page from TempDB. So the database ID will be 2. If you have multiple files, it could be 2.1, 2.2, 2.3, depends on the file number. And then that last page number will be something other than 1, 2, or 3, which is the PFS, the GAM, and the SGAM pages. So that means if it's a different page number than 1, 2, or 3, then you can be pretty sure that it's metadata contention, it's system tables. Okay, so that's how the metadata contention manifests. Then we started finding, oh, well, there's a memory object, obviously, for the temp table cache. So we have this memory object that has all of your temp table objects in it, and it's a global object. And so we started getting CMEM thread waits on the temp table cache. Now, CMEM thread is tricky because that's just any kind of memory contention. There are many different memory objects. If you watched Bob's presentation, he talked about all the different kinds of caches that we have out there. And so what this is contention accessing that cache object in memory. So CMEM thread is not specific to TempDB. You get CMEM thread waits if there's contention on any cache within SQL Server. So it's super vague. The only way to know whether this is TempDB or not is probably to open a case with CSS and have them do a memory dump and figure out which one is in contention. So this one's a little tricky for you to find. If you're just because you're seeing CMEM thread waits doesn't necessarily mean it's temp table cache, but that's one of the things that could be happening. If you search for CMEM thread waits online, you'll find many different hot fixes and cumulative updates and service packs and things that address various problems with CMEM thread waits. This is something we've been doing, we've been addressing over time by whenever we find these hotspots, we partition the memory objects so that you get like 1 per NUMA node or 1 per core even. So that kind of gets around CMEM thread. So this is one of the many CMEM thread waits you can see. And then we also had some contention on the hash tables themselves that we use to track all of this, the objects in the cache. And so this manifested as SOS cache store spin lock waits. Again, I don't have enough time to go into detail on spin locks, but SOS cache store is another one of those waits that's a spin lock wait. So you won't see it as a wait type. This just is manifests as high CPU. But then if you looked at your spin lock stats, you would see this. And again, there's other problems that can cause SOS cache store spin lock waits. So do a search for that one. You'll find lots more hot fixes for that. But this one was specifically due to the temp table cache. Again, this is probably another call to CSS to diagnose this. But these are the different things that we started seeing. Again, as servers get bigger, workloads get more concurrency, we started seeing these problems. So we had a bunch of things we got to solve. So let's break it all down. We got object allocation contention, which is contention for the metadata pages that are used to manage space and allocate objects in the database. The way you would diagnose object allocation contention is to look for page latch waits on the PFS and the GAM pages. You shouldn't see that SGAM contention anymore because, like I said, trace flag 1118 is the default behavior now. So, but you can still see contention on GAM pages. The remedy for that, create multiple files. Metadata contention. So this is contention on the pages that belong to the system objects that track temp tables in TempDB. This you would diagnose by, again, looking for page latch contention, but the weights would be on pages other than the PFS and the GAM pages. So they would be in TempDB. They would start with 2 for database ID 2 for TempDB, but they would have different page numbers, okay? And then we've got that cache contention. So if you suspect you have heavy TempDB usage and you're seeing CMEM thread weights and SOS cache store spin lock weights, then there's a good chance it's TempDB related, but there are other things. So if you see that, the first thing you want to do is make sure you're on the latest version. You have the latest service pack, the latest cumulative update, because there's a lot of issues that manifest this way that we've addressed. So make sure you have all the latest. If it's still hanging around and you know you have heavy TempDB, it's a chance it's temp table cache contention. And like I said, you can always open a case with CSS to confirm. Okay, so that's the different types of TempDB contention that we've talked about. So what are your options today? First, configuration. Again, multiple equally sized files. I talked a little bit about that question that you can, in theory, grow them larger and get more PFS that way, but I still think multiple equally sized files. Start with the lesser of 1 per core or 8 and increase as needed. So keep in mind that this has to do with how many concurrent threads you have all creating temp objects at the same time. So if you have 128 cores in your system, do you really need 128 TempDB files? Maybe not. It really depends on whether you truly have 128 concurrent threads all creating temp objects at the same time. It's possible you do, so you might need that many, but most people, 8 is probably enough. So increase as needed. Whoops, I accidentally hit my keyboard. And when you increase files, let me put a few caveats out there. For whatever reason, we found that increasing in multiples of 4 seems to help. The other thing is, technically, you do not need to restart SQL Server in order to add TempDB files. You can add them on the fly. Here's the problem, though. Remember, we talked about the proportional fill algorithm versus the round robin algorithm. The only way we get the round robin algorithm is if the % of free space in each one of the files is the same. If you have 8 TempDB files and your system's been running for a while, those files are somewhat full. If you add 4 new files, those 4 new files will be empty. So we will hit those 4 new files heavier more often until they become the same amount full as the first 8 files, and then we'll start round robining across all 12. So you could actually make your problem worse temporarily until those new files fill up. So the best bet for you when you're adding files is to restart. And it's not, I mean, I know sometimes it's really hard to restart a SQL Server, so you can, in theory, just kind of wait for it to equalize across all the files. But if you can restart, that's better. If you can't restart, maybe think about adding more files than you normally would so that you're not hurting during that adjustment phase where everything's equalizing. Okay. You should enable trace flag 1117 and 1118 if you are on SQL Server 2014 or earlier. We did not make that the default behavior until 2016. So 2014 or earlier, make sure you enable those 2 trace flags. Okay, so that's the first thing. Code changes. So we haven't really talked about this yet, but for the metadata contention, the important thing is to make sure that we can leverage that temp table cache. And there are things that you can do in your code that would cause us to have to invalidate the cache and therefore not be able to reuse those. And then we don't get the benefit of the cache at all, right? So a couple things not to do. Do not alter temp tables after they have been created. So when you create them in a stored procedure, and then you put some data in there, and then you add an index, that actually invalidates the cache. We can't reuse that temp table from cache. So that usage pattern can lead to increased metadata contention. So what we recommend is that you move index creation to inline index creation syntax. That's that syntax that came in SQL 2014 when we introduced in-memory OLTP. we introduced the ability to create indexes in line with the table create statement. So we recommend that you do that. I know that some people may be concerned that then inserting data is slightly slower because you're inserting into a table that has indexes. My argument to you is that it's probably not as bad as the metadata contention you're going to get by not being able to leverage temp table caching. So that's my recommendation, is to do index statements in line. Do not truncate temp tables, only because, I mean, if you can avoid it, I know sometimes for your application you might have to do that, but try not to do it if you can avoid it, because it's a metadata operation. So it's just one more thing that's hitting metadata. And then avoid using temp tables inside ad hoc batches. We can't cache temp tables that are created in an ad hoc batch. We only can cache temp tables that are created in a stored procedure. So if you want to be able to leverage that caching, then you need to be using stored procedures. So if you need to create a temp table, make sure it's a stored procedure and not an ad hoc batch if you can. And then the last thing is, what version of SQL are you running? So ensure that you are on the latest service pack and the latest cumulative update. I threw out a whole bunch of changes we made. All of those were made in market, in CUs, in service packs. So whatever version of SQL Server you're on, please make sure that you are on the latest service pack or cumulative update to take advantage of all those improvements. And then the very last thing is, if you've done all of that and you're still having temp table contention, and there are people out there that do, then consider upgrading to 2019, because we made a lot of changes. Okay, so I think I've got 20 minutes left.
It is now 1:30 Central, and you're good till 1:50. So you got 20 minutes. Yes.
Perfect. Okay, good. Okay, so let's talk about where we're going. Actually, maybe I should pause for more questions before we do that. Just maybe just 2 or 3 questions if we have more.
Sure. Can you monitor for these contention types in TempDB using X events?
Can you monitor for them using X events? Not necessarily I mean, you can monitor weights, right? So you can monitor for weight events. But that's no different than any other weights. You just have to look for them specifically. We are actually introducing some, we may be introducing some more monitoring. I'm not sure, what's going to happen with X events as we move forward with these changes, but there's not anything that's like super specific to temp tables in X events that I can think of. There may be some caching events, I don't know off the top of my head, but most of them are really just telling whether we cached something or didn't cache something. They're not going to necessarily tell you whether there was waiting. So usually monitoring at the session level, and that's what I'm going to show in the demo, that's probably going to be more effective than X events.
Okay, and here's one more. Is there a condition when you have too many TempDB data files?
So can you have too many TempDB data files? Generally, no, because you're doing small things, but there can be some issues if you have large objects in TempDB. So if you're creating very large objects, now instead of having concurrent scans, like let's say I have to scan one of those large temp tables, I have to do it across files. So there may be some trade-offs there, but for most of the workloads I've seen, it's beneficial to have the multiple files.
Excellent.
Okay, so let's keep going, and then I'll take more questions at the end. All right, so some things that we consider doing. How are we going to fix all this stuff, right? So one person asked, did we consider having multiple TempDBs on the system, say 1 TempDB per user database? Of course, we considered it. However, the problem is you can have this TempDB problem even if there's only 1 database on the system. So even if there's 1 giant database, if there's a lot of concurrent sessions, you can still get this TempDB contention. So creating multiple TempDBs wouldn't necessarily solve the problem. So we thought about it, but in this case, for the metadata contention, we said, no, that's not really going to happen. Now, there may be other reasons for creating multiple TempDBs, like, for example, if we wanted to do like containment, like application containment, that might be, for security reasons, things like that. So there are other reasons that there may be a good idea to have multiple TempDBs, but not for these performance reasons. So I'm not going to say it's completely off the table, but in this case, we considered it, and it wasn't really, we didn't feel it was a long-term solution for this particular problem. So other considerations, can we just put tempdb in memory completely? The answer to that question is not using in-memory OLTP the way it is today, because in-memory OLTP is meant for a very specific workload pattern. It doesn't support all the data types and all the T-SQL surface area, and the data structures are very different. And it's meant to address, performance patterns that are specific to concurrency, but it wouldn't meet all the needs of tempdb. So we can't completely convert tempdb into an in-memory database. So what did we do? Okay, so here are all of the tempdb related enhancements in SQL Server 2019. And I say related because not all of them actually directly have to do with tempdb. So the first thing we did is introduce some new monitoring. So we have this new page cracker that allows you to quickly and easily diagnose this contention by enabling you to see what's on those pages that you're seeing contention on. Can you see whether they're metadata pages or not? So there is a new dynamic management function called DMDB page info. And this loosely replaces DBCC page. So normally, in order to see if you had a page number that was in your wait resource and you weren't sure what was on that page, you would have to use DBCC page to dump out that page and then look at the header and see what's in it. The problem is DBCC page, you have to be an admin to use it. And the results that come back are not they're not in tabular. Well, you can do it in tabular format, but it's hard to kind of build that into a script and join to other views. So we added DMDB page info to be able to do that, to get the header of the page and to determine what type of page that is and what object that page belongs to, which is the relevant information here when you're troubleshooting page related waits. So DMDB page info is the new function. And then we have something else called page res cracker, which is a system function that goes along with that. The reason for that is DMDB page info takes 4 parameters. It takes the database ID, the file ID, the page number, and then it's got a mode parameter that says, how much information are we going to return. But if you're looking at like DMExec requests, for example, or sys processes or something like that, the format of the wait resource is not in the right format for us to take it and do a direct join to page info. So we added this page resource. So anytime you've got a page related wait, be it a page lock, a page latch, page IO latch, anything like that, there'll be this page resource column that was added to, we added it to DMExec requests and sys processes. And you can use this page res cracker to separate out that page resource into the various parameters that DMDB page info needs. And then you can feed that into DMDB page info and you can create a script with cross applies to surface this information. That's what I'm going to show you in the demo. Okay, so that was introduced in 2019. The other thing that you may have heard about is accelerated database recovery. So this is a recovery related thing that makes transactions roll back instantaneously and it makes recovery happen super fast. Why am I talking about that here? Because this leverages a new feature called the persistent version store. So rather than storing row versions in tempdb, when you turn on ADR, we start storing row versions in the user database itself. So using persistent version store, we can actually take some of that load off tempdb. Okay. Now, of course, we're taking the load off tempdb, we're putting it back in the user database. So one of the things they found was that they were starting to get PFS waits in your user databases. So we also implemented concurrent PFS updates. So the way this works is, you remember, in order to update a PFS page, we have to get an update latch or an exclusive latch. It's an update latch. UP is usually where you see the contention. So with this concurrent PFS updates change, and this is on by default in SQL Server 2019, whether or not you have ADR enabled, you have concurrent PFS updates. What this does is, instead of getting a latch, we're able to manage the concurrency at the CPU level using something called an interlocked operation. So what we've done is move the concurrency management, the synchronization, down to a lower level, and no more latch waits. So you should never see a latch wait on PFS in 2019 or later, because we now have concurrent PFS updates. That being said, we don't have concurrent GAM updates. So you could still have contention on the GAM pages. And in fact, we saw this sometimes when we enable our memory optimized tempdb, we found that the next bottleneck might be GAM pages. So you do still need to have multiple files. we haven't gotten rid of that yet, even with the concurrent PFS updates because of the GAM contention. So still need multiple files. And then we made some temp table cache improvements. So remember I told you about some of those caching issues where you can see SOS cache store weights and CMEM thread weights. We've made various improvements to the cache, like partitioning the memory object and kind of optimizing how we do cache lookup. So that's also on by default in SQL Server 2019. So no action required for you. You should see less of those weights. And then the last is the opt-in feature, which is memory optimized metadata tables. So memory optimized TempDB metadata. So what we did here was combine in-memory OLTP with the temp table metadata. So we took the system tables, the TempDB system tables, and we moved those into non-durable memory optimized tables. Because remember, TempDB is temporary. It gets dropped and recreated every time we restart SQL Server. So there's no reason for the metadata to be durable. It's all going to be thrown away. So we converted them all the 12 system tables that are involved in object tracking in TempDB. We moved those into memory optimized, non-durable memory optimized tables. We don't need a file group. We don't need a memory optimized file group for TempDB because it's non-durable. So all of it's in memory, no disk at all. And with memory optimized tables, there's no latching and no locking. So we were able to massively increase the concurrency against these metadata tables using that lock-free, latch-free data structures in memory optimized tables. Okay, so that's the big change that we made to TempDB in 2019. It is an opt-in feature. You need to turn this on, and unfortunately it does require a restart because we need to configure the DLLs for the memory optimized tables, and we need to just reconfigure TempDB. So it requires a restart. However, if you are having this metadata contention, it should alleviate it. Okay, so let me head over to the demo. And I think Bob dropped the hackathon name a few times. So internally we call this HK TempDB for hackathon. And one of the engineering managers who helped develop this coined the term hackathonize. So we hackathonize TempDB. So let's hackathonize. And of course, suddenly my VM connection went away. Right, that doesn't bode well. I really hope my demo machine didn't restart so I don't have to reset everything. Okay, good. Phew. All right, so we're going to start out in Azure Data Studio here. This is a notebook. I have this notebook online, so if you go, and I've uploaded a link in the 8KB GitHub that has a link to this notebook. So you can do this demo. All the scripts that I'm using are all there, so you can do this demo yourself. So what I have is an AdventureWorks. I'm just using trusty old AdventureWorks, and I've created a stored procedure that does a pretty common TempDB workload. So it just creates a temp table. It inserts some data into that temp table, basically some employee IDs, and then it does a more complicated query joining back to that temp table. So pretty common usage of temp table. So what I'm going to do is kick off a workload. So first I'm going to start some perfmon. Then I'm going to come over here and actually, first, before I do that, I better make sure that I have left this turned off. Okay, yeah, it's off, so we're good. So let's come here and here. Let's kick off the workload. Okay, so things you're going to see in perfmon. We can monitor page latch weights at a high level. So I can see that there are definitely some page latch weights happening. There's no indication whether or not those are TempDB related. I'm going to have to go directly into the DM exec request to get an idea of whether they're temp related or not. But this is just for illustration purposes. You can see I'm seeing a decent amount of page latch weights, and there's my batch requests per second, topping out under 300. We had a spike in the beginning, but then we're staying under 300. So let's come into management, or sorry, Azure Data Studio. And here is the query that I'm using to monitor. I'm just gonna run it first so that I'm sure to catch the contention. And here's all of the contention here. You can see I have tons of sessions all waiting on exclusive page latches, and the object that they're waiting on is the schema object. So that is one of those metadata tables, system tables in TempDB. Now here's the query. I'm looking at DM exec requests. I'm using that page res cracker to break up that page resource column. And then I'm cross applying that to the DMDB page info function using the various return results from the page res cracker. And that's what's giving me this header information. So for my page latches, that's my wait resource. And this is all coming from the header, the object name there. Okay. So that's what's showing me my page latch. So it's pretty clear. I've got like 93 sessions and they're all waiting on TempDB metadata. Okay. So let's see. And we are still running. Should be falling off. There we go. Okay, so it looks like we've finished up just a few page latch waits, all draining off, sessions draining off, and we're done. So I'm gonna pause that. Let's come back here. And it took about 1 minute and 53 seconds. Okay. So now what we're gonna do is turn on that TempDB metadata, the memory optimized metadata. And I can do that by using SP-configure or using an alter server configuration. But I actually just have a script that's going to do it. So I'm going to just Hacketimize. And that's also going to restart because remember, I mentioned that we do have to restart SQL Server in order for that to take effect. So I just turned that on. I restarted. And then I will come in here and we'll just make sure that that's turned on. Okay, so now you can see it's on. And then I can also check that through SP-configure just to make sure config and run are both the same. I'm just going to check real quick. I just want to make sure that everything's recovered. Okay, we are good to go. So I'm going to go ahead and start my perfmon again, and then run my workload. And let's see what's happening. Okay, so you should immediately notice that batch requests per second is much higher than it was before. So we were topping out just under 300. Now we're topping out around 450 or so, 425, somewhere between there. So over 400. So our batch requests per second has gone up. The page latch waits have completely gone away. So no more page latch waits at all. And we can confirm that by coming back to Azure Data Studio and running our query again, our monitoring query. And you can see 0 rows affected. I have no page latch waits happening. They are gone, 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 gone. Okay. And so all I did was turn on the feature. I didn't make any changes to code. I didn't make any changes to the number of files or anything like that. I just turned it on, restarted SQL Server. I'm immediately seeing the results. No page latch waits. And you'll also see once this workload completes, which looks like it's winding down now. I went from 1 minute 53 seconds for the workload to 1 minute 12 seconds for the workload. So huge improvement in performance. Now, of course, your mileage may vary. If you're not hammering TempDB to the level that I'm hammering it here, then you may not see this. Also, I've got an 8-core machine here. So the more cores you have, the more likely you are to have this contention. So the bigger bang for your buck. But this is what the culmination of everything we've done in 2019. This is what you can get with the memory optimized TempDB metadata. Okay, so that was kind of quick. Sorry, because I know I'm running short on time. And I'll take questions in a minute. So just to review, so why is TempDB causing me pain? Because everything gets dumped into TempDB, and we've got object allocation contention, we've got metadata contention, and we're dealing with all of that. So what are we doing about it? We've got the 2019 improvements, memory optimized TempDB metadata, and those temp table caching improvements, as well as concurrent PFS updates. So this is all what you can look forward to in 2019. And if you find yourself, facing this kind of TempDB contention, then that's the upgrade path for you, as well as all the best practices we talked about. Okay, so I'll leave this slide up and then I'll open it up if there's questions.
Oh, we got a bunch of questions. So
yeah.
I'll just start asking, and when we need to stop, when you need to stop, or Argenis gets mad, we can I'll email you the rest.
Okay.
So,
yeah, and I can hang around in Slack too. So.
Okay. Is the transaction log more optimal for TempDB than for user databases? And they say something about redo not being required.
Yeah, so we minimally log transactions in TempDB. The log infrastructure is the same, so the log works the same. We just minimally log our transactions.
Okay. Are there any negatives with implementing memory optimized TempDB metadata?
Are there any negatives? One is you're obviously going to use a little bit more memory but keep in mind the tables themselves are not in memory. We haven't changed your temp tables at all. They are still on disk and they're the same. So the only thing that's in memory is the metadata itself, so the system tables. So it's a relatively small amount of memory, but depending on how many objects you have and how many columns those objects have and how many indexes they have, it could be bigger. So there's a risk there of increased memory usage. There are some orthogonality issues. So if you have memory optimized tables in your user databases, the way Hackathon works is you can't have a cross database transaction with a Hackathon table. So if you're querying in-memory OLTP in your user database, you won't also be able to query TempDB metadata in the same query. It's relatively rare that you would do that though. I mean, you'll be able to access your temp tables just fine. That's not going to cause a problem. But if you're doing something like select star from sysobjects or something like that in TempDB, that might not work. So that's one issue. Okay. Sorry, there's one more big issue. It doesn't work with column store indexes, so you won't be able to, if you turn this on, you won't be able to create column store indexes in TempDB. I think that's a relatively small use case for creating column store indexes in TempDB, but keep in mind that is one issue, and that's one of the reasons it's not on by default.
Interesting. Okay. Does enabling ADR mean that the space used for the version store is used in the actual user database instead of in TempDB?
Yes, it does. When you turn on ADR, we switch from using the row version store in TempDB to using the PVS, the persistent version store, in your user database. So if you have snapshot isolation or recommitted snapshot isolation, we start using the persistent version store rather than TempDB. So you are shifting those row versions into the user database.
Okay. Are there any plans into hackathonizing these object tables for other system or even user databases?
Yeah, so that's a good question. I've had only one customer ask me to do that because they have a unique usage pattern on their user databases. So we don't have any current plans, but I'm open to suggestions. Put something on feedback. So aka.ms/SQL feedback. If you have use cases for that, I'm open to hearing them, but no current plans.
Okay. With TempDB in memory, as there is no file, can this feature be turned off without jumping through hoops, unlike user databases where the only way to delete an in-memory file group is to drop the database?
Yes, it can. It can be turned on and off as you like. There's no artifacts that hang around.
Awesome. You mentioned moving some of the code changes way down to the CPU level. Are any of those low-level optimizations that are specific to one vendor's CPUs and not another vendor's CPUs due to vendor-specific instructions?
Yeah, that's a good question. No, it's just it's a type of operation that we use that's called an interlocked operation. If you want to do some searching online for interlocked operations, it's just a way to manage concurrency at the CPU level versus inside the engine itself with the latch level. So it's not specific to vendor.
Okay. Is target recovery time in seconds recommended for TempDB?
Oh, so basically turning indirect checkpoints on? Not necessarily. We don't really need checkpoints in TempDB. So we found like having indirect checkpoint is not usually a benefit. I think there's a blog out there. If you search for TempDB and indirect checkpoints, I think there's some advice on there on how to bypass that for TempDB. So no.
Okay. Do you still have all the advantages of SQL 29 TempDB if you lower the compatibility level?
That is a very good question. The answer is yes. Compatibility level is for gating things like query plans to make sure that query plan shape doesn't change. So T-SQL functionality, query plans, those things are gated by dbcompat. These kinds of features that are server level or instance level, these are not gated. So no matter what compatibility you have, you can take advantage of this. In fact, my AdventureWorks database is on like 2008 compatibility or something like that. So yes.
Okay. Awesome. How does SQL Server 2019's opt-in Hekaton TempDB interact with max server memory? Are there any trace flags to control high TempDB workload to use less RAM for TempDB?
Yeah, also a very good question. As with any other in-memory OLTP database, you have the ability to bind a resource governor group to that database. You can do the same thing for this. I don't show it because I was showing just very simple syntax, but the syntax also supports sending a user-defined resource pool. So if you want to bind a resource pool to TempDB, you can do that through the configuration, the alter server configuration, if you want to control the memory. We haven't seen anyone that really needs to do that yet because it's like I said, it's not a huge memory footprint, but it's a possibility if you need it or if you're concerned.
Awesome. Do all the user databases implement the same metadata schema of TempDB? And if so, could we assume that our user database will scale the same way that TempDB does?
Yes, we do have all the same metadata, which is one of the reasons why we have this problem. Because like I said, as we add new things, we add new metadata. We have to, we have to add them to TempDB too, even if we don't think anyone's going to create that kind of, like, for example, a temporal table. You're probably not going to create a temporal table in TempDB, but you can because we have the metadata support there. So it is the same. The thing is, with your user databases, you're usually not creating and destroying objects with that level of concurrency. There are a few niche workloads that might do that, but for the most part, you don't. So it would scale the same way. It's just the workloads usually don't do that.
Cool. Should we remove lines in our stored procedures to drop temp tables because of potential performance problems?
That's always a question. Even when you put the drop temp table in your stored procedure, it's still a no op on our part. So in this case, it should not cause a performance issue. It shouldn't matter. We just ignore it. But it's not necessary because we just ignore it. So don't run out and modify all your stored procedures today, but it's just kind of one of those things you don't actually have to do.
Nice. If we were to create a CTE, will that be stored in TempDB for the life cycle of the query?
I am not sure how long the temp table storage exists for CTEs. I don't know that whole workflow, the back end there. It may only be there for the amount of time I have to reference the CTE, but in theory, it could be there the entire time of the query. So I guess the true answer is I don't know.
Okay. If all TempDB files are on the same set of spindles, and they say not Flash, not SAN, what advantages are there for multiple files and not just having them all in one big file?
So the advantages are having the multiple object allocation pages for each file. This is not an IO optimization. This is all in-memory contention that happens because we only have one. If you have only one file, we have one PFS page and one GAM page. And so we're all contending. Now with 2017, we do start round robining within PFS pages within the file. But like I said, I just feel like that doesn't provide enough round robining. I think you do need both the multiple files. So just keep in mind, it has nothing to do with IO and how fast the IO is. It's all in memory. Those PFS and GAM pages are always in memory because they're hit so frequently.
All right, maybe we'll do one more here so Argenis has some time to get set up. I don't want to take away all his time. With the new memory optimized metadata, can we create indexes after the insert with no issues?
You can. I mean, this was designed to get around all those metadata issues, so you might not need those code changes. So, I mean, like I said, your mileage may vary, so I don't want to say guaranteed you won't need that, but this, yeah, in theory, hopefully this gets around all the metadata contention, no matter what your code looks like.
Okay, and Argenis says, keep going, I don't care. This is important stuff to talk about.
I'll get two more minutes.
Okay, that's fine. Yeah, we don't want to.
Myself need a bio break. So
There we go. Should TempDB be on a faster disk drive instead of database transaction log files?
Okay, I don't want to argue faster. They both need to be fast because both of them are in the critical path for query execution. If you're modifying data, your transaction does not commit until it flushes to the transaction log file. And if you're querying data and you have to spill to TempDB, your query needs to read from TempDB super fast. So I don't want to say one needs to be faster than the other. They both need to be fast.
We're going to talk a little bit about that, Pam, in my session.
Oh, you will? Oh, great. So I'll defer to
slightly, but yeah.
Cool.
Okay, and the final one, why are column store indexes not allowed with memory optimized TempDB?
I feel like, I think Aaron mentioned a little bit, the metadata for column store indexes is very different. So without going into too much detail on how column store indexes work, there are many things that would normally be a data data is tied really closely to how we access the objects themselves. And we have this whole different memory store for column store, and that metadata is a critical part of that. So getting this to work, if we were to actually hackathonize the column store metadata, it's just so intertwined there, it's a lot more work. So long story short is we just didn't have enough time to get it to work, but it's one of those things that we are continuing to work on.
Awesome. All right. Thank you so very, very much, Pam. This was
absolutely
a tremendous session here. And I do have some more questions that I will be emailing you separately if you want to answer them in your leisure. So,
Yep, absolutely fantastic job, Pam. Thank you very much. Bob, great job with the moderating as well. Thank you. Right, we are.
Stop sharing and
Yep,
I'll let you guys take over.
I will jump on and share my screen for a couple of minutes just so we can get the last schedule up because we are on to our last session of the day. Last but not least, with our Janice talking about tracing SQL Server I/O. One thing I want to do is I won't put these links up. What I'll do is go back to the speaker feedback link. Please leave us your feedback so that we can pass it on to Pam. And we've got a link there for the session feedback, the overall event feedback even, so that please leave us your feedback so that we can get some ideas of what you liked, what you didn't like, so that when we do this again, hopefully we will, we can improve on the event. Okay. How are we doing for time, Mark? We got a few minutes, so we're all good.
Yeah.
How's everybody's heads doing? Melted yet? It's been 4 amazingly. We said we wanted deep dive technical sessions, and well,
seriously, Argenis.
Somebody wanted it on Twitter, and I did it. Okay.
What's he done?
Look at his background.
Oh, nice. All right.
Popular request, man. I got it. You got it.
Oh my.
Oh.
Hey guys, it's Angela. Can you guys hear me?
Hey, Angela. Yes, we can hear you.
We can hear you, but very faintly.
Yeah, you're a little quiet.
A little quiet, yeah.
I wonder if I can adjust my microphone settings. Hold on.
All right.
So can I go try something before we start?
Yeah, what I'm going to do is stop sharing and you can take over.
Thank you. So I'm going to try this thing, which is.
How's the sound now? Is that any better?
Perfect. Yeah, that's great. Yep.
Okay. It was automatically adjusting, so it was making me quiet. Ooh.
Are those words, Argenis? I can't.
Right.
I am, for the record, I am not having a stroke.
Yikes.
Yeah, Randolph has described that as doctor handwriting, and I have to agree.
I think the problem is that Zoom doesn't really integrate very well with my Surface's stylus.
We had Joey Art, and now we have Argenis handwriting.
Yeah.
It's okay, people. You'll make it through.
E.
I was gonna write better, and then I shorted.
I thought you were writing Bette Midler.
That was Randolph.
Hey, all right, so since our Genesis is the last session of the day, do we need to really stay within our time frame, or?
Well, if we can, because over in Europe it's now 8 p.m. here, moving on to, and by the end of it, it'll be 9 p.m. So we can run over. We can run over for questions at the end, but for all the European folks, it's been a long day.
So I'm gonna make it perfectly clear. I'm not sure how long my presentation is going to take. So with that said,
we're just going to cut you off at the end. That's fine.
Why not, right? Because we can always do it again and do a part 2. And I mean, you guys have heard me talk about stuff. I can talk about storage for a really, really, really long time. And I don't think you want me talking about storage for a really long time. So point is, I'll try to be reasonable. And yeah, I think we should finish on time if we don't finish earlier. And if we don't, I promise that there'll be a sequel.
All right. Do you want any time warnings at all, or are you perfectly capable of reading a clock?
I'm fine. I think I got like
Man.
Ouch.
All right.
Just beep.
So we got about a minute to go. I'm going to turn my camera off, and it's over to you, Argenis.
All right.
Off you
So
go.
let me
Cheers,
share
man.
my screen for you. Let me just do this. Where's my share thingy? So you guys see this okay?
Yep, we can see it.
All right. So we're waiting one more minute then. Oh, wait, it's 12:05 already by my clock. So shall we get started then?
I say let's go.
Okay, so the first thing I'm going to do is change my video background to something that won't drive you nuts, right? Because that I'm gonna be nice about it.
Thank you.
So few things here, guys. I've been meaning to do something like this for a while, but there's a reason why I kept it, super, very specifically for a conference like this. Because the stuff that we talk about here is not something that you use every day, right? I don't expect you guys to use any of the concepts that I'm trying to show you or talk about here today. Because really this is more about the stack itself, right? It's more about, how SQL Server does I/O throughout, right? From the very application that SQL Server is, all the way down until what happens at the storage device level, right? And that's something that, it's a good knowledge to have, the skill sets and the things that you're required to have under your tool belt in order to do that troubleshooting of that stack efficiently on a daily basis, it takes a long time to kind of become comfortable with and kind of master. So from that point of view, I really want to do, a few demos, a lot of talking, a lot of getting you in the right mindset of thinking about things, because this is good knowledge to have, right? One of the biggest issues that I see out there as I work with my customers is that we don't know enough about how SQL Server does I/O. We don't know enough about, what happens when SQL does something, and the impact that the operations at the higher level in SQL Server can have on storage and storage in general. And, so overall, I feel that it's a very good discussion to have as a community. So I wanted to do a session, basically expanding on a session that I did earlier on this year that I keep delivering at SQL Saturdays and throughout, COVID, and I probably will continue to deliver that presentation throughout. Let's say it's that session in particular was called SQL Server Virtualization and I/O Patterns. And that session was recorded for Group Buy, right? The other community brand conference. And that's the link, okay? So if you're not a storage person at all, you don't know how SQL Server storage works at all, it's probably a good idea for you to go watch that first before we have this more in-depth conversation. And I'm totally fine if you guys just, hang out without paying more attention, or just drop and go watch that, and then we can have a chat on Twitter later about what you learned, and then you can come watch the recording for this. But I want you to really guys understand that This is a higher level conversation. I'm not going to go into details of what latency means and things like that. That is something that we discussed in that talk, and you should go watch it if you don't even understand what latency means, right? Because it's a super important conversation to have. So I also left in there a blog post that I think it reinforces what that talk discusses, right? What that video discusses, and then you can take it from there. You can come back and watch this presentation, because it'll actually get you thinking a little bit more about all the different moving parts and things like that. So with that said, about me, I am a vendor and I work in sales, and that's okay, right? Vendors can be technical, vendors can be community participants, and if you hate vendors, I'm sorry that you had a bad experience with vendors. I try not to be that vendor. But I'm also an architect, but please somebody remind me what architects do, because I don't know. Also a former data platform MVP, aka SQL Server MVP. I am a former vExpert. I am a former principal PM at the Tiger team at Microsoft and the SQL Server engineering team. I guess I'm a former MCM. So I'm a former a lot of things, but more importantly, I'm an ally. And I'm an ally for those who are underrepresented. So if you are one of those, I am happy to be your amplifier of your message. So please reach out to me. I am wearing black on purpose today. So the agenda, very important agenda, right? So what are we going to talk about here today? Tracing. Yeah, we're going to talk about tracing. Maybe we'll talk about tracing. How about we talk about tracing? But seriously, we're going to talk about how you trace things at the application level, right? And more specifically here, we're going to focus on SQL Server because that's what we do. We're going to trace things at the guest operating system level. Okay, that's also very important. Pretty much everyone runs your SQL Server on top of a hypervisor. So we're definitely going to look at the guest OS aspect of things. We will definitely chime in with how things work on bare metal, how things work on containers. Maybe we'll throw in a couple of things in there, here and there. We'll see. Hypervisor. So how do we trace things at the hypervisor level? So start thinking about the stack, right? There's an application that runs on top of a guest OS, that runs on top of a hypervisor. And there's maybe a storage network, right? If you're using a device like the ones that my employer sells, there's definitely a storage network, right? Because there's some communication between you and your storage array. But that's optional, right? If you're using DAS, like direct attached storage, you don't necessarily have a storage network. You have a bus though, and that bus, it's on itself can be a problem. And then finally, there's the storage device. So once you get to that, storage device at the very end, what happens, right? Like, what's the deal with that storage device? Do they all work the same? How do I even troubleshoot something when I don't even know how it works? I guess that's the larger question that we have to ask ourselves here. Anyway, I don't expect you guys to actually read this, but this is just a reminder. This comes from from that presentation that I linked earlier to, the group buy presentation. This is the stack, the storage stack within Windows as it was a few years ago. It hasn't changed very much. It may actually be a lot more complex. I don't expect you guys to go like squint at every single box and say, what the heck is that? No. I want you guys to really consider what happens even within a guest VM. All the crap that you have to go through just to place an IO. And I'm calling it crap. We know everything has a good function, right? Everything is in there for a reason. But guys, this is super complex, right? This sort of thing make people go like, really? Just to place an IO, I have to go through all these things? But you know what? Operating systems and applications like SQL Server are super fine-tuned to make sure that if you do have to issue a latency-sensitive IO, you can effectively place that IO and minimize the amount of interactions that you have for the entire stack all the way down. And that's very important to understand, because even though you can have a system with a lot of moving parts, you can indeed achieve great performance regardless of how many layers you have. And that's a conversation that's always resonating with people as you discuss VMs, because people have this thing in their head that a VM cannot possibly do have great performance. That is incorrect. A VM can always have great performance if you're doing the right things. So this is just, you know, a generic conversation about performance and I/O for applications. But I want you to understand, all of these things could be a problem. Like literally every single thing in here could be a problem. So how do you, can you even begin to understand all the things that you would have to master in order to troubleshoot absolutely everything in here? I don't think there is any one person in the world, maybe there's a few people, you know, at Microsoft that actually understand every single moving piece in here. Oh, by the way, there is something that is always wrong in here, that if you do it, you will get bad performance. That's an antivirus. If you run an antivirus, an anti-malware software, and you actually scan, let it crack open I/O against your database files, you will incur into latency. No question about that. So I also mentioned that in that previous talk that I had, but I want to reiterate it here because that's something that I hear a heck of a lot. Oh, I am installing this fancy, you know, anti-malware that some geniuses in Eastern Europe created. Great, that's awesome. Are you skipping your database files though? Because exactly what they do is inject themselves here in the file system driver on tfs.sys, and they crack open every single I/O that you issue against SQL Server. And then you find yourself in a situation where every I/O has free latency added to it. Yep, that's a problem, isn't it? Anyway, let's keep talking about things because I can hang up. I get hung up on this and I rant a lot about this slide, but that's because, you know, I see too many boxes and I start thinking, why is this so complex? Anyway, let's talk about tracing in the application or in SQL Server. So I want you guys to think about how SQL Server does I/O, right? There is a level 500 talk from Bob Ward from PASS, what is it, 2014, I believe, that is Inside SQL Server I/O. There is a YouTube video on that, I believe. If not, it's in your past recordings. Go watch that. It's a great talk. It's a brain melting talk. I think it's even more brain melting than this morning's talk because it's insane, right? It goes over every single aspect of SQL Server and I/O, and things haven't changed much since from a architecture and topology point of view of SQL Server. So that a lot of the concepts are literally exactly the same, even for SQL Server 2019, and even for SQL Server in the cloud, right? So even for Azure SQL Database, and you know, whatever fancy name they give to whatever PaaS service that runs the SQL Server engine underneath the hood. So I want you guys to go watch that if you're really into making your brain go mushy. It's a very good way of achieving that. However, there's a demo there that I'm gonna actually sort of kind of repeat because I want to show you guys pretty much the only way that you have of tracing I/O as it goes through Windows end to end, right? Like which pieces of the equation are hurting my I/O. There's literally not a whole left. You can attach a debugger to the kernel, right? So let's start with that. You can attach a debugger to Windows, and even using public symbols, you can start debugging Windows, right? You can start debugging the whole thing. And you know, and just SQL Server is just one of the applications that run on top of Windows, and you start, you know, digging into every instruction that is called, and every single function that is called, blah blah blah. That is the only way to really achieve true tracing of an I/O as it's issued from SQL Server all the way before it leaves the actual machine, be it virtual or physical, right? You can do that. Most people don't do that, right? Because it's so complex and there are so many moving parts. And guess what? You're gonna make your system go super slow as you debug it. So that's just the way it works. So let's look at a few things for capturing I/O within SQL Server. The first thing I'm going to do, so that we get that out of the way, I'm going to crack open the debugger. So here's WinDBG preview, and this is what I was referring to earlier on Twitter when I said that I was going to show preview software for my demos today. This is WinDBG preview, the Microsoft Store version of WinDBG. I actually like it better than the the regular version of WinDBG. That's why I'm using it. So this is kind of how it looks like. It's a little bit more graphical, a little bit more friendly. And, you know, like people love their command lines and their debuggers have to be as dumb as they possibly can get. I like graphical, but that's okay. Like I use SSMS a lot. That's okay. And so anyway, let's go ahead and attach. And let me show you the scenario first. Sorry. So we go here. This is my SQL Server 2019 instance. Okay, there isn't anything fancy about this. It's just got the latest CU. And thanks to Arvin and Microsoft that helped me figure out that I was doing a really stupid thing and I couldn't load my symbols yesterday. I was able to load my symbols, no problem. This is running the latest CU of 2019. I created a tiny a database called TinyDB, and then it created a table called dbo.small. And so this table is nothing, absolutely nothing fancy. Okay, it's got an ID and a filler column, and that filler column is, you know, it's the characters 8KB all in caps. So nothing fancy about it. Let me just actually make sure that we have that table there. We do. Okay, so here's what we're gonna do. I'm gonna insert into that table a default value. Okay, just, you know, it's an identity field, and for that ID, so it will grab a default value, whatever that is, and then I'm gonna, and whatever filler default I specified in there, it'll insert that. Okay, so I want to see how the IO goes through SQL Server on its own. Now, when we write even to a tiny table, so let's think about this for a second. When we write to a tiny table, the way that SQL Server does things is, you know, we have to follow the write ahead login protocol, right? So I'm not going to just write to the data file at once. SQL Server doesn't do that, right? What does write to the data file for us? Checkpoint and lazy writer, right? SQL Server first writes to the transaction log, and when it writes to the transaction log, a very important key proposition of writing to the transaction log is that it pushes the IO all the way through with write through, meaning that IO cannot land on a volatile or non-persistent or ephemeral area of storage. Okay, that's very important, because if you land that IO on a volatile area of storage, like a DRAM cache, for example, then it'll blow up, right? The moment that system goes down, whatever data you had in there is lost. When SQL Server tries to recover that database, it may potentially discover transaction log corruption, because there were some IOs that were supposed to make it into that particular storage device and never did, because it crashed before it was able to read from it. My point is, transaction log writes are especially important in SQL Server, right? All writes are really, but transaction log writes are very, very important. So what we're going to do here is just trace that transaction log write from this particular statement into SQL Server. And so it's important to understand, and I'll refer you to Bob's presentation from PASS a few years ago, that SQL Server actually uses asynchronous IO. Asynchronous IO means that it's not going to issue the IO and wait for that IO to come back before it actually moves on and does anything else, right? Your CPUs are way too fast, your memory is way too fast for them to be waiting for your storage device, which is awfully slow in the big scheme of things. So rather than doing that, SQL Server is just going to use one worker thread to place an asynchronous IO request that maybe another worker thread would actually pick up as completed, and it will give you the result from it, right? So in this case, we're just going to trace it, see what happens. But I'm also going to look at just one thing, transaction log flush, right? So I'm going to look at this particular function here on the SQL Server Log Manager that actually performs the log flush. You know, when we actually create records for the transaction log as part of the write-ahead login protocol. Those records have to be, they're first loaded into a log cache, and then they're eventually flushed down to storage. When they're flushed is when the IO actually takes place against the actual storage device. And at that point, you know, once that happens, we're going to be, SQL Server is going to be placing a call to Windows and saying, oh, hey, by the way, I need to go write to that file using the NT write file API, the Win32 API for write file. So first of all, we'll make sure that we have symbols. So we'll go check out the symbols in the debugger really quick. Where's my debugger? Here we go. Settings. Debugging settings, and my symbol path seems okay, so that's fine. I'll have to double check that again. And now I am going to go attached to a process. And this is where I like the preview version of WinDBG because it's pretty cool, right? So I see all my processes and I can sort things and I can just scroll down here and have a lot of crap running in this machine. Please ignore that. There's my SQL Server.exe, right? And if your name is Brent Tosar, you probably want to debug this other guy, SQL CEIP.exe, because that's the one that does the telemetry stuff. Okay, so attach to the SQL Server.exe process, right? And that's how you get your SQL Server loaded or attached to the debugger. So now I just want to make sure then that I list my modules loaded for SQL Server to make sure that everything's good, right? I see that effectively SQL Server has been loaded and I have my symbols working just fine, right? I am going to go set up my breakpoints. So I'm going to tell the debugger, hey, this is my function that I want you to break at. So I'll go paste that, right? I want SQL Server to break on that. Right now, I'm not logging anything to a transaction log, so that's great. I can just hit go. I'm sorry, not go, G. And then it continues to run, right? But now I want it to break at a different call within that same stack. But we're running, so we now have to trigger that previous breakpoint, right? How do we do that? We go into, and we actually run our statement that will trigger the log flush to happen, right? Hopefully everyone is following me on this. We have hit our breakpoint, right? Because we issued a write that actually incurs into writing transaction log records, and then SQL Server decides that it has to flush them, right? Because it has to every time, right? And now what we're gonna do is set another breakpoint within write file, because we are already within the context of, I can show you this, stack. We're sitting here in this particular stack. And so here's the thing, here are some things to kind of keep an eye on. Somebody started execution of something, a statement, some DML statement. Somebody started some transactions, recovery units. Oh, we have to actually harden the log. Oh, we have to wait until the transaction log is written. Oh, before you do that, you kind of have to log call the log flush. Okay, so that's where we're at. Now I'm gonna add the second breakpoint. That's the one on write file. When we call log flush, eventually those that flush from that area of memory that contains transaction log records has to be flushed down to my storage device. So for that, we call write file, right? So we're gonna cause a break on write file as well. When we hit go, we're gonna hit that breakpoint right away, right? Because that call to log flush was eventually going to go write file, and these things happen super fast. So we knew we were going to hit this particular call writing to the transaction log file. So if we look at the kernel stack with K, now you can see, right, that this is a different thread that is doing things. And this guy actually picked up the IO as completed, right? This is just how asynchronous IO on SQL Server happens, right? Somebody called the log write, and hey, that we had a log cache that was flushed. Their synchronous write actually took place, and here's the write file taking place on that, right? Fantastic. This is exactly how it goes. Okay, so here's where we are. We have traced SQL Server's request for an IO all the way down to the NT API or Win32 API call for write file. You can indeed dump the memory that refers to the actual transaction log write, meaning you have a log cache that you're forcing to be written down to disk, right? You're issuing an IO for that to be persisted. This is a very interesting thing, because with WinDBG and other debuggers, you can actually script things out. And you can do interesting things like saying, you know what, whenever I see a write file, I want it to see the contents of memory that are going to be written down for that particular write file, right? And I ran out of time preparing for that demo, so apologies for that. But you know what, that's actually a great exercise. If you like this stuff, go play with that. You can create a breakpoint on write file that actually goes and grabs from the memory address that has your buffer data that is going to be written down to your storage device, and then output that. You know who uses that kind of stuff? The malware investigators or the researchers that are looking for malware. You know why they use that sort of stuff? Because malware typically will go ahead and do like really nasty things, like create other files from scratch that are executables that will trigger something else to happen on your system. So that's one of the techniques that they use for researching executables out there. And some people in our community have actually gone through very lengthy exercises of reviewing instruction by instruction how SQL Server does things. By the way, if you must know, if you look at the registers, of particular interest is the RSP register, right? ESP register is the one that you care about. The EVP and the ESP registers are the ones that you care about for outputting the information that is about to be written to the file. Anyway, you can't, we're just tracing stuff at the SQL Server level. Okay, we could trace things at the operating system level. We could take a step back and just debug the entire OS like this and go call by call. What is SQL Server doing? What is the OS doing? And eventually the OS is going to call a primitive, a function, a routine, however you want to call it, on the actual interface to the storage device to perform that IO. So if you think about a physical host, well, you're going to be doing IO against, maybe you have an HBA because you're connected to a SAN, or maybe you have a PCIe bus and you have some DAS attached to the PCIe bus. Well, you're going to place a request that effectively leaves, the confines of CPU and memory complex into those storage devices. And you can trace that IO all the way down there. So before that IO leaves the confines of what we call the operating system and is issued against that storage device, there is something that's called store port. So with that, I'm going to pause. I'm going to detach here, and we'll go talk about store port. Store port, where is my store port? Oops, what did I do? Did I stop sharing? I think I did. Yes, I did. So give me just a second because I need to get this out of the way. So where's my store port thingy? There we go. Okay, so it's important for you guys to look at this. This is the stack, roughly, very simplified, or what I showed you earlier, okay? So there is, SQL Server sits here, your file system sits here, volume partitions, blah, blah, blah. And then there's the store port sits in here somewhere when you issue SCSI commands against the device. And you're typically, today, you're using one or two things. You're using a SCSI device or you're using an NVMe device. Both go through store port, okay? So in there, it doesn't say NVMe because it's a fairly new technology, but NVMe drives also go through this, or NVMe devices go through this as well. So we're basically tracing at the lowest level possible before the IO leaves Windows, the operating system, and is issued against the storage device. And that's how you measure latency as perceived by, right? And I want to stress this because a lot of people say, oh, my latency is high. Well, where is your latency high? That matters a heck of a lot because you know what? SQL Server has a perceived latency at the upper layer, right? It runs on top of an operating system that also has a perceived latency as it issues IO against a given device. That IO as issued is, that there's a receiving device that is actually serving that IO. Even that device itself has a perception of what latency is like, right? Because you requested an IO, I replied in this much time, but that's definitely not going to match how much SQL Server thinks that that device actually took. You see how this is a complex discussion? It is a very complex discussion, right? But there is no easy simplification of these things. You do need to understand, though, that latency is actually a series of different pieces of latency throughout a stack. And measuring each and every single one of those is important when you want to fully troubleshoot what happens end to end. So, I'm making it sound super complex. It is. But you know what? The reality is that most of the time, you don't have to go down that granular of a level. This is why you bring up the professionals, so people that are trained in troubleshooting these issues and help you figure out what's going on. Anyway, store port, how you actually log these things is basically through a single call to logman, which is part of what's called the Windows Performance Analyzer. Okay, you can just go get that, the Windows Performance Analyzer, and then at that point you'll get Logman and you'll get Xperf and other things you need to do, among other things, store port trace. Yeah, and store port trace is really utilizing the ETW infrastructure, the event tracing infrastructure that Windows has, which just so happens to be the exact same infrastructure that extended events use underneath the hood in SQL. Okay, because it's very efficient, it's very granular, as close to the code, as close to the real code as possible, with very minimal overhead from the watcher effect, right? So that's important to understand. The store port, problem with store port though, it's very efficient, how it captures information, but it generates a lot of information in the same sense. Because what you do with store port is you say, oh, I want to see what my performance is like against that particular SCSI device that sits on bus number blah, unit number blah, LUN number blah. And that can be a lot of IO, right? Just think about SQL just generating that tiny transaction log record. You think there's just one tiny thing? No, it could be a significant amount of bytes just for that particular tiny little write, right? So it's important to kind of get this in your heads, because these are operations that, even though they seem meager, when you do them by the millions, scalability becomes a problem, right? So anyway, store port, you create your trace, you let it capture, and then you convert your stuff, run this PowerShell script. I'll send you a link to this, don't worry about it. I may not be in the presentation, I'll fix it, it's fine. And then you end up with an analysis Excel like this, and there's even some Power BI stuff and pivot stuff that people have done for this, where filter by port, bus, and target, that kind of thing. You can do really interesting things. But the important part to highlight, what is store port good for? It is good for determining the latency as the IO leaves your box, leaves Windows, and leaves well, not Linux, it leaves Windows and is issued against that storage device. Windows performed the handoff, right? Windows is in the clear. Now, how long did that storage device actually take to complete that IO? That is what store port is very good for. Okay, so that's another way of tracing IO. I've done 2 thus far, right? There's more. So let's go check out another one here for that's based on extended events, and I'm sure that Aaron Stellato right now is celebrating this. It's a little extended event session that looks at, and by the way, a lot of our previous speakers have shown extended events. I just want to highlight the fact that extended events can also be used for tracing IO, because there are several events that may be in the debug channel, like Joey was mentioning earlier, that are not supposed to be used in production unless you're under the ever careful eye of Microsoft's support. Thing is, these are pretty safe to use, but they're going to generate a lot of data, and they can be invasive, and they can affect your performance. So be very careful, please, when you do this stuff. Don't say, oh, Arjun showed me how to debug things with extended events. Let me put this on my instance that's handling 40,000 batches per second. Don't do that. I mean, you guys are smarter than that. So please think about the children. Anyway, what we have here, the extended event session, I already created it here. It's issuing data against the string buffer. So if I go issue IO against small, right? And right now I'm disconnected, but if I issue that IO again, am I even on the right database here? Let's switch into TinyDB. The table is not there, it looks like. Okay, so we need to create it. So we create the table, and now we go insert. By the way, yes, I'm on a different VM right now. I was showing things on my computer. Now I'm showing things on my VM, because you know what? I couldn't get to install the WinDBG preview thing from the store into Windows Server 2019. Long conversation, not relevant. What I'm showing you here is that I'm about to do an insert into dbo.small, but I want to trace it with that extended events package. So what I do is show me live data, because it's not running. Okay, we'll kick it off. That's fine. We don't have to stop the session. It's not really that smart about knowing whether the session is running or not, is it? So we kick off the session. Yes, I'm doing things in SSMS. I don't have a script for it. Deal with it. And so I inserted my rows. I'm gonna go watch live data. Insert some more. There we go. So I inserted some stuff and then things happen, see? So transaction log records being generated, transaction log flush but to start, a file written, a file write complete, and a transaction log flush complete. So the file write written complete, it's pretty cool because you actually get a value called duration. And so this duration is actually in nanoseconds, if I'm not mistaken. That's why it's rounded up to 0. But that's ridiculous, right? Or rounded down to 0 in this case. That's pretty ridiculous. There is a way for you to actually peruse the data generated by this extended event session and get some more meaningful numbers about how long it actually took to perform that file write. And so you must be thinking, oh my God, this is awesome. I can tell exactly how much latency was perceived by SQL Server by doing this in extended events session. Didn't I just tell you not to do that? Okay, remember that I just told you to do that because I told you not to do that. It's an awful idea. If you set this up in a production environment, you're definitely going to start seeing all sorts of trouble. SQL Server does aggregate these things into what we call VFS, virtual file stats. Remember? Yes, that DMV is actually aggregating all of this data constantly. And so that's the perceived latency as seen by SQL Server when IO is issued for the different files that are involved in your system. It's kind of how it goes. All right, so extended events. That was what is it now? The third way of looking at things. Man, it's just crazy. So now let's look at one more because we're not done, right? Oh, by the way, store port. If you don't want to use Logman, there is a way for you to create a store port event trace session in Perfmod directly by just right-clicking here and saying new data collector set. I've already created one, and the way that it looks like, it's like this. You say provider Windows store port, and then you can define a filter, blah, 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 blah. Not gonna go into that. I'll send you that link that I sent you earlier, which is way easier, and your brain will actually thank you. Okay, so let's go. One more thing, and this is something that I've been doing for years, is showing people how to troubleshoot SQL Server with sysinternals tools, right? This is Procmon. Procmon does what it says. It monitors processes, but it does so much more than that, right? It actually digs into the different calls that your processes perform, and it tells you exactly how long they took, right? So it's a good thing that we could potentially just say, you know what, let me use this to trace how SQL Server does I/O. So if the process name is SQL servr.exe, then include, and if I hit apply, look at that. I'm only getting I/O from SQL Server over here. Registry accesses and file accesses from SQL Server and nothing else. That's fantastic. So if I say okay, and then I go look at all the stuff that it's filtering out, it's great, right? So now I can go into my insert into small and insert it, and now I go look, and hey, look at that. I got my writes here against the transaction log for TinyDB. Wow, look at that. So write file against TinyDB_log. It was a success. That right. Thank the Lord that it was a success. And then it also tells me a few interesting things about that I/O. The number one thing is the offset. What does that actually mean? Within that file itself, I needed to write this much into it, okay? And I also needed to write a given length, meaning I have this much data for you to write. And the I/O flags are also important. It says non-cached. You can't cache this I/O, dude, sorry. Write through, do not leave this I/O on an area of storage that's volatile or ephemeral or non-persistent, because I'm gonna be in trouble. And the priority of the I/O, which should always be normal, please don't go be changing the priority of I/O because it's bad things are gonna happen, okay? So why is the length 512 bytes though? You have to remember the table was called small for a reason. It's tiny, right? So when it's kind of cute, you want to generate records for it, the records themselves are going to be cute, right? The log records that you're actually going to be landing on that storage device are going to be pretty small. So, and when we get to that, you know, how much do I actually need to write? What is the smallest amount of data that I could possibly write against my storage device so that I can actually do non-cache and write-through operations? That is a disk sector, okay? And that's important to understand because you're gonna see, depending on the disk sector size, of your system different lengths for transaction log writes that are smaller in size. However, you guys know, if you don't know this already, go watch that previous presentation that I mentioned earlier. SQL Server can actually bundle multiple IOs into what's called in a single log flush, right? It doesn't have to actually do it record by record. It may bundle a bunch of records. It follows a certain logic that's actually documented in that blog post that refers to a blog post from a friend, blah, 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 long story. It's in there. You get the idea of how SQL Server behaves when it's actually doing a lot of transactions, because it doesn't really make sense for SQL Server to go do those many round trips for every single thing that I have to write to the transaction log. Even if you have the fastest storage in the universe, that IO against that storage device, it's incurring into latency. And latency is exactly what you're trying to minimize. So you bundle more IO into less IO requests, and you get better performance, right? So the maximum that SQL Server can do on a transaction log IO is 60 kilobytes. Somebody explained to me when I was working at Microsoft why it's 60 kilobytes. I already forgot, like whatever, it's 60 kilobytes. It's not really super important. That's the max that I would actually reach when it's doing IO against your storage device. By the way, if you're so interested, I can go dig in the archives of why that is. It's not very important in this conversation right now. My point is, I've already shown you one more way of looking at how SQL Server does IO. We debugged it. We looked at extended events. We looked at store port from the operating system point of view. And we also looked at, by the way, store port, yes, it can be an OS thing. So I'm kind of bundling guest OS tracing in this application tracing kind of thing. And I also show you procmon, which, showing you how SQL Server is performing IO, but the application and the operating system issuing IO themselves are like one thing, right? There's only so many delineations that you can establish between the two, because an operating system cannot do anything without the application or vice versa. Anyway, so where are we at? I think I should just stop this. I should pause. And are there any questions right now, guys? I'm sorry, I've been talking for a long time without stopping for questions.
Nope, just lots of comments about people's brains melting. So I guess you're doing a really good job.
I mean, you guys asked for a level 500 session, so here it is. I was actually like second guessing myself whether this was, and this is your fault, Aaron Stellato. I was second guessing myself on whether this was a level 500. Regardless, this is really what I wanted to convey, right? So we did application tracing in SQL Server. We did a little bit of tracing in the guest as well, right? Through procmon and through a store port. So now we know that there's quite a few ways of looking at how IO is performed within the guest OS. Yes, hopefully we're good there. Now, let's talk about the hypervisor, because this is always a great conversation for me. Think about, and I'm not going to talk about Hyper-V in specific because Hyper-V is used, but not as widely used as VMware. And in this case, I'm just going to go with, what the larger segment of the population uses in the world. Here's what happens with the hypervisor. Isn't the hypervisor taking IO from a truckload of VMs potentially running on top of it? Well, how do you think the hypervisor does that, right? The hypervisor takes incoming IO from a virtual device as presented to the guest operating system. That on its own is queuing IO in there, right? It's trying to go all the way through down to a physical device that's connected to your final storage device. Maybe there isn't such device. Maybe you're directly connected to a storage device through a bus in the case of DAS or whatever. Still a lot of things are happening just for IO to go through, right? So now think back to that one slide that I showed you at the beginning that had that stack for the operating system. There's the stack for the operating system, and here's a completely different stack for the hypervisor itself. Those two go together when you're performing IO. Exactly. So things get really complex when you're talking about troubleshooting and tracing things of the different layers, even on a hypervisor itself. So I'm gonna make it like real simple for you guys, and I'm gonna really abstract of how things work on VMware. So I'm just going to show you one thing because I also want to leave plenty of time for discussion or maybe for a strong drink after this. One thing that's specifically about VMware, using ESXtop to identify storage performance issues for ESX and ESXi. This article has been around for ages. And the reality is that there isn't a better tool for diagnosing what performance is like within VMware itself. So as you have a guest OS running on top of VMware, you're gonna crank open your trusty SSH session against your ESXi host. Yes, I said SSH session against a vSphere ESXi host. You are gonna do that. Maybe you won't do that, but the guy who's a VMware admin is gonna do that, right? And yes, they are going to have SSH enabled, because who doesn't? They're going to run ESXtop, right? That's a tool that allows you to see what's consuming resources within VMware itself. And yes, I know the font is small. My apologies. I don't know how I can make this much better. I can control one with zoom it, I guess, and I can show you that there's a bunch of things running. You probably don't care about this right now. But if you look at all the counters there, they're all like system and wait and idle and ready and things like that. So those are counters that are really important to understand, you know, where's my VM spending time on right now, right? Because you are going to see the different processes for the different VMs running in there, right? This is where things, again, get super ridiculously complex for VMware. You're going to try to understand exactly where your VM is and, you know, what time is spending doing what and that sort of thing. I'm just looking at I/O right now, right? Right now, I don't want to have this conversation about how your VM has less CPU than the other, right? We'll leave that for another day. I just want to know how my I/O is doing. And all you have to do within ESXtop to tell you how your I/O is doing is press the D button. Press the D key. And then at that point, boom, everything changes on ESXtop. And all of a sudden, you start seeing how the virtual HBAs that are connected to your storage array or your storage device are doing. How many reads are they doing? How many commands, SCSI commands are they sending down the path at that time? What the writes per second are, megabytes read per second, megabytes written per second. And then there's the DAVG, KAVG, and GAVG, and QAVG. I never, ever remember what these things mean because number one, my brain refuses to. And number two, I have a great blog post that I can point you to that explains all that stuff, right? So this is the blog post. It was written by my wonderful colleague, Cody Hosterman, who's just a walking encyclopedia of VMware and storage. And he literally tells you exactly all the different concepts that you need to understand when looking at latency metrics on ESX and ESXtop, okay? How much time did it actually take for my I/O to be completed after it left the HBA or the host bus adapter through my storage network into my storage device? And how much time did that I/O actually spend inside the ESXi kernel, and then the aggregate of the two? This stuff is interesting. You're not necessarily tracing I/O though. I'm sorry, I want to make that perfectly clear. You're not seeing every I/O go through. Right? You're not capturing every I/O as being sent down. For that, there's another thing called vSCSI stats that you can use for that purpose. And vSCSI stats is a very specific VMware thing that I'm not going to go into. I'm just going to briefly mention it because otherwise we'll literally be here forever talking about this stuff. Yes, vSCSI stats reminds me a lot of block trace, which is another tool used for tracing I/O on Linux subsystems. This is an extremely powerful tool that can actually capture every single I/O as sent down. Just, you know, do this reasonably while you use block trace on Linux systems. And yes, you can use it on a hypervisor using QEMU or whatever. As long as it's a Linux box, you can implement block trace. And there are even more efficient ways of tracing I/O in Linux these days using the Berkeley packet filter. So if you're a Linux enthusiast, and I'm sure that Nocentino must be going like, oh my God, you mentioned BPF. BPF is kind of like the ATW for Linux. It's super cool infrastructure baked into the Linux kernel that allows for very minimal observer effect or watcher effect overhead on whatever it is that you're looking at. So that's another kind of interesting angle on looking at things, how I can actually capture these IOs as they're performed against my storage device. You can go crazy with this. Like literally, you can capture every single I/O as it's being issued across the net, across the stack, as long as you're going through that Linux machine, right? We're assuming that a Linux machine is the hypervisor. On VMware, though, going back to what we were talking about on VMware, ESXtop gives you an idea of what the queues look like, and then vSCSI stats helps you not only validate that number, but also capture IOs as they're being issued. So you see how things get crazy, and security teams are like, their ears perk up when they start hearing about these things. That's because if you can capture IO, you can capture data. And you can do with that data whatever you want, can't you? So this is why you're seeing a lot more technologies that encrypt the data on the fly before it even leaves your guest operating system or your container even. These technologies, you're going to see more and more of those because it matters. You're trying to protect the data at every layer. You're trying to provide a comprehensive approach to security. And that means that not even a qualified system administrator will be able to see that data as it leaves your VM or your application even, right? Which is what SQL Server does with Always Encrypted. So that's something important to kind of keep in mind here. All of these things have security implications, big time security implications. Let's see. We talked about ESXtop. We talked about block trace. So we talked about tracing the hypervisor. Are we done with that topic though?
So, hey, Argentis, I do have a few questions here.
Okay, go ahead.
I think they popped up right before you started talking about hypervisor. So
that's okay. No worries. I can go back.
Okay. So how do you see the difference in if the IO is on NVMe or a slow disk?
So you can easily tell which one is an NVMe device in Windows by looking at the driver that you're using for that particular device. Because right now, Windows doesn't support the other mechanism for placing IO against NVMe devices, which is across the network, which is called NVMe over Fabrics. Windows doesn't support that yet, right? So we've been pushing the Windows team to support that. Linux has supported it for years now, but Windows hasn't come up with support for it yet. So on Windows, you can directly see if the NVMe driver is being used for a particular device, and hence being able to tell if you're using NVMe or you just have a regular SCSI device. In enterprise servers, it's unlikely that you'll be using anything other than those two, right? Because yes, you could have like IDE, but those are like really ancient technologies. They're not used for enterprises anymore. Good question though. Any other?
Yep. Do you have experience in using dtrace on Windows? Is it just using ETW? Do you see any advantage?
So it depends on what you're trying to troubleshoot. There isn't a silver bullet, right? This is why I didn't make a bunch of slides and show you guys, if you're doing this, use this. If you're doing this, use that. I want you guys to become familiar with the tools. I want you guys to be familiar a little bit with the stack, and then make your own decisions as to who you're going to go talk to if you actually have to troubleshoot this stuff. Because it's unlikely that you're going to be doing it yourselves. And if anything, before you start doing it yourself, you should start familiarizing yourself with how the tools operate, how they work, before, kind of committing crime in production.
That's just crazy talk. I don't know what you're talking about.
Exactly.
I got a couple more here for you. SQL Server recommends disks to be 64K allocation units with 1024 offsets. Is this still the case, or are there new schools of thought on this?
My favorite conversation in the universe, and I'm sure everyone listening to this must be like, Argentis, again, it's going to talk about this. Yes, I am. I was asked a question. So, number one thing that you have to remember, and this is again reiterated on those resources that I made available at the beginning, and that talk and that blog post. SQL Server's IO block size, IO request size never actually matches the allocation unit size, unless you're bringing a whole extent into the buffer pool. That's the only time when it actually matches 64K. Okay, so 64K is a general recommendation from Microsoft for formatting your NTFS volumes so that you have less allocation units for your database files. And less allocation units means less metadata for the file system. And less metadata for the file system means better performance, as long as that metadata doesn't actually affect allocations, on-the-fly allocations, like PFS, GAM, and SGAM do, right? If you guys watch that session from Pam, when your metadata actually affects that, you may need more metadata, which is the case of PFS, GAM, and SGAM, right? But now they wrote concurrent PFS updates, blah, 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 blah. Long story short, AUs, allocation units, in NTFS are not a metadata, an allocation impacting metadata, meaning a performance impacting metadata, a part of the file system. So my take on it, Microsoft has not come up with newer guidance on NTFS allocation unit sizes. I have, because I think if you have 2019 and later, you should go with the highest available allocation unit size for your database files only. Okay. If you have other kinds of files within the file system, you use file stream, file table, or hackathon checkpoint files, meaning in memory OLTP checkpoint files, stuff like that. They're going to have a different access pattern than your database files and your transaction log. And in that sense, I don't want to have you guys waste potentially tons of space, disk space, because if you make an AU bigger, then the file every file has to be at the very least that AU, right? So if you have a tiny file that's 2 kilobytes and your allocation unit size is 2 megs, you have effectively how much data that's empty space in your file system, and that's a waste. So do I recommend 2 megabytes? Well, yeah, if you're running a pure storage device, use 2 megabytes because you're running on top of me. I'll support that. If it run on top of anyone else, run at 64K because that's Microsoft recommendation still. So great question, by the way.
Okay, just a couple more here. It says didn't see duration in the Procmon for IO. Did they miss it? And when would you recommend using Procmon for troubleshooting?
So that's a great question. I don't think Procmon or maybe it does trace the duration. I can't remember exactly. I will point you guys to resources on that later. I believe there's a way to figure that out, but don't quote me on that. Actually, you know what? Let's just look at it. Why not? We're here. You don't have to make you guys wait. So we have that. It's right. It's my Procmon. That's my file, result detail. Select columns. Oh, look at that. Duration. Oh, wow. We got it. Thanks for the question. I've forgotten about that.
Awesome. All right.
Okay. All right. What else do we have?
Let's see. I've got a few more. Do you want to keep going with questions, or do you want to try and finish what you've got?
Let's keep going. People are interested. You know, they're going to fall asleep and their brains are going to turn to mush, and we're not going to be able to make them think anymore. Let's keep going.
All right. Another question. Do you have any experience with the resilient file system in combination with SQL Server?
Oh, yeah. Another religious question. So I have opinions. Use NTFS. Thank you.
Okay. Works for me.
So let me qualify that. REFS is a lot better than it used to be. And by that, I mean a heck of a lot better than it used to be. There are still some questionable things about REFS out there. Tons of things use it. Tons of things in Azure, tons of things on-prem. If you ask me or Janice who works at Pure Storage, just use NTFS, please. I'm not gonna not give you support if you run REFS. How about that? My recommendation, if you're running on top of us, run NTFS. If you're running on top of somebody else, go ask them what they think. This is when it comes down to value. Like, what value are you getting out of REFS? I don't know. Does it give you anything different? You just want to use it because it's nice and fancy and it's got it's not NTFS? I don't know. Like, if you ask me, just run SQL Server on top of NTFS. If you ask me, Microsoft should support NTFS on top of Linux. Why not? Different conversation. Sorry, Angela.
No, that's okay. Let's see. Would you recommend different allocation sizes for log files versus data files?
No, use the recommended for your system, whatever it is.
Okay. ext4 or XFS on Linux?
XFS all the way. ext4 is dead. Or Jenna said it here.
Okay. Let's see. This one's been in here for a while. It says that they've used Procmon in the past to monitor write durations for the transaction logs, but are there any?
Wait a second. Sorry, Angela. Before we keep going, I'm going to qualify that.
Okay.
There were still some bugs on XFS that they were figuring out, and by them I mean the Linux vendors were figuring out, and the community were figuring out the bugs in XFS. There may be some extreme situations where ext logs better than XFS for very extreme kind of workloads, right? Don't get hung up on that. Just go with XFS because that's a path forward. That's where the investments are being made right now by the Linux community. So my suggestion is just use XFS. Sorry that I went back. Go ahead.
Nope, that's okay. That's okay. So somebody's just wondering about if there are any downsides to using the Procmon tool.
Of course, you're creating overhead.
Okay.
I mean, listen, every single thing that you put on top of a system can actually derail the performance of that system. And so if you have Procmon running, even though it's built on top of ETW and all that, it's going to affect the performance of your system at scale. And it's actually got memory that backs all the events as they're being captured, and it may start dropping events and stuff like that. So it can be dangerous in prod. Be careful. Everything that I said today can be dangerous in prod, period. Right? I guess next time I do this presentation, I'm going to qualify it by don't do stupid unless you know exactly what you're doing.
Okay. Let's see. Is there any consideration for monitoring hypervisor volumes, but on hyperconverged infrastructure?
Oh, yeah, another religious discussion. So it depends on what you're talking about. If you're talking about Azure Stack HCI, you're literally running Hyper-V underneath the hood, and then the same concepts that I mentioned for troubleshooting, for tracing IO within the guest OS would apply to your Stack HCI. If you're talking about, I don't know, VMware's vSAN and Nutanix and stuff like that, I'm not familiar with all the intricacies of those things. They have to have tools, otherwise their support wouldn't be able to troubleshoot themselves. The question is, can you actually use them and get something meaningful out of them for you as a sysadmin or a database administrator? I don't know.
Okay. And then we've just got a comment from somebody who says that RFS doesn't have the limitation of the sparse files when you grow over 16 gig or so in snapshots. It's the only benefit that they've found.
There's a blog post on purestorage.com that we made a long time ago that actually talks about the large FRS, or the large file record segment. That's another feature of NTFS, another metadata thing for NTFS that you just change, and that way you don't have to deal with that sparse problem that you were dealing with in NTFS before. So yeah, there's an equivalent workaround in NTFS as well. Good point though. REFS does do away with that problem.
Okay. We are at time. We have no more questions. Did you want to continue going?
I don't know. What's the people saying? I can keep going because I think I have very little more to talk about. I have one more demo and then I'm done.
I was gonna say we've got a couple more questions that just popped up. As soon as we tell them that it's done, they ask.
Okay, I'm going to tell you about the demo that I was going to do, and then I'll answer the question. So we'll call it a day. Okay.
Okay, perfect.
Because people in Europe are getting tired and they want a beer, and I want a beer too, and blah blah blah. So the demo that I was going to do is about tracing the storage network. Okay, and the storage network is basically you have a host, right? Let me actually do this on share the screen from my Surface here really quick. So bear with me 1 second. I'm going to share the whiteboard. Okay, here we go. So you have your host here, whatever it is, a VM box or a bare metal box, doesn't matter. And here's your storage device. There is a network in between the two, right? How do I look at things in there? That is the thing that I want you guys to think about, right? There is a network in between my thing that generates IO and my actual storage device, right? So what's the, oh my God, somebody's asking a question about ZFS. Please don't get into that. So, sorry, got distracted by shiny objects. We want to trace the IO as it goes from the host to the storage device. How do we do that? It's a network, right? So in a network, you can sniff the network. So there are multiple ways of doing that. There's port mirroring if you're using a SAN, right, or whatever it is. There is some sort of capability for port mirroring where you can literally see the incoming IO as it's being issued from the host down to a storage array device. Totally can do that, no problem. If you're using iSCSI even, it becomes even easier because you can just use Wireshark right? To look at the incoming IO on your iSCSI box, which is exactly the demo I was going to show you. However, since we run out of time, we're going to go ahead and I'm going to put that demo on a blog post, or maybe these guys will invite me to talk again here on whatever the name of the next thing is, or what have you. But with that, I'll stop. Let's answer questions, and then we'll go for a beer.
All right, I got one more question for you here. Do you support, and by when they say you, I'm assuming they mean Pure. Do you support installing the SQL engine on any hypervisor instead of a physical machine for hosting half a petabyte size database?
Why are you asking me Pure specific questions in here? Let's take it offline, please. I don't want to answer Pure specific questions here.
Sure.
Yeah. Sorry. I mean, love you guys. Thanks for using my products or looking at them, but I don't want to spend time doing that. Sorry.
Fair enough. Oh, and then somebody was asking if you have the link to the blog post where you were just talking about earlier.
About the large FRS? Yes,
Yeah.
I will make sure that it gets added in here. It's
okay.
If you search blog.purestorage.com large FRS, you'll find it.
Okay. That's it.
Awesome.
Fantastic
Can we drink
stuff,
now?
mate.
So Argenis, I can't type questions into Q&A panel as a presenter, but can you describe what you just described? But can you talk about that in the context of Linux? Go.
What do you mean in the context of Linux? What are you talking about?
You talked all about Windows, man.
Oh, you just want me to focus on Linux now.
He wants to do the whole presentation again.
Let's do it all again for Linux.
I got a good answer for that, dude. Remember when I said I was going to do VMware over Hyper-V? That's kind of how I feel about Linux. I'm sorry. Everyone uses Windows for SQL Server right now. There's adoption of SQL Server on Linux, but it's not as massive as I guess everyone expected it. Love it. I think if you ask me, I'm a new enterprise. I want to deploy SQL Server for whatever reason. Would I look at Linux over Windows? Probably. Hey, I was the PM for SQL, so I know how it works, and I'm pretty comfortable about it. But I can tell you, the huge majority of the SQL servers that we see out there at Pure are all running on Windows.
Right.
There's a few exceptions to that rule, obviously, but we have significant. If we want to do this session again for Linux, I'm down. So put me down. We'll do it again.
You said earlier that if you were going to be invited back, you will absolutely be invited back. We asked you for a 500 level session. I would have said that was an insanity session. It was absolutely fantastic. Really enjoyed that session.
Appreciate it.
So we want to say thank you to all of the speakers today. We've had 5 amazing speakers delivering, let's be honest, some absolutely fantastic sessions. We've been absolutely blown away with the quality of them. I want to say thank you to all the moderators as well, helping out in the background, answering questions, and basically making mine, Mark's, and Anthony's life a heck of a lot easier putting this event on. So thank you so much to them. And we want to say thank you to all of you as well. There's no point in us putting an event on without you guys watching it. So thank you for attending. We really hope you've enjoyed, and we really hope that you've taken something away. If you're anything like me, you can't wait for the recordings to come out so that you can watch it again and sort of maybe not get quite so confused about. I got confused about twice through each session at some point, so I need to go back and watch them. So we will, we've got the recordings, we will edit them. Basically, we're not going to put any branding or anything like that on them. We're just going to cut them up because we're just one long Zoom meeting otherwise, and post them onto YouTube, and we'll ping everyone just to let you know when those are up so you can view them. They'll be on YouTube. And to the speakers, we will also ping you, and you can get a copy of your sessions as well. So on the screen there is the link to the feedback. Please leave feedback. Let us know what you liked, what you didn't like. We really want to know what you thought of this. It's the first time we've put this on, so we want to put this on again. We want to make it better for you. And just from me, thank you very much. Mark, Anthony, any comments?
No, I mean, it's just turned out to be a great event. And yeah, thanks everybody.
Anthony?
Oh, yes. Thank you, everyone. Thank you to the speakers. The quality of the sessions were just amazing. We appreciate all the effort you put into building those sessions and in delivering them to our community. And thanks to everyone for watching and participating. When the event launched and especially over the last few weeks, just seeing the acceleration in the numbers of people that wanted to participate. I mean, there were several thousand people that signed up, which I think is insane. So thank you all for participating.
Fantastic. Okay, and that's going to be it from us. We're going to sign off. Mark, you're the host.
Yep. All
We're
right.
going to say goodbye and good night.